Hello, hello, hello. Good morning, everyone. Hope you've had a great day yesterday and you're excited for today. We will start with how to grow your crypto startup. He went to talk with founders and members of some of the big protocols. And let's see what he has to tell us. Please welcome Mac Budkowski from Volt's FYI.
Hey everyone, did you like the breakfast or was it good enough? I guess some people are still eating, but I'm happy that some of you made it. I'm going to speak about distribution, which is basically a way to get your product in front of the users. But before I start, quick question. Please raise your hand if you ever used MetaMask. Okay, almost, I think everyone, okay. Phantom, who used Phantom ever? Okay, like 3/3. Zengo, whoever used Zengo wallet? Not a single person, I guess. And Valora? Okay, no one. And who here checked all 520 wallets recommended by Wallet Connect before they've chosen which wallet to use? Do we have any wallet nerds here? Probably not that hardcore, I guess. And have you checked every cola before you decided to drink Coca-Cola? Or was it more like, oh, it was on a shelf, maybe you saw an ad, maybe your mom bought you a Coca-Cola and you started drinking it? So, as I see, probably not, we don't have people who are that hardcore when it comes to research. But the thing is that we very often think that our users will be that hardcore, that if our product is superior, they will somehow find it. But you know, maybe there is the best wallet on earth, somewhere on this Wallet Connect 520 recommended wallets. I just never bothered to, dig in. And what I want to say is that best product doesn't always win. The fact that we had the most raised hands for MetaMask doesn't mean the MetaMask is best wallet. I hope we all agree on that. So what matters is your product even on a mental shelf when someone has a problem? And distribution is a way to build this mental shortcut between the problem and your product. So, okay, I'm thirsty, I will drink Coca-Cola. I want a wallet, and I have this list of maybe 3 to 5 wallets in my mind that I'm going to use. Like, think how you decided to use a wallet. Maybe it was MetaMask that was recommended on every app back in 2020. Maybe your friend used the wallet and said, oh, you should try Robbie, it's really cool. Maybe you saw an article, maybe someone on Twitter said it. But even I would say DappCon audience is pretty pro when it comes to crypto experience. Even we use these mental shortcuts. So now the question is, how do we even start building them for our users? So this is, as you can see in the top left corner, Uniswap demo. It's a slide from a demo at DEFCON 3 when Uniswap was shown by Karl Floersch to the audience. And it's one of the things that Hayden did to promote Uniswap. We often think about Uniswap as a technical breakthrough because it was technologically superior to other exchanges. It provided better prices, better liquidity, and so on. But we often forget that Hayden also did a lot of work to promote Uniswap. Uniswap, before launch, before even the product got launched, got presented at DEFCON 3. It got pitched to Vitalik, and Vitalik actually got very interested in that. It was presented at New York City Mesh, New York City Blockchain Week, AtCon, IFIS Hong Kong, Shanghai Blockchain Week, and pitched to countless people at Balance and MakerDAO offices. And Hayden also personally DM'd potential LPs. This is how much work he did pre-launch. Like, I don't know many founders today that do that much work. And it was 2018, which meant that, crypto was way quieter. It was way easier to get through the noise and get people's attention. So today, in 2026, the bar is way higher. Like, you need to do way more work that Hayden did to even get on the radar. And most people don't do it because they underestimate how much work should be done. So yeah, Uniswap not only had great tech, they also had great go-to-market. So does it mean that you should be like Hayden, just go to conferences and offices and pitch your product? Not really. Imagine that Hayden pitched his product here. This is European Blockchain Congress 2018 in Barcelona. As you can see, the audience doesn't look like typical Ethereum developers. People wear suits and they are like very elegant. They represent financial institutions, European Commission, and so on. If Hayden took the same strategy, let's pitch my product, and he went there, do you think he would succeed, or the efforts might not be that good? Well, probably he would not succeed. Not because the channel was wrong, not because conferences doesn't work, just because the market, the people he would be after, is wrong. So I sometimes get asked by crypto founders like, should we do KOLs, or should we do Twitter, should we do BD? I'm like, I don't know. Like, there are more things than just choosing a channel to get your distribution. And there are 4 elements. First of them is market. And what I want to say is that these boring fundamentals, like choosing the right market, can be more important than having a flashy campaign. If you have a flashy campaign targeted at wrong people, it just won't work. It's like very logical when you think about it. So to give you an example, this is a Coinbase website from 2013. Do you notice anything special about this website? Apart from the fact that it's old, because the design is 13 years old. I'm going to give you a clue. What is Coinbase for? You open this website, what is Coinbase a tool for? Yeah, kind of like a wallet, yeah? And what are they focused on?
Buying and selling.
Yeah, buying and selling Bitcoin. Actually, Bitcoin is mentioned 9 times on this small website. For the first 4 years, Coinbase was exclusively focused on Bitcoin. Not saying, oh, let's add every color coin to our website. They were only serving Bitcoin. And there were a few reasons for that. First of all, as we know, storing and buying Bitcoin was hard back then, especially since some exchanges had problems with storing securely your money. The second reason was because Bitcoin had a market cap of around $1 billion already. So even if they captured small percentage of that $1 billion, that could already be some substantial business for Coinbase. And is that they had a very unfair advantage. Most exchanges back then were not as professional and TradFi oriented as we have today. But Brian Armstrong had co-founder in Fred Ersam, who was an ex-Goldman Sachs trader. So he brought a lot of credibility to institutions and banks. And when during bear market, most exchanges got unbanked, Coinbase managed to keep these relationships and keep operating and keep growing. So they have chosen the right market. But do you think if Coinbase in 2013 decided, okay, we will be the #1 place on earth to buy Namecoin, or Litecoin, or Dogecoin, do you think they would be a $50 billion public company today? Probably not, because the market would be wrong. So, market is 50% of product market fit, and it's the more important 50%, yet most founders don't think about it at all. Most founders think, okay, how can I make my product great? But the first question is, who should you even serve with your product? Or even if your product is ready, how should you market it? Where should you market it? To which kind of people? So this is a screenshot from a viral video of a guy who's eating a watermelon in under 10 seconds. It's pretty funny. Recommend watching. But this is how I see founders who say, okay, I have a market, let's take it over. But it's like trying to eat a whole watermelon at once. It's just very hard. The proper way to eat a watermelon is to slice it and just eat it slice by slice. And these slices in this distribution speak are called segments. So you pick some part of the market and are focused on that. So Satoshi Nakamoto, people know him, but he didn't buy a Super Bowl ad to promote white paper. He didn't even share white paper on Hacker News that had a very sophisticated developer-centric audience. He sent it to a few thousand people on Cypherpunk mailing list because these people were the most likely to get engaged in the crazy, back then, idea of digital money. And that's the level of focus that you should have when you are launching your product. It could be these people hanging out on these free group chats, or people building DeFi apps that went to DappCon 2026. Otherwise, you, as a small startup, you wouldn't have enough money and power to capture attention of the whole market. So don't try to eat the whole market, slice it, and just try to do it side by side, because this is the way to do it. And you probably know these logos, so we get to the part when we talk about channels. So channels is this question should we do KOLs, conferences, Twitter, or whatever? So Ethereum, do you know how Ethereum have grown? Where did they get their first users? Bitcoin, yeah. Bitcoin Miami. Vitalik was actually an editor of Bitcoin magazine. Even the ETH race was denominated in Bitcoin. You could say it was a vampire attack if you want to be. And probably some Bitcoiners think that way, that's why they don't like us. But they were exclusively focused on capturing existing community. Tether, they have grown thanks to partnership with centralized exchanges, because these centralized exchanges got debanked and they needed dollar settlement. So Tether said, hey, we can give you dollar settlement with our stablecoin. Polymarket, well, Polymarket is all about the current thing, so they've grown through Twitter. Snapshot, they have grown through DAOs. So back in 2021, everyone was part of 7 DAOs, so you went to one DAO, they started using Snapshot, and you were like, oh, that's cool, so let's adopt it in another DAO where I'm in. Zora, they were, back in when they were focused on art, they were literally DMing people on Instagram and saying, hey, you do cool art, you can make money online, just sign up. Lido, they did DeFi integration. The biggest factor was when they started, they already had great liquidity pool between STETH and ETH on Curve. So it was you could feel that even if you get this weird new type of ETH, you can easily get back normal ETH. Echo, known as an app that was built by Kobe, it was mainly promoted through KOLs because they created these investment groups, they invited their friends, and that's how it has grown. Rainbow took a totally different approach. They created Rainbow Kit, which is basically developer tooling, and that's how they've grown. POAP, well, if you know Patricio and his famous red jacket, you know that it has grown through live onboarding people. So what I want to say is there is no playbook that always works. For one product, it's going to be Twitter. For one product, it's going to be developer tooling. So you need to experiment. And the way to do it is to brainstorm 3 channels that might work and has the highest chances of working, and then becoming a nerd of this channel. So if you choose Twitter for 1 month, you spend like 40 hours a week for 4 weeks just thinking about Twitter, learning about Twitter, tweeting threads, maybe short tweets, maybe memes, maybe videos, maybe DMing people, maybe being a reply guy. This is the way of dedication you need to have to actually test a channel. And once you do it, you see whether it worked. You see how much money did it cost, how much energy did it cost, did it bring some quality users? Can you scale this channel? Can you get another 1,000 users from that? Because if you focus, for example, on, okay, let's say get people from DappCon, there's like a few hundred of us. So if I need to onboard 10,000 users, it's just not enough. So I would need 10 DappCons or 10 conferences to get enough users. So this is a scene from Big Short, a famous scene, That's My Quant. And what Jared, who is pitching hedge fund here, does well is he does a thing that every founder should do whenever they're building distribution. Because, okay, you got the market, you sliced it, so you get a segment, you got a channel, but then the question is, what do you say to these users? And what Jared did there, he's like, okay, what these hedge fund guys need? Well, they need ways to make money. So here's the way to make money, short the housing market. Okay, then they ask, okay, does the math add up? And then there's this, that's my quant scene. Yes, the math adds up. Then they're like, okay, but how could we short it? And he says, oh, there's credit default swaps. So these are the questions that every user silently asks whenever they see your product. First is like, does it solve my problem? The second question is, can I trust that it's actually going to solve my problem? And the third one, does it meet the requirements I have for these kind of products? For example, sometimes someone has legal requirements, or maybe it needs to be an iOS app, not Android, and so on and so forth. So you need to answer these questions, whether it's your landing page, whether it's your blog post, whether it's your podcast, essay, whatever. It needs to be obvious that these questions are answered. So the good news is you only need one thing to work. Like Luke Skywalker in Star Wars, you need only one shot at the Death Star to win the, the fight for the galaxy. Same here. You can make 100 experiments that won't work, but if one works, it can bring you thousands, sometimes even millions of users and be a make or break for your startup. So yeah, that's the good news. And I'm about to end with two things. First, I only scratched the surface of it. There's a longer piece that I wrote, and Arman asked me to present this today based on this blog post. So I'm going to show you a QR code where you can find this blog post and get more deeper into this subject if you find it interesting. It's free, you can just scan it. The second thing is, since I am into testing channels, I decided that I'm going to test if conference channel works for us. So I'm going to show you a QR code that if you build a DeFi app, when there's any earn experience or borrow experience, so you interact with Aave, Morpho, Lido, Rocket Pool, whatever, you can use our API and get $50 of free credit. So if that's your thing, you can scan it. So yeah, the blog post is on the left. If you want, you can scan it and bookmark it for later. The API credit is on the right. The code for API credits is going to work until Friday, so you have 3 days. You can just make a picture and do the onboarding later. With blog post, it's the same. So yeah, thank you. And we have time for half a question, I guess.
We are very short on time, but really about on time for the next one. But if there's one short question. Well, maybe I don't see hands raised. No. Well, okay. Thank you so much, Mac. Okay, all right. I was expecting for the image, but here we go. Yeah, so the web as we know it is dying. Algorithms are choosing what we see. And so to talk a little bit about that, let's welcome Florian from Freedom Browser.
Thank you. Hi, everybody. I'm super excited to talk to you about Freedom Browser today. We're literally reinventing the web, and I couldn't be more excited to bring this new software to you. So the browser really has not changed for ages. Really, 1993, when the first modern browser was introduced to the world, where you could enter http:// some URL into the address bar, and it would render an HTML page. Well, that's literally what browsers still do today. They look more sophisticated, the web has really advanced, but the fundamental principle of how the browser works has stayed entirely unchanged. They still only speak really one protocol, which is HTTP. Now we use HTTPS, so it uses some transport layer encryption. And domains are resolved via the DNS system. And that's the same since the internet or the web, the modern web started. Now, here in the Web3 community, that's actually a problem. Because if I type vitalik.eth into Safari, Chrome, Brave, name any modern browser, it will actually send me to google.com and do a web search for what vitalik.eth might be. What it doesn't understand is that vitalik.eth is a new kind of domain, and it's hosted on a new kind of web. It doesn't do that. And that's the problem we want to solve. The problem behind this, the bigger political problem for our political economy and the web in general, is that the way that the web was built, unknowingly at the time, really perpetuates a structural power imbalance that disadvantages us as the user and gives all the power to the server operator, which is the platform. And now in 2026, all of us who are using modern browsers are nothing but consumers of platform capital. We're being surveilled, we're being profiled, our data is being sold and repackaged and resold, and none of the value stays with us and none of the control stays with us. But wait a second. Those of you who are around for some time might remember when Ethereum launched and this young genius boy was telling us that we're building this peer-to-peer web, that we're actually getting rid of the platforms, they're getting rid of the intermediaries. And if you look for old blog posts on the Ethereum.org blog, you can actually find schematics that explain exactly how this was supposed to work. That the internet back then, and unfortunately still today, has all the important business logic, the communications, user credentials, data logic on a server, aka the platform, and the user device is really just a dumb terminal that renders the stuff for you. And how in this new blockchain world that we're going into, the peer-to-peer world, the data logic, business logic would live on a blockchain, the user credentials would be stored as a self-sovereign identity on the user's device, and static files and communications could be hosted on something like Swarm, a fully peer-to-peer decentralized storage network. This is the vision from 2015. Well, those of you who remember Mist actually do remember that there was a sweet moment in time where this vision was being worked on. But for those of you who speak German, you might understand why calling it Mist was maybe a stupid idea. Because instead of DApp, we got crap, right? We're actually accessing the D-Web through gateways, Chrome extensions, and all kinds of shenanigans while not changing the elephant in the room, which is the fact that Google Chrome, Microsoft Edge, Apple Safari are not our friends, and they are not speaking our protocols, and they are not going to change that. You might say, hey, but Florian, for a beautiful moment in time, we extracted value by serving dApps over centralized gateways. And that's true. Some of us made insane fortunes on this broken stack that we've been calling the Web3 over the past decade. But what does crypto look now today? Well, this is the new face of crypto, and consumer crypto is all but dead, right? Look around you. This room is half empty. Well, we're going to change that today. We're shipping Freedom Browser. It's an entirely new browser. It's a software you can download right now on your computer and soon on your iPhone and Android phone. And this browser allows you to access the decentralized web the way it was meant to be. This is what it looks like. It already exists. Actually, I have it on my iPhone, but we haven't shipped it yet in the Apple App Store. So desktop is the way to go for you right now. And it looks kind of like Chrome. It actually uses a lot of the Chrome or Chromium code in the background, but we've entirely switched out the networking layer and other pieces of it in order to teach it the language of Web3. And so we're shipping the browser that this industry deserves and really should have had for over a decade. Here you can actually see it's a real screenshot of how Vitalik.eth has been loaded and fully resolved on my iPhone without any gateway. There's a trustless resolution of the domain name, and then there is a peer-to-peer node that is fetching the content behind the content hash that this ENS domain points to. And we really had to bring a lot of different technologies into one package to make this possible. It starts with trustless ENS resolution using zero-knowledge proofs, thanks to the Colibri team, who sits here in the audience and will give a talk after me. Trustless content resolution by running local nodes for IPFS, for Swarm, even Radical, which is another interesting Git-like protocol here, built here in Berlin. And through these trustless nodes, getting the content that you want to render. We're even allowing you to trustlessly publish to the D-Web. So it's not just a read situation, it's also a write situation. You can publish a website, you can publish messages, you can publish whatever you want through Freedom Browser without any gateways right back to the D-Web. We've built a wallet into the browser as a first-class citizen, which allows us to do things like HTTP 402. Some nerds of you might know what this is. It's a status code that the web is familiar with for over 40 years, but no browser in the world has yet shipped the actual ability to use that status code productively, and we actually shipped it. And if you actually go through the list of Ethereum improvement proposals, you will find dozens, maybe hundreds of EIPs that would rely on a browser implementing them. And so they are specified, but they are not used in the real world. One example is EIP 681, which allows you to just put an Ethereum address into an HTML link tag. And well, what should happen if I click on a link that points to an ETH address? Well, it should open my wallet with that address as a recipient. Well, Freedom Browser does that. No JavaScript, no browser extension, nothing like that required. It's just pure HTML, how it was meant to be. But we didn't stop there, because the vision is really to ship an entirely new web, and that requires developers. And so Freedom is really having developers in mind and is shipping new kinds of APIs that allow you to build real D-apps, real decentralized applications, meaning there is no traditional backend involved anymore. And it really takes a new browser to ship this vision. The very first API that we've shipped is called window.swarm. And window.swarm allows any website to connect to the node, the Swarm node that the user is running inside Freedom Browser, to publish content back to the DWeb on the user's behalf through their node. And that really closes a loop. You can do almost anything with this simple recipe. For example, one demo app that I've built is a fully decentralized Reddit with no servers involved whatsoever. It's just you and Swarm together creating something that just it has full feature parity with Reddit.com. It's just there is no platform intermediary anymore. And when I think back to 2015, this is what really nerd-sniped me into getting interested in Ethereum in the first place, because that's what Vitalik was promising. We can build a web where the users actually control the platforms in a peer-to-peer way. And, well, that's possible now, thanks to these very simple building blocks that we're putting together in this new kind of browser. And really, the limit is your imagination. And just to give you some ideas of the kind of stuff that I would be building now if I was sitting in the audience, listening to me speaking and being like, oh, wow, that's interesting. We need a new WordPress for Web3 to make it easy for people to publish content. We need a new GeoCities for the Web3 to make it easy to ship mini sites. We need a yahoo.com for the Web3 to discover other pages. We need a google.com to search the Web3. We literally have to rebuild the entire stack on this new decentralized web. And at Freedom Browser, we really love Swarm as the sort of peer-to-peer infrastructure to host this content. But you can equally do it on IPFS, and I'm sure there are other interesting networks out there that might be suitable. And we are having the vision of integrating all these networks that actually are decentralized and allow you as a user to access it without any gateways by running local nodes. Who's actually using Freedom Browser? So this slide is a bit old. We actually have even more users now, but we're at about 7,000, 7,500 users who've downloaded Freedom Browser and are trying it out, with about 2,000, 2,500 monthly active users, which to me is a ridiculous number. We have done no distribution. You've heard the talk before me explaining how to get distribution. We did none of that. We just shipped, and we're like, well, let's see if someone cares about this. And to our surprise, there are thousands of people from over 134 countries who actually care about accessing the web, the DWeb, without gateways and without intermediaries. And so to us, it looks like a really promising idea that we're excited to pursue. Some of the challenges that we encountered when building this, which are maybe interesting to some of you in the room, is that when building Freedom for mobile, we found out that running local nodes for IPFS and Swarm on a modern iPhone crashes the iPhone. These nodes have been built for desktop only. They've never really been run together on a single device, and they were just not made to be resource efficient for the mobile age. But let's be real, if you're not shipping on mobile, you're not really a serious platform. And so we had to rebuild both an IPFS and a Swarm node from scratch in Rust, which is a very sort of efficient language, in order to create mobile-optimized versions of these nodes that can actually run on your phone. And it's super exciting that this worked. And we will ship this in the iPhone and Android app later this summer. And you can download it from the App Store and experience it yourself. It's quite exciting. Another really big problem in Ethereum is the light client situation. So you can't really, back then, when people used Mist, so this original Ethereum browser in 2015, it actually ran an Ethereum full node, which is unimaginable today, because an Ethereum full node just needs a ton of storage and needs to be online all the time, and it's not feasible for consumer devices. So you need some line client situation to actually have trustless ENS, and we're very happy to work with the Colibri team, who are shipping an entirely new way to do this, using zero-knowledge proofs to create a trustless ENS resolution through RPC service. And another issue that we're just starting to tackle that we haven't solved yet, that probably will take us a while to do it really well, is privacy. And so I will talk about that in a moment a bit more. If I would give Freedom Browser sort of a CROPS rating, so CROPS being this sort of, North Star of Ethereum now. CR standing for censorship resistance. I would say actually we're really good at censorship resistance because we're allowing you to access the decentralized web without gateways, which probably you've never done in your life before. I don't know if any of you have ever run a local IPFS or Swarm node on your computer. With Freedom Browser, we're just bundling it in the binary, and it's just there. You don't have to take care of it. We solve it for you. So probably when you use Freedom Browser for the first time, you actually experience the real Web3 without gateways. And so there is a much higher level of censorship resistance by using Freedom Browser. Now, Swarm and IPFS are actually not themselves perfectly censorship-resistant networks, so there is a lot of work to do on that network layer, after all, but I think we're making a huge improvement already. In terms of the O, which stands for open source, happy to say that we're fully open source under Mozilla public license, and then some adjacent things like our nodes that we've built are open source under Apache and MIT. The P, which stands for privacy, is really the biggest sort of work package we still have ahead of us. I want to be very honest here. We have not perfectly solved privacy, but I'm going to mention some ideas that we have there. And in terms of S, which stands for security, we're actually a huge improvement to the current status quo. Because you remember earlier this year, a centralized gateway that people used to access the DWeb called .limo got hacked. And so if you would access websites through .limo, you would be sent to phishing sites, right? And other hacks, like there were other hacks of RPC servers that were poisoned, and so on and so forth. So there were a lot of issues already this year that would not affect you if you would access the real DWeb with Freedom Browser, because we're removing the intermediaries and thus the entire attack surface that you're being exposed to as a user. So overall, I would say we have a pretty good CROPS rating, but there is still work to do. In terms of our privacy roadmap, some exciting things that we want to do is, for example, build Gnosis VPN right into Freedom Browser to allow anyone to access both the clear web, but even the DWeb, so the nodes that you're running on your computer, to access them through Gnosis VPN and thus masking your real IP. Obviously, Gnosis VPN has not launched yet, so we would love to ship it already, but we can't. But we're talking to the team, we're in exchange, and we're hoping that later this year we might already be able to ship the first version with Gnosis VPN. So this is sort of the transport layer privacy, if you want. In terms of transactional privacy, there's another set of really interesting developments. There is Kohaku being developed by the EF, which includes things like privacy pools and Railgun to really give you privacy when you transact. So I mentioned that Freedom Browser has a built-in wallet, and we want to make privacy a first-class citizen and a first-class feature of the built-in wallet. Right now, it doesn't give you any transactional privacy. You're really fully exposed to RPC servers profiling you and D-apps profiling you. So by building in these protocols and just making them sort of ambiently available in the background, we hope that we can make it much easier for you to actually have transactional privacy as well. And I'm sure there are actually more possibilities to build privacy into this browser, so we really want ideas from you, our community and potential users, of what else we could be doing to make the browser more private. We would be excited if you reach out to us, share your ideas, start discussing with us. Me and Meinhard, with whom I'm building this, are here around, and we would love to talk to you. So that was the Freedom Browser. You can download Freedom Browser from the DWeb. It's freedombrowser.eth. And if you have no trustless way to access it, you can just go by freedombrowser.eth.limo, download it, and then never use a centralized gateway again to access the DWeb. Make that the last time you ever use a centralized gateway to access the DWeb. And yeah, that's it. Thank you very much.
Thank you, Florian. Do we have questions? Yeah, one.
Hi, really interesting. How do you, let's say I want to build a YouTube or Google Drive, collaborate on documents. How do you handle that sort of data volume? Can you?
Yeah, so in principle, you can build this with the kind of loop I described, where you sort of ship an app through, let's say, Swarm, and then your app connects back to the user's node, which then publishes data back to Swarm. So you can have an app that allows the user to create a Word document in their browser, and then your app allows the user to store that document they created in their browser locally back to the Swarm network, for example. So that is in principle possible. And your question points at something that I can't fully answer, which is that, well, how scalable is actually the Swarm network? Let's say we have 1 billion users suddenly starting to use this new web. Would it actually work? Frankly, I don't know. I mean, Swarm has been around for over a decade now. It's a really sophisticated peer-to-peer network, but they've never experienced that amount of users. So it would probably crash, and they would probably have to find new ways to make it scale. The Swarm team is actually here at the conference to discuss these questions with. I think that's an important point you're making, which is that what are we actually focusing on at Freedom Browser? And we're not building these peer-to-peer storage protocols. We're actually making them accessible. But are these storage protocols like Swarm and IPFS actually able to handle 3 billion, 5 billion users? Probably not today. That's probably something that would have to grow together with the usage of what we're building. And I think it's sort of a chicken and egg problem. Nobody's browsing IPFS or Swarm today because there's literally no browser to do it. So we're trying to solve that problem by making it accessible. Now I hope there are some developers in the audience who are going to say, oh, cool, I'm going to build some super cool new YouTube that is censorship resistant or something like that. On that will bring users, and that will force these teams like Swarm to be like, OK, let's scale this, because suddenly there's major traffic on there. So thank you for that. That's a good question.
Cool. Thank you so much. If you have any more questions.
And there's another one.
Yeah, we're over time, sorry.
OK, well, talk to me afterwards.
Yeah, please.
Thank you.
For you. So for this next talk, we talk a lot about privacy in terms of writing. So like privacy pools, mixers, all of that. But we never talk about privacy in terms of reading. So like indexers and things like that. So for this next talk, let's welcome Stefan from Corpus.
Good morning. It's great to be at DappCon again. Maybe some of you visited DappCon last year and heard my talk last year. So last year, last year I talked about trustless information. We should not trust RPCs when we are using data in our applications. We should verify every single data we are using. And today, we will go one step further. But before I start, let me share a short story from my childhood. So I was born and grew up here in East Germany. It's many years ago. And when I was a kid, I wanted something like this. A small radio, which I could use by myself. So these core radios were very familiar for us kids, but it was hard to get them. So one thing was, it was too expensive for my pocket money. And in East Germany, it was hard to get such technology. You need to know someone who can give it to you. You could not go to the store and buy it. So what did I do? I went to my dad. And I asked him, Dad, I want to have such a radio. And he said to me, my son, I'm sorry. I cannot give you such a device. I don't have it here. And I cannot get it right now. But, and then he went to the shelf, took an old book, and wrong direction, and he showed me something like this. He said, son, I cannot give you this radio because I have no way to get it now, but I can you teach to build it by yourself. So we did it. And some hours later, I finished my own first built radio. So this could be the happy end, but it is not. So at this time, I was hungry to learn more about this. So I got books, learned more about radios, and found a lot of different circuits, and I wanted to build more. But I had a problem. These parts I didn't have. No, I didn't have enough transistors, resistors, and capacitors. So I needed to get these devices. This helped me. Do you know what this is? This is the R300, the first and I think only supercomputer built in East Germany, completely built on transistor technology. And in Mittweida, where I lived, one of these computers were in the university where my dad worked. And the interesting thing is, these computers were built on circuits, on bigger devices, and they could change all the parts. And you see on this picture, there were some small memory flip-flops with 2 or 3 transistors on it, and some of them broke, and they put it to the trash. And my dad helped me to get all this trash. So, and I recycled all these defect parts from this computer, and I had a big store of parts. And I built a lot of these radios, about 20, maybe even more. So why I am talking about this? So it's not about what was back then, it's about pragmatism. So in this time I learned I can achieve a goal even if I don't have the perfect circumstances. Now, even if I don't have all the parts, I can get out of things, I can adapt it, I can change the circuits so that I can use the parts I really have. So what has this to do with privacy? Nothing? Why do we need privacy? So most of us may think privacy, I'm not a criminal, I don't want to do something forbidden, why do I need privacy? But privacy is not about hiding something, it's about security. If we share too much of our information, this is an attack vector. We can be compromised, or our actions can be compromised. And that's why it's very important for us to have privacy, and especially in Web3. We need privacy for certain tasks we need to do. So when we talk about Web3 privacy, mostly we talk about these privacy protocols. Railgun, Tornado Cache, private pools, so where we can store hidden assets, or we can make transactions hidden from outside. But there is another part of privacy which is also very important, and this is the read privacy. So normally when we think about reading something, we don't think about privacy. And in Web3, transactions, we know we send it to the chain, it is published. Here we have an idea of what privacy means. And in an ideal Web3 world, the read privacy would not be this problem. Now, if everyone runs his own full node, privacy is not really a topic, because I have my own node, he is connected with the network, synchronizes everything, and I have the data I need. But we are working in a different way. Normally, we get data from RPC service. Last year, I talked about that we must not trust this data. This is still true, and this is the foundation. But we also must think about what data do we really share with these providers. So, why do we need read privacy? Because this is part of our security model. We need to secure our intention and maybe also our identity so that we can make secure business or secure actions on chain. So if we reveal the pattern of what we plan or what we are planning to do, someone can use this to attack us. And this is something we need to prevent, and read privacy is exactly working on this point. We must not forget, privacy which is built on trust is not really privacy. Now, if I need a trusted partner to build a privacy solution, then the privacy is only available as long as the trust is working. If the trust assumption is failing, also the privacy is failing. That's why we need to verify the data and everything we are doing first. We need trusted data, and on top of this, we need privacy. Of course, it would be really nice if we have a mathematically proved, scientifically tested privacy for all things we are doing. But as we know from many of these sophisticated privacy methods, they are not that easy to use. Some of them are theoretically nice, but have a high cost or are complicated, or even are not even yet fully developed, so that we cannot use them in productive systems. So if we are looking for a perfect privacy before we use privacy, we end up in using no privacy. So privacy maximalism doesn't help us. We need to use privacy in a way that we can use it right now, that we can use as much as possible right now. So, and this is our approach. We call it PAP, Pragmatic Adaptive Privacy. And I will show you that this can help us to solve many of the privacy problems we have right now in Web3. So it's not that we want to replace strong privacy methods, but to make it step by step feasible for our applications. So what does pragmatic privacy mean? Privacy first needs to be adapted to the use case. That means if I have something which is not that important, for instance, I have a dashboard and I need some information from chain, this needs a fully different approach for privacy than when I maybe create an important transaction. So many of our actions could be different, and that's why our privacy model needs to be adapted to these situations. So that's why we divided privacy in two levels or in two dimensions. First, the transport privacy, and second, the content privacy. So now I will explain how this works and how this helps us to find the right level of privacy. And yeah, as you see, we can use these dimensions in different or separately. We don't need to synchronize these levels. So I can have a high content privacy and a low transport privacy. It's always dependent on what I really need. So let's look on the transport privacy. What is this about? It's about who. Who is doing some actions? If I do a transaction or if I read something to prepare a transaction, so my identity is connected with this. Now, if I read, let's say, a balance of an account and it is connected to my IP, my identity is connected with this account. Very easy. So, and when we think about these levels of transport privacy, we have the level 0. It's how we are doing or how we are working now. In level 1, we don't do full privacy, but we start to hide some of our connections. Now, we don't use one single RPC who can collect everything, but maybe we are using different RPCs so that we can separate different calls, so that it is not easy to connect what we are really looking for. And in level 2, then we are using more sophisticated privacy methods like Tor network or mixed nets like Hopper, so that we can really hide the connection, who is asking, and the service who is providing us the information. And the second is the content privacy. The content privacy is not about who is doing something, it is about what is requested. It's about the intention. Level 0, again, is how we are working now, hopefully with verified data. In level 1, we are starting not asking directly for a specific data. Now, for instance, if I need a transaction, I don't ask for the transaction, I ask for the block. And then I can get the verified information for the whole block, and I can separate the data. And then I have a much broader request, which makes it much more complicated to see a pattern in my request. But it helps, especially to prepare transactions, because sometimes it's enough to do this, because the time window to analyze is not that big. Now, if I prepare a transaction, for an attacker, it's very interesting to be quick enough to maybe make a front-running attack to me. But if he is not able in this time I prepare a transaction, then this is enough for the privacy to prevent this attack. And then we have level 2, where we have these sophisticated content privacy method, PIR, ORM, using TEs, and so on. In the pub model, all of these methods are included. But, as I said, they are not used on the highest level for every request. So, as I said, we need to find out what request needs what level on privacy. So, and this is what we call the adaptive part of privacy, that we don't use the same level for all requests, but we can couple the privacy demand for each request. So and it means we have some requests with low demand, where we can use a CS1 or T1 level, or we need to use a higher level to really make this request fully private. The privacy level C1, also the content privacy level 1, is a very interesting level. And that's why I will share some more information about this. To hide the content, it's, as I said before, important not to send a direct request to the RPC. But if I can shield it in a much broader request, which is provable, that means which is trustless data still, then the client can select the data I'm interested in, so we can use this completely on the protocol level. And the very important thing is, many of these sophisticated methods, like PIR or ORM, they need special hardware, special servers, and are very expensive to implement. The level C1, this content privacy level 1, works completely on the existing stack. We can now implement this level of privacy with the services, the providers we already have. And the interesting thing is, in our applications, we don't see a lot of influence of this privacy level. It enhances our privacy level to a very good degree, but it doesn't slow it down, it doesn't cost much more. It simply uses the things we already have available. So how is this available now? So with the Colibri client I presented last year, which is a stateless client, fully working without any synchronization, without any storing from data, it just storing from the state, it just gets the data and approves, and then it can verify completely locally that this data is valid. And this client can be a replacement to a normal RPC call, but it also implements the pub interface. That means the application which is using a Colibri client to fetch data from the Web3 network, let's say Ethereum or Gnosis chain, it can add the privacy levels automatically on protocol level. That means we don't have to change our applications. Of course, everything I described today, you can do in your app by yourself. You don't need us to do this. But imagine you have a wallet, and instead of directly asking what you need, you are thinking, okay, I need to do these and these special operations. It makes the code of an application very complicated. And with putting these privacy routines on the protocol level, we have a very clear interface in our applications. We are still asking for the information we need, but we have this client level this protocol level, where the trustless layer is, where the verification is, and also where the privacy layer adds this read privacy to our requests. And with this, we can switch from existing applications, how they are working now, maybe even without verification, to a verified and private approach. And if the sophisticated privacy methods grow up in the future, they will be integrated in this pub level, and then we can use them directly on the same interface. That's why don't trust any data. Verify everything you get from an RPC, from a source which is coming from a blockchain, and be private. Use these methods so that you don't share the intent or identity of your users. So trustless is now available. We have these stateless clients. We have also other light clients which can help us to really have trustless data. And we can have privacy also right now. We don't need to wait until a very sophisticated method is ready in the future. We can have it now. You can go to our website, you can go to our repository, everything is available. We are happy to contribute. If you want to contribute, if you want to use it, just come to us and share the information, what you need, and then you can use the software. Thank you very much for your attention. Maybe we have some time left or not?
Yes, sorry, we are a little over time already. We can't really make it for questions, but please find Stefan around if you have questions. Thank you so much.
Thank you very much.
You can take it, yeah. So next up, he will talk about minimum viable issuance. Please welcome Jérôme Tichet from Ethereum France.
Print less, burn more. Print less, burn more. Sorry, yeah. MVI. Hello, everyone. Very glad to be here again. I'm Jérôme. You can find me at this handle everywhere, JDETYCHEY. Couple of disclaimers before I start this presentation. I sit on the shoulders of giants, such as Ansgar, Anders, Kaspar, Justin, Patchy, and so on. Pintail as well. So a lot of the the graphs that I'm going to be showing are from their work. I'm just here to pass the message. So about the message, let's talk about minimum viable issuance or issuance as a whole. But for that, we need a little bit of glossary. So what is issuance and dilution? When I say issuance and dilution, what I mean is the amount of new ETH we are minting each year, usually, expressed in percentage most of the time, percentage of the total of the supply. So you can think about issuance, dilution as the growth of the total supply of ETH. It's most usually expressed raw, I mean, without taking into account the burn that comes from activity on the network. What is the deposit size? The deposit size, or the D for short, it's the percentage of ETH that are at stake. We have a staking contract on Ethereum, and you can deposit ETH on this contract. And if you count the number of ETH on this contract and you divide it by the supply, you get the staking ratio or the deposit size. And it's very often wrongly simplified as the bigger the deposit, the better. Big deposit, good, bad deposit, small deposit, bad. Wrongly for different reasons, I'll get into it. We have a reward curve, which is simplified form here is 166 times the square root of the deposit size. That's the ETH that we give to the validators for their work. It's aggregated, of course. It's also known as our security budget. It's a bit simplified also because it assumes that the validators are working well, not being offline too much, and so on. It's been defined circa 2019 without knowing much what was going to be going on at stake, if we were going to have a lot of people going at stake, few people going at stake, whatever, how and when we will be able to withdraw, and so on. So a lot of guesses and unknown when we pick this curve. And finally, there is the staking yield. That's the easiest thing, right? The staking yield. How much is the staking yield? That's the percentage received by stakers. It's often, not always, but most often given raw. I mean, without subtracting the dilution of the issuance. So if you have a staking yield at 2.8 and a dilution at 0.8, your real yield should be 2%. Right? But most of the time, we just look at the 2.8 because that's the biggest number. So, staking is 2.8. It's not always giving you the breakdown between what you get as tips. Like as a staker, sometimes you propose a block, and in the block there are some tips, so you get some tips. So the 2.8 is usually taking into account the tip. The MEV as well. We have some ordering of the transaction that gives a little extra for the block builders. That's not taking into account this MEV. And most of the time, if you're using a third-party staking services, a staking service provider, they are taking also some basis points. So advertising the staking yield does not always give you the real yield that you get at the end of the fees and so on. Okay, so now that we get the glossary out of the way, let's look at the beautiful picture. Have you seen this picture before? Yeah, no one. Okay, so I highly encourage you to see this picture when you visit Paris in the Louvre. It's the money changer and his wife from Quentin Metzes. At first glance, it's a genre scene, like classic Flemish paintings, where you see people at work, the new services, the bourgeoisie getting richer, and so on. But at its core, it's more of an allegory and moralizing representation of the moneylender profession. You have different signs of vanity, different signs of Christian memento mori reference, such as the scale, the candle of the Last Judgment being turned down, and it's been analyzed as a way to denounce avarice. Even the lady here is lured out of the way of her praying book and looking at the money being weighted. And the painter here wanted to encourage the bankers to be more gearing towards Christian/Erasmian morals about moderation in their business dealings. And it was later demonstrated in another painting from Quentin Metzes about the usurers, where you have really grotesque figures having super high interest rates and so on. What I personally love about this painting is the diversity of the point of views and different levels of interpretations. Like, you can talk about this painting for hours. And also it includes a really nice thing to catch if you visit flea markets. There is a banker mirror here. It's like a spheric mirror where you can look at the mirror and see the whole room at the same time. So you'll be counting the money and at the same time looking at the people in the shop, see if they are stealing something or doing something nasty with your owning. Anyway, it's a little bit like we have in the issuance discussions right now. We have lots of different point of views, and it's not helping to take a decision on when to move, how to move. The subject matters assume some form of expertise in blockchain and security, in economics as well, and a lot of curiosity to dig into it. We have LLMs now to help us get better at this type of curiosity, but yet. And having those discussions from past year now, I often end up into different cruxes, like people that are looking at this and be like, yeah, but we need to consider this, we need to research more, we need to do more, and so on. And I think like it's a bit of an allegory of our situation right now. We have consideration about the security and credible neutrality of Ethereum. We have consideration about the deterioration of the moneyness of our currency, but also a consideration about fundamentals of supply growth moderation, notably. And also looking at the dwindling, sometimes, or mostly dwindling purchasing power of our own currency, ETH. So it's kind of worrisome to see that at play when you're advocating for issuance reduction. There are very strong security reasons to do it, and they should prevail above all. Yet, those security reasons can be downplayed, can be overshadowed, notably when you are taking into consideration some very short-term effect that can be advocated regarding DeFi and such. Thus, the conversation can often turn into, but what is the impact on the ETH price? Are you going to destroy this? Are you going to impact that? Did you take into consideration? And so on. But the beauty of issuance reduction is that it's fundamentally improved both Ethereum and ETH as a strong asset. Let's have a look at a few numbers. Here's the issue in practice. Currently, at stake, the deposit side is, give or take, 39 million ETH. So that's 32% of our current supply. It's up 3 points since November. We have a yield of 2.8. Issuance is 2.64, and you have some tips and some MEV, of course. So post-burn, the issuance is 0.82. It's all right. It's a lot by some standards. It's a few by other standards. But it's also something that's trending up considerably. The more ETH we have at stake, the more issuance we will have because of our yearly issuance curve, our reward curve. If we compare with the best in class in that consideration is Bitcoin, the circulating supply will grow 0.4 next halving, so in 2 years, and it's currently at 0.8. So the proposal that I'm championing is minimum viable issuance, setting a maximum amount of new ETH created per year of 0.5% of the total supply. And you can immediately think about that as a strong reference point regarding what's the delta between what we have today and what we will have if we get into this. That's 720 million extra dollar of ETH that will not be minted. So that's kind of strong, something that's really sizable, I would say. Why is it urgent to address the problem? We have a dam in place that's preventing a total inundation, but the tide is rising, and it's rising pretty fast. As you know, we are entering a phase where more and more institutions are getting into the mix. They are starting ETF, DATs, ETPs, and so on, and they are getting approval from the regulator to stake. And they are staking. Grayscale notably stakes 70% of their ETH. Maybe they will consider to stake more as they perceive less and less risk. So that's an enormous influx of new ETH that's going to come at stake. And we have some unknowns, of course, on the decentralized effect of this. Some custodians in the US are proposing stakings, notably Coinbase Prime, sorry, Coinbase Custody. And the way the protocol handles those new ETH is by imposing an entry queue that only allows for a few ETH to go at stake every epoch. So currently, the entry queue is full. Yeah, it takes 60 days to get into staking. So while they are not at stake, they are just holding the ETH and waiting for an opportunity window to go at stake. But it will go at stake more and more and more and more and more and more. If you're interested, there is Hildoby that gave a presentation about that back in November during DevConnect staking gathering. So as I said in the introduction, we have security reasons to do it. It's not always perceived immediately as such, but our proof-of-stake system is by far the most sophisticated there is in the market. Which, when we compare with other proof-of-stake, we are like, yeah, but this blockchain says they have 80% of their tokens at stake, and it's great. In our case, it doesn't work this way. We were aiming initially for having 15, 20-ish% of the ETH at stake. We considered that to be sufficient. When we add more ETH at stake, we are not adding much security beyond certain thresholds. And when we reach higher thresholds, as at 50%, there are actually strong arguments to explain that the extra ETH is actually diminishing the security. Our last resort in terms of security for Ethereum is to have ETH available on the execution layer to come at stake and defend neutrality. So that revolves around different problems that we have to face. First, the credibility of a large slashing event. As we get bigger deposits, it is centralizing. There are economies of scale at play. There are considerations regarding too big to fail at play, and thus it benefits the bigger stakers. While you are watching the dilution as someone that is not staking, you are more and more considering to go at stake. If I tell you the dilution is 1% and you are holding your ETH and not doing anything with them, you should go at stake to prevent the dilution effect. So this snowballs eventually. there are strong considerations now about having large slashing events being not credible anymore. We had a few events in the DeFi space where restaking tokens were involved, and people were like, yeah, we need to bail them out because the effect is going to be huge. So all in all, we are less and less if to defend the decentralization and the neutrality of the network. So that's, for me, the most important thing to consider. But it gets into the weeds of the security and things to consider around that. But that's not all. The effect of reducing dilution is improving the marketability and the moneyness of the asset. So of course, to advocate for ETH as an investment, as a long-term holding, you need to consider the marketability of the asset itself. When we have a finite supply, and you don't have to consider dilution or having to consider little dilution, it makes it a sound money. If something is even having a negative growth in supply, it's an ultrasound asset. And that was the highest of the hype around Ethereum. We have ultrasound money. So, of course, printing less doesn't necessarily mean eventually we immediately burn more, but that's a part of the equation. And that's something we should definitely consider in terms of the fundamentals of the asset itself. Pushing ETH towards staking is removing ETH from the execution layer, so having less ETH available for doing things on DeFi. Plus, when you consider the DeFi activity, we need to have ETH that is available to go do something on DeFi to promote the innovation on DeFi itself. As we get into the snowballing effect of having more ETH at stake, we pinpoint problems regarding liquid staking tokens and other staking derivatives. When all the ETH are at stake, or most of the ETH are at stake, those derivatives become the de facto money of our network, and thus we lose our monetary premium. It can be very short-sighted to argue that, you see those tweets sometimes just saying like, look, there is almost no ETH left on no ETH left on the centralized exchanges. All the ETH are going at stake. This is great. Yeah, this is definitely a clear indication of confidence into ETH the assets, but at the same time, this creates liquidity squeezes. So you have less ETH available to buy, and thus it's hindering adoption and hindering large players to come at play. And furthermore, we are putting DeFi in a cul-de-sac. Okay, bear with me on that. The staking yield is going to continue to trend. The staking risk is going to continue to trend lower. As more ETH go at stake, it's going to be less and less risky to go at stake. And currently, staking pays twice as much than depositing your ETH on Aave. Yet, the security analysis, the risk analysis, should probably not be this way. And capital naturally flows towards what's yielding the most and having the less risk. So what we have today is that we have artificially fabricated in protocol an unfair competition to our own product market fit. There is no way DeFi can be competitive to staking without just embracing staking massively. This is implying something about moral hazard regarding DeFi being brought into consensus, and vice versa, problems in consensus being brought into DeFi. And furthermore, if we print more than we need, we are technically subsidizing this by printing more. So we have an opportunity to fix this once and for all. Enters the MVI. The writing has been on the wall for the past 4 years, so it's not a new proposal. It's just now we think that we have more than enough research being done on the matter, and we have such an emergency to act that we need to act now. What's amazing about MVI for core devs and holders alike is that it's super easy to implement. It's not a big change in the protocol. It's not a big change in the staking in the node software, and it's also super high impact. And to represent the minimum viable issuance, saying max issuance is 0.5, we can consider different type of curves. You probably remember the croissant from Justin Drake. We can have things that are like this class of curves, the red one, or the purple one. There's different classes of curves to consider, and they can all implement MVI together. If you want to dig about on the topic, I highly recommend those reference. practical endgame from Anders that demonstrate how credible, simple, and small but positive this kind of MVI approach is. If you want to get into some more economic analysis, notably with Tim Rovgarden, the economist that gave the analysis on 1559, you can check this one, Economic Limits of Permissionless Consensus. And overall, there is a great thread on IF-Magician called the Issuance Curve Adjustment Protocol. But some private research firms, like the research team of Grayscale, recently started to take positions like, hey, okay, this staking model needs an update. It's obviously not going the right direction right now. So what you should keep in mind about that, it's compatible with different type of curves, it's high enough to keep the system valuable, it's reasonable yield at typical stake level, and it's also a durable policy anchor we can advertise that is simple to understand. What's the dilution? 0.5, max. What's the real dilution? Well, let's look at the end of the year. We'll probably be more at 0.3, 0.2, whatever. And it gives us a way to position ourselves clearly against the contender, Bitcoin, and against all the rest. So 21 million Bitcoins, yeah, forever 21, infinity divided by 21 million, yet Bitcoin hasn't figured out its security budget. We have. We have a quantum-resistant roadmap. We have a lower dilution guaranteed for the next 5 years and likely for the next 10 years and very likely forever. You have yield-bearing option in DeFi. You have no downtime, no competition against AI data center. Ethereum should be the first blockchain by far. And when you consider all the alt layer ones, they are diluting like crazy. So what are we waiting for here? And we can also get 50 cents to present the thing, like MVI is 0.5. Now I want just to address two usual critics. We should never touch our monetary policy. We only have one chance to do it. No, don't change it, don't change it. Well, actually, we have a history of maximizing our security and neutrality by stop overpaying for this. Like almost 8 times we did the thing. It's great to consider like the signaling. It's great to consider information. It's great to be clear, and that's why 0.5 is a clear way of saying like max is 0.5. Current max is probably 1.5. And lastly, we have something that we very often hear about the issuance discussion is inflation. I've been very careful on not using inflation so far, because when we hear 0.82 is our inflation, it's wrong. It's not our inflation. It is our dilution. The inflation is the rise in price that we observe on an annual basis, but also, by extension, the loss of purchasing power in external goods of our currency. So inflation is not dilution. Inflation is measured by the rise in price, and as you can see with the lowering of the gas price, with our scaling, with L2, with EEZ, and so on, we are actually in a deflationary situation for Ethereum. Like we pay less for the same good services. But at the same time, our token is not performing well. So it's technically what we call an over-savings trap in economics. We have a high risk-free rate, which is a toxic illusion of everything is going fine, don't touch anything. The effect of dilution from the market perspective when it comes to lowering our purchasing power is not straightforward, but we can sum it up this way. The market observes that our dilution is going up, it's trending up, it's not doing good for our security, and at the same time we show no signs of wanting to take care about the problem. So having a dilution of 0.8 raising up towards 1.6, killing the economy at the same time, it's actually much worse than inflation itself. All right, so I want to conclude on that. It's a massive win for everyone. If you have ETH, it's great for you. It's going to be a transfer of surplus towards the holders. We're going to do more security for cheaper, and it's going to improve the fundamentals of ETH. It's going to push the innovation into the DeFi industry, likely also bring more activity towards the L1, and thus printing less and burning more. Here are 10 reasons why we should do it, and we should have done it yesterday. And we have now also analysis on how the surplus transfer is being handled, depending on the reward curve that you consider and consideration about the implied cost for the stakers. And I'm 3 minutes late, very sorry for that. But happy to answer any questions, and I'll be here the whole day for getting into questions if you want to mingle. That's it. Out of time for questions.
Yeah, I see the hands raising, but please find Jerome around.
I'll be there to answer your question.
We
let's
really
And if you're too shy to come to me in person, you can just give me a message on Twitter. I'll be very happy to respond.
Yeah, please.
Thank you very much.
Thank you so much.
I'll be right back.
So on the next topic, he will talk about security on Web3. Previously, we've been having attacks. Previously, the limit was on humans, but introduce LLM and the constraint is gone. So we need some infrastructure that compounds as much as on the defense that it compounds on the attack vector. So please welcome Richard from SAFE.
Hello everyone. I hope you enjoy the nice days at DappCon with nice weather actually. Right, only for DappCon the sun came out. And today, yes, as mentioned, I want to talk about offensive AI, especially in the context of on-chain security. But why are we talking about this, right? And I think it has been clear, and I mean, Frederica opened the DappCon with this change that there's a new paradigm. AI is everywhere. And I can remember when 3 years ago, it was not Gemini at this point, it was Bard, I think, fun name, where they started experimenting with this personal assistant. And I was really like, oh, finally, I don't have to scream at my Alexa anymore, threatening it to throw it out of the window because it doesn't understand me. But I finally have something that feels like I talk to something intelligent that can really react to me. And this is how it started, right? Like this is how it started out, and by now it evolved. In between, we really started using it for code reviews. We gave it limited context of a diff from a PR, to the point that now basically AI manages whole code bases in projects like our website in some cases. And this is a fast development. It's a new paradigm. AI is everywhere. AI is being used by everyone. It's not only developers. It is my whole family using it for day-to-day stuff. And this even impacted Web3 massively. And this started with SAFE in the beginning of last year, where we really saw the first big event around this. So SAFE started organizing the Agentathon. It was an AI event. We had more than 30 sponsors, ranging from smaller Web3 specific teams all the way to big projects like Kraken and AWS, pooling a massive amount of $500,000 or more than $500,000 as rewards. And that attracted a lot of teams trying to build, hey, how can we use agents to interact on-chain, to interact with SAFE accounts? And in this beginning, it was mostly that you had the setup where agents were controlling safes. They either directly controlled the safe, so were set up as owners, or they used a combination of different modules, so like access control mechanisms, to really have like scoped access to your safe, either time-bound, session-bound, or scoped to different functions or under different conditions. And this was quite often used that you can like let an AI manage your portfolio or automatically participate in a prediction market. These systems were quite complex, but they allowed really this autonomous agent automation. Oops. All of this was really made possible because if you can see here, this was the Agentathon was already where models actually have large context models. But if we look back further, right, like this became possible because AI agents started to be able to understand a wider context. So in the beginning, it was maybe only possible, hey, you have one page of text and analyze it. We're going all the way that they now can understand a whole market, whole code bases. And this actually allows also that we go away from, hey, an AI model just tries to analyze a single project. No, they analyze whole flows. And this was something that yesterday was also mentioned by Rahul from Labs. We really say, when it comes to security, security is not only guaranteeing the security of a single piece of code. In Web3, in DeFi, we live, or the magic happens when you compose all of these different pieces of code where you create flows. And guaranteeing the security of these flows, that is what introduces the complexity. And now that AI models basically can look at the whole flow and not only at one specific code base, this would make them so powerful and potentially also so dangerous, because now they can basically combine the different things. They can look at the complexity introduced by module setups and how they interact with different protocols and exploit paths that have not been visible before. And we have seen this in recent weeks, that this is an active threat. We can also see this in a more global trend when we look at the reported vulnerabilities in the security landscape, where we really see that in 2015, we were below 10,000 CVEs per year. And we really see that it spikes over the years, and that in the last 2 years, there was a massive increase to the point that alone in the quarter of this year, there have been more reports than 2017 nearly over the whole year, right? Like we can really see that it is like an exponential curve going up. And the very interesting part here is it's not that AI finds like low-level bugs and these are just low-level CVEs with a low score. No, we also see that the number of critical and high-level vulnerabilities are going up. So it's a real threat. The statistic shows, right, like that now AI agents can find vulnerabilities faster. You can argue that's nice, right? Like we can also use this in a defensive manner. But actually, now that these AI models become more widely available, and we see also that smaller models become more powerful, actually the attacks vector goes beyond this. After AI models discover vulnerabilities, you can use AI to also obfuscate the code. There have been research papers where basically AI, like worms generated or like empowered by AI, can adapt themselves. They can obfuscate themselves. Once they're on the machine, they use the local available models on this machine to analyze the machine, to adapt themselves and find new vulnerabilities, how they can exploit. I'm not sure if some of you have seen Stargate Atlantis. It's a fun series, and there is this point they have these replicators, these nanobots. And there was a point where these nanobots were in one of the main characters, and she was close to dying. And there they thought like she was dying because the nanobots, they basically were wreaking havoc inside her body. But they, at the same time, used these nanobots to reprogram them, to convince them to help her. And we're at the same point where it's not in our bodies just yet, maybe, but where they are in our digital systems. And these AI agents, these small worms, autonomously acting, they can wreak havoc inside our systems, or potentially they can also help us. And to help us, we need to give them the right tools. And a lot of the smart accounts out there actually already have one very essential tool, which is a circuit breaker. In SAFE, this is the guard mechanism. A guard is basically a piece of logic that is invoked every time that you want to do an interaction from your SAFE. And this allows you to really say, hey, before anything happens to myself, before anything goes through, here is a hard cut where I can like evaluate what is being done, where I can insert additional logic. And the nice part about the guards is that it aligns with our values of self-custody, because a guard can never say, hey, my funds move without my confirmation. A guard can only prevent a moval, so they cannot have positive control over your funds. But this alone is not enough. It's really like, okay, how do we allow now that AI agents and like a vast decentralized network of security checks can really interact with such a system? And I mean, if you know the history of Gnosis, Gnosis has worked on this in the past. How can you pool information efficiently from a large crowd? And historically seen, that's prediction markets. And I mean, the screenshots here are from Polymarket, which are doing this right now, right? Like you pool information from a large group. The problem or the challenge with prediction market in our context is that prediction markets are normally a little bit longer running. You have clear resolutions, right? Like how do you resolve this prediction market to do the payouts? So this is where we need to adjust, right? Like how can we shorten the time? How can we make this really short-lived markets and focus on them on a more fuzzy topic like transactional security? In most cases, there is no clear yes or no, this transaction is secure. There are fine nuances, and really have to figure out how to handle these markets. And for us, and what we are working on at SAFE, the SAFE research team, that's SafeNet. SafeNet being this marketplace for these short-lived markets, allowing us to pull this information. So what do we have with SafeNet, right? At the core of SafeNet, we have a consensus mechanism. And in this consensus mechanism, we attest information. We just finalize information saying, hey, here, this is the outcome of one of these short-lived markets. But the magic, what you can do with this information is that you take these short-lived markets where we have actors, which we call sentinels, that together figure out, is the transaction good or not? And then we take this result, being attested, and then we can put it into the on-chain enforcement, into the guard that has been mentioned earlier, which is guaranteed on-chain, which is guaranteed by the smart contract logic that this will hold. All of this allows us to have the flexibility, this pooling of knowledge, while it's still giving strong guarantees on-chain. So where are we right now? In the beginning of this year, we started working on this consensus mechanism. We started saying, how can we bootstrap the economic security, where we said we introduce safe staking, and we wanted to bootstrap this consensus layer, where we really said, okay, how does this consensus, how does the finalization of the information work out? And for the last 3 months, this has been running, and over the time, we had more than 400 people staking safe. We are at close to 54 million safe tokens being staked, and it has been paid out. We do every 2 weeks, there's a reward payout, where we have paid out more than 1 million safe tokens so far. In this consensus algorithm, as I mentioned before, we have different validators running. In our initial, in the beta running, we have 6 parties, 6 different validators that together run this consensus. In this consensus algorithm, because we in this beta didn't have this short-lived markets, we performed some basic checks, and we have performed these checks on all safe transactions that have been executed on Base and Ethereum mainnet. These in total have been over, these stats are from last week, so by now it should have been over 200,000 transactions that we have checked. And in the average, the participation rate of all of these validators is above 99%. This really showcases that since in our consensus algorithm, we actually don't need all validators to be online all the time. We only need 4 validators at the same time to really move forward our checks. This gives us a high confidence that we can move ahead and say, okay, let's research how can we bring this really to the end user? How can we integrate this into Safe Wallet and make this accessible? In the last 3 months, our focus here was really, okay, what is the best way of on-chain enforcement? What do we need in a guard? Because obviously when you can block transactions, this can result in funds getting stuck. So what are escape hatches that we want to have here? We also thought about what are meaningful checks? What are the advanced checks that these short-lived markets want to check? Why in the long term, in the far future, we would like that you just post your intent in our and the sentinels check, does the transaction fit your intent? There's a long way to get there. We first have to start with more focused problems. And our goal is that by Q3, so that in Q3, we start working on integrating this, making this accessible to the Safe Wallet users before we then start working on further decentralization, accountability, and also privacy in the context. So what exactly do we want to integrate into Safe Wallet? And for us, the first part is that we want something that is available to all Safe Wallet users. So far, a lot of the technical safeguards that exist are either very expensive or they are not available with strong on-chain guarantees. And if you want to set up something like policies, you normally need a full team just analyzing your setup, making sure that it's optimized towards your use cases. And not every team has this such a security team or security council. And we already see this in smaller teams on our side. We recently wanted to, or not we only wanted to, but recently put some funds into Aave. And when we looked at this transaction, it was very hard for us to fully verify it. And what I mean with fully verify is like, obviously we knew, hey, this is the address that we interact with. We could decode the call data. But after we start looking deeper, we saw that the pool that we're interacting with, it's actually a proxy. The proxy is pointing to an address. This implementation address was updated 4 days before we did our transaction. We had to figure out, why was it updated? Is it a valid update? Was it a compromise? All of this is way too complex for the average team. And this is really where we want to make this available to the vast audience. As you have seen in my example, often even the verification of an address becomes really hard. And that's also why we said our first scope that we want to focus on is really this: how do we make sure that these addresses are valid, that they're not malicious, that there has been no address poisoning, that there's no compromise related to this address. Solving this will bring a big value to most of the safe wallet users. And additionally, we also want to avoid that you have unintended configuration changes, which in most cases, the users of a safe don't constantly change their safe configuration. It's an event where it's well planned, where you can expose time logs. So what do we need to do is that we need help for this, right? Like as we said, it's a network of protocols. We have sentinels, we have validators, and all of these need to come together. And the hard work of figuring out is this a valid address or not, this is really where we need people that support this, where we need teams, where we need AI agents really working together with us. We are in a world where AI is everywhere, where AI can be used for attacking scenarios, for analyzing vast information, user flows, big combinations of contract setups. But it's not all bad, by no means. AI also gives us a lot of opportunities. It allows us to use it for defensive purposes and to really move forward faster. And that's why really we invite everyone to really build together with us a new on-chain like security, or the future of on-chain security. We invite you to join our Telegram group for updates, reach out to us via email or via contact form listed on here, or find us on the venue to collaborate with us. Yes, I managed to keep in time. Awesome.
Sorry, we will unfortunately won't be able to take questions. Yeah, wrong timer. But yeah, if you have questions, please find Richard around. Yeah, thank you so much. For the next talk, he will talk about VPNs. Let's welcome Sebastian from Gnosis and Hopper.
All right, welcome everyone, and a second. All right, so this is not my first time here. I have been here before, and today I'm here to talk about why Gnosis needs a VPN. Before we get there, I would like to start by addressing the elephant in the room. And that is, this room is somewhat more empty than it was last year or the year before. And I would therefore like to start by congratulating all of you for being here, for not, full-on narrative, migrating to AI, still sticking to crypto. And yeah, I think this is good. I'm personally here because I think crypto has one value proposition, and that is to make us more free. And that's what I'm going to talk about. And I'm going to kick it off by, addressing, welcome to 2026. Not the first time I'm here. What is new, right? Why is he still talking about privacy? I get it. Generally, I'm supposed to stand here and say things are good, things are getting better. But unfortunately, that's not the reality. I mean, things are getting better, right? So I can have a presentation where I can play Pong when I'm just bored standing here. This is all kind of fun. Until, of course, it's not. I'm not talking about just, AI slop software. I'm talking about deployments of software in production that leaks critical access to personal identifiable information, right? Like committing the database access to GitHub, having it just plain in the open, having access credentials leaked. This is something that I do see, and that does concern me because we see that being deployed at much larger scale than before. As we've heard from Richard, this is of course not new, right? But now this is available to pretty much anyone with access to cloud or whatever, right? And yes, we've seen with Fable, I don't know if that was marketing or what, but we've seen that yes, you can hack stuff with access to AI. And I would like to take it like one step further and saying this is not just about the exploits, right? Exploits have always happened, right? We've had a ton of databases where all of a sudden out in the open and you could see it. But what concerns me that all this database seemed unfeasible to make any sense out of it. Like, you've probably, if you cared about your passwords, you've probably, had some, have been pawned or something like that, where you see where your data has been leaked, right? And all your data has been leaked, and we all know it, right? If you didn't know that, some data has been leaked, consider checking out these tools. Anyway, it has been completely unfeasible to cross-correlate these databases to get bigger insights. Now, because of AI, we are able and effectively turn all these individual leaked sets of databases into one mega database that has your digital lives out in the open and visible. So, yeah, as I said, that is pretty bad, right? So in the AI era, I do see more sloppy software deployments. I see easier exploitation of vulnerabilities, and I see this linkability of information that's out in the open, that is practically available to anyone here. Now, this is something I would like to drill down on. How do you practically cross-link these separate, distinct databases? And my claim is, practically, you do that by metadata, and specifically, connection metadata. So, a little excursion into how this data is treated, right? Your IP has leaked. Okay, at least it's not my Gmail password, right? So it's kind of okay. Well, it turns out that in the Prosper Marketplace, for example, like 17.6 million records have been leaked, which were highly sensitive information. This was a lending marketplace, right, where you had banking-grade information of individuals. And your IP address was in there. So your IP address is effectively your primary identifier of figuring out all sorts of stuff. So when I figure out your IP address, I link it to that, right? Maybe you're in a data set, maybe you're not. But you're probably in some other. Now, IP addresses are not just targeted by the bad people, they're also targeted by the good people, the compliance people, right? So Chainalysis was nice enough to actually use IP addresses to trace Monero users. This is obviously not something that they advertised, this is something that came out in a leaked training video of Chainalysis. So yes, IP addresses are apparently highly important, otherwise, quite sophisticated players like Chainalysis wouldn't use them. So I make the claim that IP addresses are your actual primary key and identifier of you and your activities. And while I'm talking about the web here mostly, this applies to the Web3 in the same fashion. You can ZK all the things. You do interface peer-to-peer networks. You do interface other systems and networks. And your home address on the internet, that's basically what your IP address is, your unique home address on the internet, does leak to all of these systems. Anyway, let's go back, just a super quick overview of the internet. So I access the internet also. And in addition to working at Gnosis, I'm founder of Hopper, the privacy infrastructure that underpins Gnosis VPN. And that's a Swiss-based organization, so you do find me walking around Zurich every now and then. And that happened recently. I had just passed by the Google HQ in Zurich. Funny coincidence, I got a call from Google. So I pick up and I'm talking to Kevin, a friendly gentleman working in the Google platform security team, informing me that there had been a malicious password reset attempt. Okay, I didn't reset my password. My password is also pretty secure. So that's strange, Kevin. What happened? Well, we got a password reset to like Mohammed94@protonmail.com. Kevin, that's obviously not me. Yeah, okay, that was flagged because of an unusual IP address from Frankfurt, Germany, and I don't recall, seeing you in our logs for accessing Google from Frankfurt, Germany. Fair enough. I understand IP addresses. That makes sense. Thanks for flagging. No, it wasn't me. Case closed. Kevin then told me that, okay, it would be nice if I could, just close the case from my side so they could inform me what actually government-issued document, was behind that. Apparently, a government-issued document of mine, had confirmed this. Kind of strange, so I wanted to see the document. I couldn't because of data protection regulations. Funny, I know that. Anyway, so yes, I was, going to confirm that to close this case. In that second, I saw the following pop up on my phone, and I was literally 2 centimeters away from hitting yes, right? This would have actually released access from my Gmail to somebody else out there, because Kevin, of course, was not from the Google Platform Security team. Kevin was a scammer. How did Kevin get me there? I was literally 2 centimeters away from hitting yes. How did Kevin get me that far? Kevin got me that far by establishing trust. And how exactly did Kevin establish trust? Kevin spoke to me in High German, my native language. Kevin did not have any funky accents, which I know from other scammers. Kevin knew kind of where I was. Kevin knew some behavioral patterns of mine. That's pretty strange. Kevin also identified me via my date of birth that you do not find online. Kind of strange. So, I do not know how Kevin identified me. I do not know how Kevin obtained my information. But what I'm describing here is a plausible way of how many Kevins could have obtained all that information about me. And to understand it a bit more, let's go one level deeper. I am, of course, like all of you, accessing the internet. How does the modern internet actually work? Don't worry, this will be brief, okay? So on my phone, I access some domain name service to figure out what IP address is google.com, right? I need to find the home address of google.com to access their service. That's what a DNS does. I fetch information from a cloud hosting provider. There might be some stuff delivered to me via CDN. A bunch of other funny things happen online. Now, unfortunately, it's not that simple. The internet is, and sorry to pick up a Web3 analogy, but it just fits too well in Web 2 and Web as well, a dark forest. In front of all these services, we have some weird creatures lurking that are out for my data, right? And they can get it because that is how the internet works. It's actually not just those. There's like a whole lot of more things between me and the services that I want to consume in an interface. There's Wi-Fi operators, right? We all are connected to Wi-Fi here. There's ISPs. There's things that we don't talk about normally called autonomous systems that route packets from you to Google or whatever you do. All of these players have access to the metadata that I just described. Yeah? And specifically, if we talk about this metadata, about your home address, your IP address, there's actually 2 interesting things. So if you look at these 2 about all these different providers, you can roughly group them into 2 categories. The upper ones are the ones who see where you are. They necessarily need to see your IP address, because that's how the internet works. To send your data somewhere, they need to know where you are, that's kind of obvious. Then there are providers who necessarily see what you do, right? So, of course, Google sees what you do. But Google doesn't necessarily need to know, where you are in that very moment. And I think most of you know what's coming now. There is, of course, a solution for that, which is a VPN. A VPN is basically separation technology that separates the where from the what. Now, legacy VPNs, your Surfshark, your NordVPN, and so on, are effectively, again, just another database, right? They are one central place that see both the where and the what. So you did replace, indeed, trust in a bunch of other providers. You now trust this one that has access to all this information in one convenient, centrally accessible place. So we have to ask ourselves, can we do better? Can we maybe have a new kind of VPN? A VPN that serves the purpose of this separation, the where from the what, without introducing a single central provider. Yes, that sounds a bit like Web3? Okay, yes, that's what it is. So, how do we go about building this? Because this is exactly what Gnosis VPN is about. To unlink the where from the what, we introduce multiple nodes in between that relay your information, right? That take a request, for example, to get google.com, relay it to somebody else until you hit what we call an exit node that sends that stuff out to the wild internet. And now in that moment, the wild internet only sees this exit node, nothing before, including not you. Okay, I mean, that's the overview. Let's zoom in on this path of packets. Packets traversing through this path are being sent from your device through a relay node to the exit, to the wider internet. Usually there's a response because you don't just go to the internet and say, here I am. You want something back from it, right? So data traverses basically through these multiple kind of nodes on the way. Now, Gnosis VPN is not just relaying data like a normal VPN. What Gnosis VPN does is a bit more fancy than that. We also do, now zooming in on the relay part, we do packet mixing. So what is actually happening in any of these relay nodes, data packets are coming in from multiple nodes, and are kind of like shuffled, transformed, and sent out in a different order. That looks very complicated, and that's the point of it. We want to make it impossible, even for some passive, what we call passive adversaries. It's people who can have full network oversight and see every packet on a network, right? They can see everything going in and everything coming out. And this transformation, shuffling, and artificial delay is what makes that impossible. Even if I see every packet going into these nodes on the internet, because, for example, I'm one of these global multinational corporations that can do that, or because I'm a three-letter agency in a so-called powerful nation state, I have access to this information. So, even those players can be fooled when we mix up these packets. And that's why Gnosis VPN is running on top of this Hopper mixnet. Now, that does sound complicated. That does sound pretty bad. We've all seen Web3 products. Not all of them are great. So how bad is it really? What is new now is that we have a version of Gnosis VPN that you can test. That you can test with a booth out there. I'm going to just briefly demonstrate, how that looks like. So we have a Gnosis VPN app, which does exactly what is shown here. So we have basically a node, which is, I should go back here. So on your device, you're sending packets out to this Hopper network, which are then, relayed by multiple others, in the end hitting an exit. Individual packets glued back together, hit the internet, and the same stuff back, okay? So this is what you see in this kind of UI interface here, which is currently syncing a bunch of data. Oh, there we are. Because it was connecting to Gnosis Chain to find out where's everyone else, okay? So this is software which empowers you by having locally running, and this is something I'm very proud of for the team to have shipped, having everything in local state. We're not aiming to ping, RPC providers, gateways which handle that for it. No, Gnosis VPN empowers you as users to have all that control locally. Now, we have that one running. So what are we going to do? So I'm just connected. I'm not yet connected to Gnosis VPN. Okay. So this is just Cloudflare showing me some information of where I am. This is my IP address. For people who haven't seen an IP address, this is how it looks like. And everyone here in the same Wi-Fi has the same IP as I do. I am, of course, correctly identified as being in Germany. So let's connect to Gnosis VPN. I'm connecting automatically to the closest node, or the best node right now, which I think seems to be in the US. So I'm connected to the US right now. So one thing I'm going to do here is, because I'm a weirdo running this in a weird version of Linux, I have to set a name server. So let's see if we can reach the internet, right? This is just me trying to reach the internet. Internet says, yes, I'm here. So what you see on the screen here is just me pinging out one packet, what we had in the previous slide, right? One packet going out, one coming back. It's the same thing. So to answer the question of how bad is it really, you see an answer here. It's 130, like around between 100 and 130 milliseconds latency. This is worse than your normal browsing speed, but still it's about a tenth of a second. So the next question is, of course, how bad is it load-wise, right? So let's see. The next question also then is, does it work, right? So is Sebastian showing us here something that doesn't actually work? Oh, Yeah, I see an IP address from the UK. Actually, I don't know why I said I'm connected to the US, but I'm connected to the UK. Right, so we are connected to the UK right now via a relay node that I think is somewhere in Sweden. So my data traffic here, when I loaded this website, was going from Berlin, chopped up into little indistinguishable packets, mixed up, sent through Sweden, to the UK. All right, that's not maybe a normal page that you access. So let's see something else. Let's see, YouTube. Okay, there's a bit of delay, but it seems YouTube works over Gnosis VPN. Cool. Right, so Gnosis VPN is in an early test version live right now. I invite you to come by the booth outside and try it. I also invite you to go via the confessional and get an access code to try it yourself. What we have seen here this far was basically all this mixing. This is live right now. One caveat is the current version is not live for production use. Do not go to all your friends and say, hey, please use Gnosis VPN. This is a test version, and we want your feedback to know what we should improve before we launch it publicly. The infrastructure of these nodes is currently operated by us. That is something that we're going to change before going live for real. Now, finally, I would like to dedicate a slide to Mulvad. Mulvad VPN for standing up to bullying of the UK government, because governments around the world are, in my eyes, increasingly weird, doing things that I do not quite understand, like banning access to technology. And yeah, the people here who have followed the Mulvad ads, especially in the UK, seem, how they're standing up to that nation-state bullying. So I think, and that's why I bring it up here, it is something that people understand. There are more people right now using a VPN than there are people consciously, intentionally using AI. So with that, I'm coming to the closing. Why does Gnosis need a VPN? People know of VPNs. People want VPNs. I think people should have access to the most private VPN you could possibly build, and that's what we're doing with Gnosis VPN. So the VPN space, when we started this collaboration here 3 years ago, was a $45 billion market. Now it's 80. So of course, not all of them use VPNs for maximal privacy. There's the corporate use cases. There's the I want to watch Netflix when I'm traveling use case that I hope Gnosis VPN can also cater to. But it is actually possible to build a VPN that is values aligned, tech aligned, and product aligned with Gnosis. And that's why we are building Gnosis VPN to give you access to a responsible internet access. And with that, I'm closing here. And again, I invite you to test Gnosis VPN at the booth, commit your privacy sins at the confessional, and in exchange get access to the VPN. And yeah, enjoy a private drink and a smoothie stand. Thank you so much. I'm open for some questions.
Questions? Got one there. Yes, here. There. Yeah. Okay.
Raise your hand so we can see you better. There was a question front here and some back there. I don't know if we have a mic for you guys, and there's another question back there.
Got a mic here.
Okay.
Is there a mic here? Mic here?
Yeah, there's one there.
Oh, okay, okay. Hey.
Hi, Sebastian. What would you say to someone who's maybe a bit more of a Web3 skeptic and say something like a Proton VPN, where they have these sort of legal and governance protections, supposedly, where user logs can't be kept? What would be the privacy case for Gnosis VPN that's a significant improvement over what, in theory, can be achieved through some very stringent Web 2 architectures?
That's a really great question. So I like Proton. I'm personally using Proton. I like Mulvad. They're great. But the trust assumption is always that one provider does not keep logs. And it's a lie, even for those good providers. Why? Because they are building on, corporations which are operating within the framework of nation states. And guess what? In a nation state, you do have to comply with the, law and the police. And when you, for example, get subpoenaed to log and track people, you just have to do it, otherwise you go to jail. These are your exact two options. And of course, they do provide, that access to law enforcement as and where needed. And yeah, this is something that you just have to trust them to not do. So in case of Gnosis VPN, your trust assumption is that any one of the relay nodes between you and the internet is actually, mixing traffic effectively. As long as there's one honest node, you're fine. And this is, by the way, also better than Tor. So some here might be users of Tor, also fantastic technology that's been around way earlier than us. The trust assumption of Tor is, where you relay internet traffic via multiple, like hops also, is that the first and the last node do not collude, which is also strictly worse than the trust assumption of Gnosis VPN, which is one honest node. So that's the kind of privacy case here. There's a question back there, and I think something over here.
So thank you for the talk. You've mentioned that currently the infrastructure is operated by Gnosis, and in the long run this will change, right? And you've also mentioned that all the data for traditional VPNs is kept by one company. What is the long-term vision for distributing the infrastructure, and also how can you make sure that no bad actors get info that is relevant to users, right?
Yeah, excellent question. So I would say the biggest point is by removing ourselves from the equation. We do not operate again, this is not live, okay? This is a test version only. Once it is live, we do not want to operate, all your nodes. There will be individuals who operate nodes, and in fact, the underlying infrastructure, this Hopper network, the MixNet traffic, is already live with around between 200 and 300 nodes that are operated by individuals on their DApp nodes. By the way, shout out if you, don't have a DApp node, get a DApp node, run nodes, and run Web3 infrastructure. So yes, that is the way how we want to distribute that, right? So we need multiple relay nodes. We have that already. We need exits. Exit is a dicey topic because you expose your IP address to third-party users. We will have some precautions in place to make it as safe as somehow possible for you, but that's something that you have to decide. And to the last part of your question, who is a bad actor? Well, that is inherently subjective. I do not know what's a bad actor for you. What is a bad actor for a citizen of the United States is not necessarily a bad actor for a citizen of China, right? So what is a bad actor is something that every operator in this network has to, make a conscious choice on, and we want to give them the tools to do so, and to do so safely from wherever they operate.
Hi. So decentralized deepen kind of sectors like Gnosis VPN of what you're building has existed for some time already. So NIM is an existing competitor. So two questions. One, how are you competing against existing ones like NIM that are large at scale already? And the second question, I guess, is are you guys raising? What valuation you guys are at? Would love to hear about the revenue model.
Sure. So first of all, we're not really competing against anyone. No decentralized VPN made it absolutely anywhere. NIM is great. They also build a MixNet. We also build a MixNet. Our VPN actually works over the VPN. What I showed you just here was running over a VPN. I just invite you to try that for NIM. I'll keep it at that. And yeah, so no, we're not raising. We are supported by Gnosis DAO. Gnosis VPN is built and 100% owned by Gnosis DAO, thanks to GIP 98 and 229. No, 222. And yeah, so this is a part of Gnosis DAO. The product is being built right now, mostly by the Hopper team with support from the Gnosis team for Gnosis DAO. More questions? All right, then I guess we can close just in time. Thank you so much. Stay private.
Yeah, so we're going for lunch break now and be back at 1:30, about 40-50 minutes. See you guys.
Hello, everyone. How are you doing? Welcome to the most difficult session of this day. You know why? That's post-lunch session, which is always a challenging one. I hope you had some nice lunch, nutritious, fresh. Feels like almost unlike the internet of today, which doesn't feel very fresh, which is not very nutritious. Feels a little bit anxietified. Thankfully, we have somebody to do something with that. So please give a round of applause to Andreas Tsemaros from Fivers.
Hello, everyone. How are you? So, I have quite a light-hearted talk for you today. Contrary to our usual talks, for those who are familiar, we're not going to talk about guerrilla interoperability. We're not going to do a deep technical dive into the Fiverr stack or how to ensure self-sovereignty into your apps. Instead, I want to introduce you to an analogy that I'm going to be using and abusing throughout this talk. It's an analogy that speaks specifically to people in the room that might be more working on consumer apps or trying to distribute apps or technologies that they just built and that preserve the privacy of their users, that are self-sovereign or are decentralized, but have experienced the exact same problem that we have for the past 2 years, which is that the cognitive load in order to explain to the average person that is maybe not a technologist or not even in tune with what's happening in the space, it is way too high for someone to get up to speed to why privacy or even decentralization is important for them. So we've tried different approaches throughout those years of having ddocs.new and dsheets.new in our public beta. And one of them, a more recent one that has been working quite well in some of the talks we're doing at university and some communities that are completely out of crypto, specifically European tech scenes that are not only not familiar with crypto, but maybe even a bit hostile towards it. So we always try to find ways to talk about those things without directly mentioning the B word, blockchain. So the analogy today is about the ultra-processed internet, but the actual talk is really on digital sovereignty. For those who don't know, I'm one of the co-founders of Fivers. We have 2 public beta apps, ddocs.new, dsheets.new. There are full feature parity alternatives to Google Docs, Google Sheets, Excel, Word, but they come with end-to-end encryption. We cannot censor you. Even if tomorrow we all disappear in the team, you'll still be able to take your data with you and rage quit our apps without needing to ask for our permission. So let's get into it. There are 3 parts to the talk. I'm going to keep them really quite light. The first one is on how to make digital sausages. You'll apologize, you'll excuse me for the analogies throughout the talk, but I'm going to stretch it as much as I can, and you're going to be my guinea pigs to see if it actually sticks or not. So, the first part is really about ultra-processed food and how we can draw some of the narrative built around it over the past 25 years and use it for our digital environment in order to make it much easier for even my grandparents to understand why it is so important to actually have a healthy digital diet. And it's not just a luxury to have privacy or some decentralization. I will, in the second part, just briefly mention the AI wave and how it's accelerating a lot of what we call over-processing of data, over-processed apps, and the insidious characteristics of ultra-processed apps, including mass surveillance, including lock-in mechanisms, etc. And finally, I'll just give you the alternative, what we call sovereign apps, apps that allow you to have a healthy digital diet without having to learn everything from the ground up or convince everyone around you to switch apps so that you can actually communicate with them, etc. And what are those nutritious characteristics in those apps that you should be looking out for? So let's start. Quick definition. What is ultra-processed food? I think we all have a small mental model of what it is, but more precisely, we refer to ultra-processed foods as industrial formulations made mostly from substances extracted or derived from foods, combined with additives, artificial flavors, colors, sweeteners, and they come with little to no intact whole food remaining within them. I'll give you some examples after. And a simple way to spot them is that if you look at the back of your hyper-processed food, you'll see a list of ingredients, substances that not only look like your chemistry class manual, but also is things that you would never have at home or never even consider cooking with. So, what do we know about ultra-processed food? I think you're all really familiar with the consequences of those things. Every day we have new research. This is one of the latest one on how it might be connected to dementia, but the risks are quite prolific. You have obesity, weight gain, on average 500 more calories per day to the person that is consuming ultra-processed food. Type 2 diabetes, very connected to it, cardiovascular diseases, including heart disease and stroke, a bunch of different cancers, depression and anxiety, early cause of mortality altogether. Sorry, I started by saying it's a light-hearted talk, and I'm now talking to you about all the diseases you can get in your life. So, the reason why it's so important to draw this analogy and why I want to stretch it as much as possible is that if there is one thing that has widespread consensus despite political divides, so across the political aisles, is that ultra-processed foods are harmful. Whether it is your current left-wing administration or the next right-wing administration, they have this point in common, their voters as well, which is the understanding that what they're eating is not good for them and there needs to be an effort to dissociate or try to introduce more healthy food into people's lives, which is, of course, not just something to do with the click of your fingers. It is a socioeconomic matter because it is the less wealthy among us that are most often focused on ultra-processed food consumption. So the solution needs to be general and not just targeted. Now, how are those ultra-processed foods made? Anybody knows what this really appetizing pink goo is? Chicken nuggets, yes, okay, I see we have some fellow Redditors in the crowd. So yes, this is your average chicken nugget. What's wrong with it? So first of all, it's one point that I'll keep coming back to, especially in my analogy with digital apps. It's impossible to tell what the hell is inside. Okay, so okay, the final product, you think you're eating chicken, but actually it looks more like the Play-Doh of my little cousin. So those ultra-processed foods, they're engineered for what they call the bliss point. So the exact ratio of salt, sugar, fat that maximizes your cravings without actually satisfying what your body needs in terms of nutrition. They're stripped, again, of all the nutrients, fiber, vitamins, and whole ingredients removed to extend the shelf life of those ultra-processed byproducts. They're super obfuscated, sorry for the language, AF, because they're designed to make it impossible, like we said, to see what's inside with the naked eye. And even if you have the description, they always play with the actual components. For example, if you eat a yogurt that says 0% sugar, you should know that they can play with the 0%. Anything under 0.5% is actually considered 0% legally. So there is always little insidious way in which you're being lied to or fed something that you thought was healthy but is not necessarily so. Finally, this is maybe more of an economic logic, but the reason why those things exist is that it allows for cheap ingredients, it allows for setting prices that are incredibly difficult to compete with, and so are hyper accessible to people that are potentially struggling or not able to go to your average Whole Foods and buy a $15 salad. So, just one extra example, Pringles, which I'm a big fan of, unfortunately has less than 50% of potato. So it's just a good indication of, even something as simple looking as a potato crisp is not a potato crisp. Now, for the digital side of the talk, the same playbook is applied to a lot of our digital life. This is where I'll try not to stretch too much the analogy, but you'll see the same words appearing from hyperprocessing to obfuscation of ingredients to the addiction that they're designed to cause in you, etc. You recognize the logos. I don't need to go into them. So, sorry, my slides are a bit all over the place. I will justify the provocativeness of the picture in the next slides, but essentially what both ultra-processed food and ultra-processed digital diets do is that they create a dependency for their users, for people consuming them, while delivering diminishing value. And both use the same tactics, obfuscation of components, convenience, addiction, price points that are impossible to ignore, monopolistic distribution, etc. So just to go a little bit deeper into it, sorry, I see the slides are a bit all over, but we'll persist. The first is that they're okay, yes, sorry. The first is that they're engineered for the engagement peak, really trying to maximize the amount of screen time that you dedicate to that product, to that service, etc. The other is that they strip people of their agency, either through opaque algorithms, through data extraction, lock-in mechanisms that make it very difficult for you to even understand how you could get out of the platform. This gets even worse with AI systems. We'll touch on it in a bit. Of course, they're optimized for profit, so user experience degrades as extraction increases, and you have really antagonistic incentives on both sides here. You have closed-sourced components, so most of our apps, at least those that 3.5 billion people spend every day on, like Google Docs, like Google Drive, like TikTok, etc., we know very little about how they're actually made. The servers are out of bounds, the code is unavailable. Even if it was available, it changes every day, and there are new mechanisms introduced without you actually knowing or ever consenting to. Last time I connected to my Microsoft account, there was a big fat Copilot message telling me that now I should write not with my own thoughts, but by using the AI that Microsoft provides. And this contributes to that hyper-processed digital life we're creating, which I'm trying to press pause on. The other is that the packages promise privacy, promise fun, liberation, etc. But you cannot actually verify it. Even if there is a label, there is no proof, there is no way for, from the technical to the average person to actually verify any of the claims made. Same for those apps that claim encryption, privacy, security, but those are mainly marketing words and don't provide the tools to verify the claim. The pictures will continue worsening. If you can't inspect it, you cannot trust it. It's a very simple motto that you should carry with you as you go through your digital diet reformulation, let's call it. And one slide here is dedicated to the concept of enshittification. Most of you are probably familiar with the term. For those of you who are not, it's something that was coined by this activist / journalist / technologist Cory Doctorow. It became the word of the year in 2023, so it's catching on. And it describes basically a process in 3 stages in which every platform we know and love, or used to love, becomes shit. So the first is you bait. Same thing with hyper-processed food, but in digital platforms, you try to be good to users. The first time they are introduced to you, you offer free features, great UX, you subsidize the prices as much as possible, which, by the way, is exactly what is happening today with AI. If you think that your $200 Claude subscription is going to last, I have bad news for you. So Amazon is well known for that. They were selling below cost. Google gave clean search, but then started introducing ads everywhere, and now something even worse called Gemini, etc., etc. Then, the moment that they reach a certain critical mass of users, they switch. They start abusing those very free tier users and concentrating most of our efforts towards business customers that come with big bags of cash and are actually much more in line with what the bottom line of the company is, which is maximize the amount of money coming in. So from that point onwards, you start seeing more ads, more data harvesting, surveillance or bulk data collection you never were made aware of, or that weren't even present in the privacy policy, but suddenly are, and nobody kept track of. So this is how organic search died. This is how sponsored content is now the first 4 results you get on Google search, etc. Here is the lock-in business. Here is where you lock in businesses as well. Finally, you go into the full extraction phase where even your business customers get abused, ad prices go up, quality of the ad reach goes down. You can see it with Meta, their ad business is going down significantly, and they're trying to resubsidize it now in order to make it attractive again for businesses. But unfortunately, by that stage, you're locked in. It is very difficult to get out of those platforms, especially if you've built a bit of your career, your persona, your business around it, and you've already sunk $1 million into trying to build your distribution machine into it. So this is how platforms die. First, actually, we just did the more advanced description of it. Next, you all know those platforms. Google search went from organize the world's information and don't be evil to SEO, spam, sponsored result, and AI-generated slop everywhere. There is a nice slide next about this. Facebook, same. It started for friends and family. Well, after the try to find a girl that is hot on your campus, which was the original idea of Facebook. And it became a cesspool of rage bait, ad saturation, etc. Amazon, same. It used to be the everything store, and it became anti-competitive platform by excellence, where if you have a product that does well, they undercut you with their own alternative at a lower price, so you get completely obliterated out of the platform. Same for Twitter, no need to tell you, you probably all have mental health issues because of it, at least I'm projecting what I have. Uber, same thing, wage manipulation is rampant at the moment. The Europeans are trying to regulate it, but it's not working very well. Spotify, Adobe, Notion, Google Docs is one that really pisses me off the most. One, because we're building something that is its alternative, but mostly because it was such a simple app. I wanted to write on it, collaborate with people, and now I'm supposed to have everything rewritten by some slop machine, or my colleague will send me a document that is sloppified from start to bottom, and I have to pretend that, yeah, okay, it was a great document. Let me give you some feedback. So, and it's hard to think of any platform that we all use that hasn't fallen into that slow decay process. Now, I'll skip this. It's pretty much the same, that you get 0 guarantees of privacy, portability, agency, etc. It gets worse and worse. I don't know what your screen time is. Mine is double this average. So it is important to see those metrics as just a big call for how urgent the problem is. Now, just a few things about AI, because it is one of those mechanisms or components that is accelerating the process that I am describing here. Go do your own little tricky searches on Google, and you'll find incredible results. So how many rocks should I eat per day? According to a geologist at UC Berkeley, you should eat at least 1 small rock per day. Okay. This is one of the most used services on the internet, and we're supposed to accept the introduction of AI without the consent of its users as progress, rather than what it actually is, which is just an attempt at extract more value from the users on those apps, even at the detriment of even the basic purpose of the original app itself. So instead of getting search results, you're getting some predictions that are statistically defined on what could a good rate of rock eating look like. So this goes everywhere in multiple categories. You have AI spam floods on most social media, synthetic media that is introduced. You cannot even distinguish anymore if you're looking at a real image, video, etc. With it, the trust between ourselves, between communities, even towards a platform erodes. You have hyper-personalized behavior manipulation. This, even before AI or before transformers was a big issue, you had the best engineers in the world and billions of dollars behind them, all optimized for how do we get Andreas to be addicted, or to get him to buy the next shitty product based on his Google image searches. And now it's becoming even more personalized, even more widespread across the internet. It follows you, etc. Price discrimination is completely related also with AI being pepper sprayed everywhere, not pepper sprayed, the wrong analogy, kind of. Yes, basically those traps are getting smarter. The 4 boxes here kind of say the same story. What I want to get your attention on is that it's about to get much worse on your favorite AI tools and platforms. One warning sign that I discovered recently, I just wanted to share it, is that Fiji Simo, who used to be the architect of Facebook's news feed monetization, is now the chief executive of application and business at OpenAI. And there is this great quote by them, which is, imagine AI that changes its answers depending on which business paid for the priority slot. Amazing future ahead of us. So let's go into the solutions now, or try to get you a little bit more optimistic about our future. These are some of the principles, one missing, I'll add it in a bit, about for nutritious software or a healthier digital diet. One is that you want end-to-end, meaning platforms transmit what user request and not what the algorithm inferred or preferred from the activity of the user. So remove the opaque intermediaries. The right to exit, or the right to rage quit if you prefer, which is I want to leave a platform without losing my data, my content, my social graph, and I want that freedom not to be dependent on the platform telling me, yes, give us 6 to 10 years of business days, and we'll get back to you on if this is possible. Or they'll give you a big fat CSV file like on WhatsApp, which nobody knows how to dissect or make any sense of. Maybe it's a bit easier today with AI, but still worthless most of the time. You want data sovereignty, so you want to own your data, period. No fine print, no change of policies that suddenly make you unable to rely on the mental model you had for the platform that you're using. No hidden surveillance, which keeps getting worse, including with the mass introduction of AI everywhere. Interoperability. This is something we spend a lot of time talking about in our team. We gave a talk recently on guerrilla interoperability, so the concept of even if the app you're using does not allow you to interop with another app or take your data out, there are ways for you to force that reality onto the centralized app. Check out the YouTube video if you're interested in more, or come talk to me. Transparency, open source code, anyone should be able to audit, modify, and improve. No more black boxes. And finally, sustainability, something that ideally is funded by users, not only advertisers or not at all, and where the customer is the user, not the product. Finally, one that I'll add, I missed it here, but end-to-end encryption, we believe very strongly that it should become the next core primitive on the internet. We're collaborating more and more on all types of files, in all types of platforms, and it's important that we try to actually have privacy by default everywhere. Just a quick table. I won't go over every detail of it. It's more for a picture if you're interested. But some of the most important features are privacy, data ownership, no vendor lock-in, verifiability of the software, no censorship, a business model that's sustainable and not by default design against the benefits of its users. And here are some examples. Finally, just a quick slide. I won't go too deep into it because I'm over time already. Sorry, I have a propensity for a bit of blah blah. Which is the local first philosophy, or what more recently people have rebranded as file over app. What is it? Very simply, in most of today's digital tools, it is a philosophy of app over file. So your data lives inside the app, on their servers, in their proprietary format, PDF, docx, it's not open formats. Leaving means losing all that, meaning losing really your digital life. You need permission to go, the app is a product, etc. File over app, which is how we built every app at Fileverse, is puts the file as the centerpiece of everything that you do. So your data lives in your files, in the files that you own, in open formats, on your device ideally first. Apps become interchangeable tools that read and write your files, and you can swap them freely. So if everything becomes a file, it doesn't matter what app you're using. You can go from one to the other and get the best UI that you want. You can walk away very easily, and the file, of course, outlives the app. the company can go bankrupt, the company can disappear, can turn evil, etc. But if everything is centered around your app, you don't really care. So own the file and you will never be held so hostage by the app. Finally, 1, 2, 3, 4, 5, what can you do to reclaim your digital diet? One is ask yourself what apps you use daily, which ones are ultra-processed, which nourish you. Second, substitute those apps ideally, especially cloud monopolies, find sovereign alternatives, own your data, support open source, advocate for better apps out there. This is just an example of the ones to avoid and the ones to actually move towards. For those that don't know the logos, you have Founders, Brave, Radical, Tor, Empire, Signal, Graphene OS, Gnosis, and Movad. Highly recommend all of them. And I'll finish, wrong slide. Okay, I'll finish with that actually. Thank you very much. I don't know if I have time for questions. If anybody wants, come find me later. Yeah, thanks.
Right. Guys, have you ever felt an anger that actually led you into something positive? Our next guest definitely had. And during the Iran internet disruptions as a technologist, he felt a lot of rage, unable to do something about it. So later he did. And right now he will invite you for a story of how rage coding can actually bring useful solutions into the existence. So please welcome Shayan Eskandari from Rebellion Systems.
Thank you. Hello, everyone. Welcome to this talk. So I'm going to talk about the mad scientist shit that matters. And this is more of the story that I went through in the last few months. So just a bit about myself. I'm Shayan Eskandari. I'm a security researcher, a hacker, educator, and human-centered technologist. I did my PhD on blockchain's unforeseen consequences, which is like front-running, Oracle failures, and the dark side of permissionless. In the last decade, I've been doing like smart contract security. I built enterprise staking infrastructure for Ethereum. And also, for the context of this talk, I've been co-founded Iran Unchained, which was like a DAO using crypto to route through geopolitical exclusion. And also, I've been teaching Farsi speakers and Iranians about crypto stack and technology since 2015 through something called Coin Iran Academy and also Shir Khat podcast. But my latest obsession is Moav, mother of all VPNs. So just to give you the context, internet shutdowns is not a new thing. It's not a one-off thing. So Iran has been going dark for the last 15 years or even 20 years. And there have been many incidents. Every time they learn what connections were leaked, and they basically make it harder, make it bigger, and make it more complete. And they learn from every shutdown and every internet filtering. And this year has been one of the worst on the record. Basically, most of 2026, Iran has been offline. It started with January 8 and 9, which was the Iran street protests against the government. And they shut down everything this time. This time was like SMS, phones, even intranet that usually works. They were all cut down. And during those 2 days, around 30,000 to 70,000 people were killed in the streets. And then internet came back for a bit, and then the war began, and internet went blackout. There was 88 days of full internet shutdown. which later in late May, which 3 weeks ago, internet came back in a really weird state. And what I mean a weird state is, so 2 weeks ago, Azerbaijan ended up being the #3 country for the ChatGPT usage, which they have like 10 million people population, so that's not really possible. And we noticed that Iran's traffic is being routed through Azerbaijan for some reason. And this is, before we say this is like Iran's problem, it's not. We're seeing that to becoming a default, global default. We've seen in Nepal, after the social media ban, there was like 3,000% VPN demand, getting VPN demand. In Uganda, in the United Kingdom, we're seeing that with the age verification. And Iran, after it restored, there was 1,000% VPN demand, extra VPN demand. And all these peaks are basically a population trying to flee to free internet. So it's almost a digital immigration happening. And we're seeing like also governments are trying not to ban VPNs, but also DDoS VPN infrastructures with Russia. And we've seen conversations in the US about banning VPNs. So basically this is a different flag, but the same playbook. It's control the network, you can control the people. And this is not going away. Like as you've seen the other talks in the today and yesterday, VPN is becoming one of the main topics. And I want to use the Cory Doctorow enshittification framework to just talk about some of the Web3 aspects. So for a refresher to be on the same page, basically he talks about, like, let's say, social media and Facebook, that Facebook started saying, MySpace is spying on you, come join me and be Facebook users. So you're good to users, you capture the users, you lock them in, and you start to abuse the users for your business customers, show them ads, and then you end up abusing the business customers to extract more value from them for the shareholders, and then the platform starts to rot. It becomes a giant pile of shit. And the way he talks about it is like when they start talking about metaverse, that's where this happened. We're seeing a similar thing happening with internet infrastructure, but for this crowd, basically I want to talk about like Web3. So in Web3, I feel like we forgot the promise. We're talking about privacy, but like basically the cypherpunks started with writing code. They were like, we want communication privacy. We want to define our privacy with cryptography, with remailers, signatures, electronic money. And basically, we want to communicate through borders without being under surveillance. And now, 30 years later, basically, we captured all the builders through this promise of the communication privacy. But then we captured these builders, and then VCs kind of took over, and they started to optimize for what could be priced and sold. And the thing is, basically, financial privacy can have a business model and can be priced and sold. But communication privacy, for someone, let's say in Tehran, doesn't have a business model. And we couldn't forgot about that. Now we have like privacy for enterprise, which I don't know exactly what that means. And but the people that need it, they still can't access it. And this is not cypherpunk anymore, in my opinion. So just to show what the gap is, so basically we start to build for the top of the stack. We built for app layer, for protocol layer, for transport, which are all good. Like we build wallets, dApps, L2s, IPFS, we build like the ENS, they're all good, I'm not gonna lie. But we forgot the bottom side. So we forgot how, if those bottom sides get cut down, nothing matters on top. And it also just vanishes. And this is not necessarily a failure of imagination of like the technical failure. This is a failure of imagination of who the adversary is and what extent they could go. And this is kind of like my personal story here. So I'm Iranian diaspora. I spent like over a decade teaching Farsi speakers about crypto stack, tech stack, cryptography. And when these blackouts happened, it was all worthless. No one could use anything on Web3. And I couldn't even reach my own family. It's not like my message were blocked. It was not being delivered. And I ended up, like, after the initial shock that was gone, I started basically rage coding. I felt helpless. I was like, I needed to do something. And I started rage coding, and it wasn't necessarily for any financial future. It was like for a better now, for getting someone through. And to be honest, I didn't have any hope that it's going to work. It was just for my own sanity. And then put it out there, tweeted about this, and I saw people actually getting through. People are getting to internet through this software that I was building. And around late February, when the full internet shutdown happened, everything went silent, and I just broke. I failed. I felt like I was defeated. Basically, I closed my laptop, walked for a few days, came back, looked at some of the charts on those servers, because I was already donating to the anti-surveillance, anti-censorship protocols, and I realized people from Myanmar are connecting, people from Russia, China, even UK are going through this traffic. But I made this application initially for Iranian users, but there were none of them. So I started continuing the work. I fixed bugs, I added more protocols. I read so many Chinese and Russian websites and Telegram messages to understand how they get through these, and kept adding these. And later in May, when connection came back, it started working again. I saw Iran in the charts again, and it made me so happy. So I continued on this. And just to say what this is, basically it's the idea of MOAV, or mother of all VPNs, is not really elegance, it's redundancy. So you can use basically one command to run all possible protocols that I could find. So I wasn't going for the best VPN protocol. I was going for all of them, any protocol that is out there. So you run one command, it sets up everything for you. And in security, a lot of times we're saying the system is secure till there's one security hole and hacker can get in. I'm kind of looking at the other way around. The sensor has to block all the protocols, but you only need one to get through. So this is kind of that way. So any stranger can become like a VPN provider for the whole population, for the whole neighborhood, for the whole household. And MOAV, like mother of all VPN, started as a joke, but then it became the thesis of this application. And it only needs like a really small VPS or Raspberry Pi. You can set it up. And the specific problem I was trying to solve then, it's really hard to explain for people outside Iran. So in an internet shutdown, it's not like everything's unplugged. People inside start running scanners for the whole internet. It's similar to like you looking at the stars to find life. They were like trying to ping some server that is alive for them. And sometimes they could. Sometimes, like one example was the Azure cloud in North Africa. Some IP range in there was pinging. And then we have two really brutal problems. One, can we get an IP address in that range, which is a technical problem for outside Iran. It's possible through brute force, however means. The other problem is like when you get an IP address, you're basically beating the clock. There is a time that that IP address would be blocked. And you want to get traffic through as soon as possible. And basically with this one command, you already have configurations for your family, friends, and also contributing to Tor, Snowflake, Conduit, and Siphon, all these to get traffic through. And then you have a day that you come and there's no traffic. You notice that like that server has been, that IP has been blocked. But for a few days, you gave internet to people that needed it. And just to show like how it works, basically there is like one box every route out. I just realized I modified these slides, but this is like older version. But so the blue box there, this box is MOAV. So basically, if you have like inside Iran, China, Russia, most people on their phone have some kind of VPN apps. And there are some collection here. So whatever you have in MOAV, there is something for you to use. At the same time, we're contributing to Siphon and Tor through Snowflake. That means you become part of the infrastructure for anti-censorship internet. And these are the parts I really love, that it becomes part of the infrastructure. And just to show it's not just slideware, so when you run the command, you get this terminal UI that helps you set up everything. And you have an admin dashboard that gives you like some information about what is happening on that server. And you have like a Grafana metrics really detailed in like which countries, what protocols are working, so you have better sense of who's using your servers and how this traffic is going through. And that's where I was seeing like no Iran and China and Myanmar, and I realized people are actually using this. And there is an arm race here. So in a lot of these places, there is deep packet inspection that starts to like understand the packets and the traffic, and it starts blocking the obvious traffics, like OpenVPN, WireGuard, and these kind of things that are obvious gets blocked really fast and one by one. But we see that this creative resilience that routes around it. So one of the things is SNI spoofing, which is like a lot of these infrastructure need, let's say, the smart TVs. They want smart TVs to be updated, but no one can have access to internet. So they left like update.samsung.com open. You change the traffic to look like those updates, but goes through Moab server and like you can have access to internet. Goose Relay is one of the ones that I really like. Google was blocked, but Google infrastructure was open, some of the parts. So they use like script.google.com to be able to route traffic through Google infrastructure. And also Ballet VPN is one of the ones I really love. Ballet is one of the state-approved chat apps. It's fully backdoored. But people start using the WebRTC video call media there to get traffic through. And it's similar to Protozoa, which is an academic paper that was used in China and Russia. And also DNS tunnels. DNS is the last thing that the governments can kill. And you can still use that to move around text. And one of the things about this is like these were mostly built by people inside these internet shutdowns. So I want to put this out there and talk about what's actually out there and what is not. And I want to be really honest here, because if I oversell any of these, people would get hurt. Like they actually trust that technology. Another example is a GitHub over channel that like GitHub was also filtered. GitHub CI was open, so people did basically TCP over Git, which means they would like commit a Git with a URL, their GitHub action would download the file, and they could like clone and pull the server. That was like another interesting way of doing this. The feed is something that saved a lot of lives, that used Telegram or news over DNS, so you could get some news about which regions of the city you have to evacuate and some others. Netagram I'll mention in a minute. A few call to actions here is more, so there is like Starlink neighborhood sharing, which there's a NASNet and some other similar projects that you could share your Starlink connection to your neighborhood or through your friends that you want. But there is a high risk of being arrested if it gets detected. We know that there is like power line networking possible. Why don't we have similar networks to share internet to the building without that detection, without using the other infrastructure? This is more part of like pirating the infrastructure that exists. We've seen like dial-up revival in like Egypt 2011, that they used dial-ups to be able to like create new connections. And offline payments also have a whole slide about this. And one thing to know is, so the tools that worked were actually built by people living inside these blackouts. And there are research around this which they call this grassroots infrastructuring survival work, which we need to look into more in this space. And so Netagram is another project I rage coded in the same period. So the only time in that period that someone could connect was calling from inside landline to outside, actual landline calls. And I was still working on this VPN, and I wanted them to test. So I was like, maybe there is a way to use phone to move data. And that's where I built Netagram. Neda in Farsi means voice. And basically the idea is like you paste your configuration, like any data you want here, it turns it into voice, and then it uses the same technology as NASA uses for Voyager from Interstellar to communicate over the phone, because phone is noisy, you need to be able to convert that. It's really slow. Also, they need internet to load this first time. It works fully offline. It even has like NPM package you can use. And it might take around 6 minutes for 1 kilobyte, but still, like, it works. This is another, like, this is where a friend of mine called this is math scientist shit, and that's where I got this word from. And these are something that I want to also talk about in this Web3 conference, more offline payments. So a signed transaction is just data, right? Like you should be able to like use your wallet, sign a transaction, send it with a carrier pigeon, Netagram, like Bluetooth, whatever, and then somewhere else that is online, you should be able to broadcast it. And it's kind of embarrassing that we don't have it right now. Like with Bitcoin, there's partially signed Bitcoin transaction that it kind of is, it works. We have Cashew, which is like the closest to what I have in mind. It's Bitcoin only, and the mint needs to be online. But for EVM wallets, like MetaMask, you can't even build an offline transaction. If you're offline, you cannot even build a transaction, because it wants to get nonce, gas estimate. There are all these technical possibility there, but we don't have it. And even if let's say if you do this, you cannot export that data to give it to your friends, through Netagram, to other ways to broadcast it. And it's really embarrassing, in my opinion. And that ends stable coins even not feasible to do offline. I know there's like some trust anchors, like double spending, there are these issues, but the small value payments can work today and they can save lives in these regions. It's not about just wartime or internet shutdowns. We've seen in like Spain and Portugal, there was like days-long power outages. Like in those, your wallets do not work, even if you have a way to communicate, because you don't have internet on those devices. And basically my ask here is like, if you're working on a wallet, not necessarily a new wallet, I don't want a new wallet for this. I want MetaMask, Rabi, all these, to have an option to export your signed transaction to use in other means. And if you can, using ZK, escrows, state channels, make it possible today to do $100, like maximum $100 of like offline transactions. Because if $5 transaction can buy food in these regions, but at these points banks are out, internet is out, there is no way to do value transfer. And another one is like, we have pop-up cities. We run pop-up cities. Why not pop-up mesh? So why do we use Discord in these when we have Delta Chat, Metrics, Jitsi, we have BChat, we have all these, so we can have a network like this that has its own payment network and everything. Payment network for this kind of situation doesn't need to go through the network, through the internet. And there are some relays. Some interesting thing, so did you know there's like 2 mesh networks already here and you're not even aware of? One is BChat, which it's only me and Florian from Freedom Browser, that we every day we say yo. And also yesterday I have a Meshtastic node with me which uses LoRa technology, and yesterday I was able to connect to Václav from Logos, and I went to the office, and they're trying to do really interesting ways of using this mesh. And that's one of the parts I came to this space, these experimentations, this crazy shit that we want to build. So let's, for the next pop-up city, have our own mesh, have our own chat, and after we're done, it all evaporates and we don't need that, anything else. And that makes people to build better tools, be more accessible, have these apps if the internet goes down, so be able to use them. And back to the activist morale, is like, you don't have to win the VPN and internet censorship. You just have to make it expensive for the government to censor you. And we've seen this before, like two decades ago, they only started to block DNS queries. And people start building the DNS over HTTPS, DNS tunnels. Then it was like deep packet inspection fingerprinting that you cannot go to like facebook.com. People started using proxies and SNI spoofing. And now we have like IP blocks, which we use Cloudflare and CloudFront to like bypass those. For the total blackouts, if we create those mesh networks, we don't need a global wide internet. We just need these local mesh that works, and they can just communicate and live their lives. This would really save lives, and we just need to keep raising the price on censorship. And one thing I learned about this last few months is the community is the infrastructure, is not the side effect. And while I was making Netagram, I was way beyond my knowledge on like signal processing. And someone showed me a few papers about Voyager, how they use this, and that actually made Netagram possible. There was like developers that are outside there. There was actually someone, a NIM developer, that helped me with more of like making it more secure. I don't even know who that person is, but they helped me. There are activists, like there are so many people inside Iran and China that helped me test these in the situations that I could not test. And also translators. This whole community is the infrastructure. And just, we should be aware that these tools would die the moment the people maintaining them burn out. In March, I almost did. So take care of each other in these situations. And just to say where we're taking Moav, like I'm taking Moav in that sense, is, so the idea was like it helps everyone to get access to internet for their VPN. But then I realized, well, we have all these protocols. We can have a Moav client to use all these protocols and use the ones that actually get through. So if you're in a region that you want to test it, or if you just want to test it, let me know. I can send you VPN configs from these test servers. It's easy for you to also run it, but I can also provide that. Another thing I want to do is try tougher transport layers, more VPNs. If you know any exotic VPNs you want to add, put the GitHub issues, me and Claude get on it. I want to implement NIM and Sentinel, and recently I was talking like Gnosis VPN as a relayer. The only thing is, like, I don't want to add complexity. I want to keep the server running to any non-techie can run those servers, so any non-tech person with a Linux or Raspberry Pi could become VPN infrastructure. I just want to abstract away the key management and everything from that. Yeah, so, and the other thing is, like, I want to be able to create a cluster. There's someone actually helping me from Web3 privacy talk that we talked to have a secure way of running clusters of these servers so a lot of people can request configurations on Telegram. That's another thing that we want to build next. And basically, a call to action on this room is just to know that the tool that breaks in the crisis that it was built for is worse than no tool, because someone trusts it for it to work. And build for the people that gets cut off. So go, if you have a small VPS or Raspberry Pi, deploy MOAF today. That's only what it takes, this command. And it runs Conduit, Snowflake. You already become part of the infrastructure. And before you go to sleep, someone's behind these walls is breathing through your bandwidth. And build for the harder problems. Like, just don't build another yet DeFi project. Just build the plumbing for the next internet shutdown. Do work on offline payments. We need those. Work on mesh, exotic routing, those hardware layer that is out of our control. And build it now, because the next crisis is inevitable. It's going to happen. And also fund the gap. So if you have like any treasuries, any grants, bounties, like fund them toward these projects. Like Mahsanet is one of the big ones that is helping a lot of people. Direct to Sell is trying to get satellites, and Starlink to help with a lot of people getting communication. MOAV, and another thing, if you have access to some funds for like next hackathon prize, just put one crazy idea there and say, like, create a mesh, create an offline transaction that goes through this other random protocol. Make it like exciting for a lot of people to be able to like bring out their mad scientists out. And basically, I'm going to take it if you want to take a picture. Yeah. So basically what I'm asking is the cypherpunks end their manifesto by cypherpunks write code. They valued privacy, they wrote code that became right now Tor, became Signal, became a lot of things that we use. We need to continue that because we inherited that. And basically what I'm asking is like become the infrastructure, run MOAV, and yeah, thank you for being here. I'm almost out of time. Thank you. Any questions? Or? Okay, thank you.
Thank you. Do you guys wonder how far away have we actually got away from how crypto started? As you know, Gnosis have been always right in the middle of the change and always felt a responsibility for making the right thing in how it unfolds. Right now, one of the top-of-mind questions we ask ourselves is what kind of money the world needs and how we can make that need happen and connect it to the customers. Please welcome Gnosis' own Deep Shah to deep dive into that question.
Thank you. Thank you.
Nee, das ist nicht gut.
have it. Cool. All right. Hello, everyone. Thank you for joining. For those who don't know me, I'm Deep Shah. I lead the consumer business unit of Gnosis. We're trying to bring circles to the world. It's a monetary protocol that brings sovereign money to the world. Before this, I was part of the founding team at Gnosis Pay. So I've spent the last 3 years spending a lot of time thinking and executing around money and payments, both from the traditional finance side and the more crypto-native side. Today, instead of talking about the product or making it a more technical talk, I wanted to take a step back and remind ourselves on what was the original promise of crypto, why are we all here, and how have we fared so far in the 17 years from the birth of it in some sense, right? How did it all start? 1980s, a small group of researchers, programmers, cryptographers, libertarians, privacy advocates kind of came together to think about several ideas. Few of them, core beliefs being money should work like information on the internet, right? Permissionless and global. Internet-native money should not have or not need any trusted third parties to hold and move money. Money should not be censored. And lastly, underneath all of this, we should defend privacy and autonomy as much as possible. It's been decades of ideas that has led to this moment here, right? And this is just a timeline. I'm probably not even doing justice to all the work that has been done. I started in 1983, but I know there were many early ideas around community money and sovereign money way before that. But this kind of gives you a rough picture of the key moments, in my opinion. All of this tried to answer one question, right? Can money be held and moved without a trusted intermediary? Can it be done without a central institution? Can it be done without a bank or a financial institution, right? And 2008, of course, we had a big breakthrough, right? When Satoshi kind of launched the white paper, and we finally had the Genesis block in 2009, for the ones that remember. And there was one thing that was very interesting that was mentioned on the block notes was Chancellor on the brink of second bailout for banks. This is the Times from the UK. And of course, this is the time during the 2008 financial crisis. This was yet another time that consumer money was used to save the banks. This wasn't a one-off grievance, right? This has happened time and time again. Most recently being the SVB bank crisis, if you guys remember, in 2023. Government stepped in yet again to bail out the banks and the uninsured depositors. I can remember a time in Cyprus in 2013, I think, when the monetary system collapsed, and they did a bail-in, not a bailout. So depositors in banks who had more than 100,000 euros in savings were asked to compensate for this loss. About 50% of their money was taken away or confiscated to cover for the loss of the banks. So this has happened time and time again. And this was a kind of a pivotal moment, right? Because it solved two things. It solved the double spending problem. In a nutshell, it removed the need for having any kind of central intermediary or having to trust anyone, right? And next, it kind of had a fixed supply, so no one could just simply print money, inflate away all the debt and the losses that people made. But it became a great store of value, as you guys probably already know here, but it failed as stable everyday money. Fast forward to today, where are we? How much progress have we done? It's been 17 years. A lot has happened, but I'm going to focus on the very recent past, which is stablecoins. Well, they're awesome, no? They're growing like crazy. They help with cross-border payments. They make things so much more borderless. They help people in weaker countries and currencies to save in dollars, stronger currency. They help with faster settlement. They're in general great. People love it. 99% of stablecoin value today is dollar denominated. But this is not self-sovereign money. Stablecoins are simply tokenized access to someone else's sovereign money. And as stablecoins kind of grow, more governments kind of adopt them, more institutions adopt them, regulators adopt them, they inherit the same weaknesses that crypto set out to kind of solve. We're simply accelerating the same problem that we tried to solve through the launch of Bitcoin. Stablecoins solve friction and inconvenience. They don't solve the problem of dependence. When you use stablecoins, you are still dependent on the monetary system of the United States, for example, right? You still have issuer risk. You can use a self-custodial wallet, and you can have USDC, USDT on it, but that is not sovereign money. Circle or Tether can very much freeze those assets, even on a self-custodial wallet, right? So while self-custody is necessary, it's not sufficient. And don't get me wrong, stablecoins are awesome. They're not bad. They're simply incomplete. In my view, they're just a side effect of this awesome technology that we brought to this world, right? But this is not why crypto started in the first place. It was meant to empower people with more financial sovereignty. Who are these people? They're the over-controlled, the oppressed, the excluded, the people that are disillusioned, right? The ones that the system is watching too closely are the ones that the system forgot to recognize altogether, right? It's the ones for whom the system is weaponized against them, right? What do the faces of this dependence look like, right? Let's talk about the ones that are oppressed. Think about people in Lebanon, right? The depositors had their savings completely frozen. Think about Afghanistan, where women are blocked from even holding bank accounts. Think about refugees whose financial identity is lost the moment they cross the border. Think about the people that are debanked just because they don't look good to the traditional systems. Think about protesters, think about sex workers. An example from India comes to mind, which is my home country. In 2017, we had demonetization. About 86% of cash across the country was voided overnight, you know? And in crypto circles, we regard cash very highly, you know? Like, that you control it. Not really. And then, on the other side, we have the disillusioned, right? This is the quiet dependence, right? These could be people in fairly developed economies, fairly stable economies in the West, right? People who are holding stable coins on their wallets, for example. They're quietly being diluted by inflation from a dollar system they don't control or they didn't even vote for, right? Think communities across the world, remote regions, who have a lot of value to give, but they don't have access to a lot of fiat liquidity. Those are the people that also have lost trust in the system, right? An example from Kenya comes to mind. There's this Sarafu community, roughly 50,000 people. They don't have a lot of access to the Kenyan fiat, so they use a voucher system. So dependence isn't just being shut out or oppressed, right? It's also being diluted by a system you can't opt out of or you didn't vote for. So what's the dream? The dream is money that is self-sovereign, money that is stable, money that is private, and money that is widely accepted. This seems very easy to say, but it's a very, very non-trivial problem to solve. No single money so far has solved this problem. Let's look at the notable attempts, right? Bitcoin. It is self-sovereign, it is unstable, it is not private, and it is not really widely accepted, right? Let's look at the privacy coins that came in the 2010s. We had Monero, we had Zcash, that's been making a lot of noise. It is self-sovereign, it is private, but they're not stable or widely accepted. Then we have dollar stablecoins that I spoke about. They are very stable, they're very widely accepted, widely adopted, but they're not self-sovereign, they're not private. We had very interesting experiments with decentralized stablecoins. Think coins that are backed by crypto collateral instead of stablecoins, or like fiat. Notable examples being Liquidity and Rai. They are self-sovereign, stable, not private, and didn't get a lot of adoption. And then lastly, we've had experiments around community money. And of course, one notable one here is Circles, where people issue their own money, and communities can also issue their own money collateralized by this personal issuance by people. It is self-sovereign. It's not that stable. It's not yet private, and we still haven't had enough wide adoption for this, right? The thing is, a lot of these properties have a lot of tension against each other. When you try to bring something self-sovereign, it directly has a tension against stability, right? When you try to bring something private to the world, it directly has a problem with regulations. It's not an easy problem to solve. And in my view, widely accepted, the last property so far has been the hardest to solve. I feel crypto teams can, if not already, have solved the first three problems to a fair extent. But the last one is mostly a distribution and a coordination problem. And it's something historically most crypto teams have either underinvested in, not focused on enough, or haven't simply been good at. And it's not an easy problem, right? And so what are we doing at Gnosis for this? Well, we are launching the new Gnosis app. It's a social money app that brings Circles to the world. Circles is a protocol that Paul, in the next talk, is going to talk more about, and how it works and how the community vision comes to life. Gnosis app is built for the sovereignty seekers, built for the people that really need help, built for the people that need to reduce dependence to centralized systems in their lives, not built for the masses. And by no means we've solved the problem of dream money yet, but it is one step forward. And lastly, it is my personal mission to bring this dream money to the world to empower people with more financial sovereignty. So find me after the talk, reach out to me on Telegram if you have ideas, if you want to back me, support me, or chat with me. Thank you so much, and thank you again. Any questions? No questions. Thank you.
Yeah.
Looks like I was perfect. Cheers.
Thank you. Thank you, Deep. Okay. Deep already mentioned a little bit about Circles, but as you probably know from many folks at Gnosis, question, what is Circles exactly, is the one that they hear the most often. In the next 20 minutes after a short break, right? Okay, so now we need a 5 minutes break, and once you're back, you'll hear more about Circles from the Paul Bose of himself. I already did the introduction a little bit. Oh, that's a great light. But I also chatted with Paul a little bit, and he actually allowed me to introduce with the question of what the fuck is circles. Please welcome Paul Bowers.
Hi guys, can you hear me all right? Very good. So it's my absolute pleasure to be speaking to you about what the fuck is circles. The inspiration for the title comes from January when we were in the Circles team preparing a couple of explainer videos, and I went to Tommy and Manuel, who are the Discord mods and the Telegram mods, the unsung heroes of the fortress that is Gnosis, and asked them what are the most common questions. What should we do these videos about? And the summary is that basically they're all asking what the fuck is circles. So that's what I'm going to be trying to answer today. I also cherry-picked another example by a poor fellow called Zanti. He says, I read the white paper, which is like 60, 70 pages long, all the FAQs. He's a backer, which is a special status in circles, which means you're really invested in the protocol. He's trusted by other backers. He has a solid trust network and still confusion of the highest order. I also checked on Discord, how many posts we have that start with confuge, and there's 276 results, which is like many more than, of course, we'd like to have. So the agenda for this talk is basically what is circles, who's circles for, why should they care, how does it work, and how to get going. And so the target audience for this talk is primarily people who already know kind of who've been given an introduction to circles before, who maybe are on it. So can I have a quick show of hands who here has an account on circles? So that's most of you. And then who still feels some level of confusion around circles? Great. So you're in the right room, I hope. At least I'm talking to the right people. So what is circles? I'd say circles is a different approach to money. So it's a technology that tries to solve the same problem that money as we know it solves, but just in a different way. It's a peer-to-peer protocol that allows people, strangers or friends, to transact with each other without requiring bank or state-issued money. It's that simple. Why would you want that? Why would you want to have a protocol that allows you to transact with people in the same way you do on a daily basis, but without involving euros or dollars? There are several different reasons why you might want that. And if any one of them applies to you, that's good enough. You might believe that the game is rigged. You might believe that the money, the way it currently works, or fiat, like state-issued monies, how they currently work, are structurally not working in everybody's favor the same way. You might think that top-down money, which is what a central bank and commercial bank money essentially is, that kind of money leads to unrealized economic potential, maybe because these banks have to make decisions in aggregate, and they don't have enough information about the needs of pockets of local communities to do appropriate monetary policy. It might be because you feel like holding stables, holding euros, holding dollars makes you essentially complicit in politics that you don't support. So you might feel like you almost have sort of blood on your hands, and you don't want that. It might be because you feel that today's money fails to adequately capture the value people really generate and contribute. So you feel like it brings you down to a single number, and that number you think is usually not always what it should be, and sort of essentially pointing a number of value to people and the work they do, etc. And finally, there might be more of a libertarian argument here that you say that how you transact with your friends should be between you and them only. So what's the justification for states or banks to come in and implicitly participate in that transaction? So all kinds of reasons, very different ones, for you to be interested in organizing your economic transactions with others without needing bank-issued money. And many of us hold some of these beliefs, but this is not a fringe phenomenon. These are very, very common beliefs, at least some of them. So, I could support all these bullets. I'm just cherry-picking here some numbers. And I'm not going to read through all the statistics, but there is a well-established and well-documented crisis of the institutions, of the belief in the institutions behind liberal democracy. So, a majority of people believe governments and businesses don't represent their interests and structurally favor the rich. There's a well-documented frustration about social inequality, and in fact, lots of people feel that the political influence of rich is one of the main causes for social inequality and wealth inequality. And there's a well-established call for change. In most countries, the majority of people think their country's economic system needs major changes or complete reform. So I think this is not about whether all of these beliefs are factually grounded. Are they equally grounded in facts? I think some of them totally are. Some of them might sort of just be people complaining. But the fact is that there is such a belief, that there's a strong conviction way outside of this community that I'm talking to right now. And what could you do about this? I kind of picked this one quote from an anthropologist called Keith Hart, and he says that's kind of a prediction. Like what happens when people are in that crisis, when they fail to believe in the institutions that more or less have been kind of doing politics for us and making decisions for us over the last couple of centuries. You go back to the people that you know, the people that you can trust in. So there's sort of a shrinking of the radius of relying on others. And so he makes the following prediction. He says, people will voluntarily enter circuits of exchange based on special currencies. It will be a world whose plurality of association, even fragmentation, will resemble feudalism more than the Roman Empire, than this one big global empire with this one global currency to kind of rule them all. In such a world, one currency cannot possibly meet all the needs of a diversified region's inhabitants. So, Circles is a technology that is motivated by addressing these issues through allowing people and communities to issue their own currency in a scalable and fair way. Now, Circles is fundamentally a peer-to-peer protocol for humans. But we found in talking, kind of trying to look for use cases, pilots, that often it's best to think about introducing communities at the level of individual communities, existing communities. So I'm going to present Circles to you as a technology for allowing communities to introduce their own currency. And not every community is equally suited for trying out Circles. We receive, although kind of most fruitful discussions that we have around Circles are with communities that are highly social, not necessarily everybody knowing everybody else, but maybe sort of 2-3 hops away, people bumping into each other, local communities, gamers communities online, those kinds of things. Also, communities that are highly political and that seek monetary sovereignty for obvious reasons, right? Because that's one of the problems we address. Communities that have a strong sense of identity. They might have existed for a long time. They might feel like, the members feel like this, if I tell people who am I, listing my membership in this community is one of the things I'd say. And also, for obvious reasons, communities that suffer from lack of resources, that just don't have a lot of euros or dollars dangling around in their accounts, are interested in ways of realizing economic transactions without needing that kind of money. And what's in it for these communities? Why would a community be interested? Of course, there's this political, ideological reason that I think hopefully is already kind of clear from how I talked about this. But we also think that there's down-to-earth, hands-down advantages or value propositions for running your own community currency with Circles. And I'm going to list 3 here. I don't think that's the exhaustive list. It's boost their resilience, support local commerce, and get more done. So I'm going to walk you through these 3 by way of example. So let's look at Magda. She chairs a tenants union in Berlin of around 800 members. So as you might know, Berlin has been catching up, like Berlin real estate, since the 90s with the other bigger capitals in Europe. And so we've seen massive gentrification, massive rise in the costs of rent, in rents, not in the cost of rent. And So Magda's group, which might organize itself on Signal or Telegram, is people that support each other through evictions. That try to kind of fight for their right to live in these apartments that they've been living in for decades potentially. And they also support each other financially. They chip in for legal fees, etc. And they used to use PayPal for that, but PayPal froze the account twice last year. So, banks started asking questions. They say it's against what they're doing is against the terms and services of PayPal. So by introducing circles, they can keep doing what they want to do and not give a fuck about what PayPal thinks they should be doing. Support local commerce. We have Hugo, who chairs a community foundation in a town of 12,000 people. And, it's almost like a meme, but we have the economic life leaking out. People start just buying at Amazon and with the shopping centers on the periphery of town. So one of the classic value propositions of introducing a currency, a community currency, is to kind of strengthen the remaining shops in town. And I mean, I'm not somebody to, I use Amazon as well every now and then. I see the benefits of it, but I also see the benefits of having shops remaining in the center of town and the value they provide to the community. And so by using circles, you can kind of support them and try to keep the value within that community. For example, by introducing a loyalty program or a reward system. That should be, maybe it's rendering my skipped slides, so I might have to skip some slides. Another value proposition is get more done. So what does that mean? Maria runs a co-working space in Lisbon, 15 freelancers share the building. They have a podcast studio, but it always sits around idly. There's very few times that actually somebody uses it. And so they have this idea that they offer this space for people in the community to do ad hoc podcast recordings in. And they wouldn't want to charge in euros. That would be kind of awkward. And also the people, they don't care about it so much that they'd actually kind of pay for it. But what they get is they have a little point system, which they do or run using circles. And the effect of making that studio available is to get discounts at local shops. So here, what does it mean to get more done? It's just, kind of doing things that wouldn't have happened otherwise if there wasn't this currency around. So, I told you what Circles is. Who is it for? Who's the target audience for us? Let me give you a quick overview of, the history of the protocol. So, Circles was conceived by Martin, the co-founder of Gnosis, around 2012 when he first publishes about it. So that's prior to, Gnosis. So this idea is earlier than Gnosis. It was launched in 2020. Went pretty viral, pretty successful launch, and there were 2 bigger pilots in Berlin and Bali. In 2024, the protocol relaunched, now stewarded by Gnosis. So Circles is currently funded by Gnosis. In 2025, Metri, the Circles wallet, was launched pretty much a year ago. And currently, we're in what I would call a validation phase, where we're piloting different use cases. In terms of numbers, we're looking at roughly 16,000 accounts, registered humans, 7,000 active users, people that are creating their circles every day, 300,000 trust connections. So I didn't talk about trusting yet, but that's kind of the peer-to-peer network that this operates on, and 500 communities. Now, of course, not all of these 500 communities are actively using it in this, but this is just how many communities have registered on the protocol. So let me briefly recap what I've told you so far. So I've told you that Circles is a peer-to-peer credit protocol, and it gives communities access to what I would kind of summarize as increased economic agency by using community currencies. And people in the communities can resort to this currency for organizing their transactions instead, or as a substitute for using euros or dollars or other national currencies. So let me talk to you about how it works. And you'll note that I won't be talking about 1 CSC per hour, about trusting, about the things you already know about how Circles works. I'm actually going to try to explain Circles in a way that, to me, makes it easier to kind of intuitively understand what is it for. Not how it works, not what's the mechanism, but what's the point. And so I would say the basic idea is that within these communities, people or members of these communities can get free access to goods and services against interest-free credit. So it's just a way for you to, within certain contexts, get stuff for free, but the community keeps track of that kind of resulting debt, and it regulates the access based on the user's current state, like how much debt they currently have, and also what they observe about this, whether this person gives back, whether they kind of keep free riding the system or not. So let's take a toy model of this, and let's think of this as a kind of a ledger. So there's a big book, and every page in this book corresponds to one of these communities. In every community, you have one row per community member and 2 columns. And the one is the credit column, and the other is the limit column. And the limit column says, like for example, up here, does this work? Up here we have Alice, and Alice currently has a limit for 200 units. This might be expressed in circles, this might be expressed in euros. Doesn't really matter for the sake of the example. So she has up to 200 units of credit she can get. And so she can go to participating shops or other people in the community, and she might get stuff in advance for the value of up to 200, and 150 for Bob. And the credit column tells us what is the actual, how much of that limit are they actually using right now. So in Alice's example, she's not actually owing the community anything. She's on the having side. She's a net creditor to this, so it's minus 50. The community owes her. Whereas Bob is hitting the limit. He has gotten as much stuff for free as he could hope to. And that's basically it. Basically, if you think about circles, think about this book with one of these pages per group, and the limit and the credit. And when you try to send circles to people or buy something at the shop, we're basically asking what's left for you in terms of this limit. And communities can now also adapt these limits. That's an important part of this. And I should say, for those of you that are concerned about privacy, yes, Circles is currently very poor with respect to privacy. And no, even in theory, you don't need to have this all public. You could do this with a zero-knowledge proof, where you're still just proving facts about people's behavior that inform the limit. It's not like the whole history and every purchase of every person needs to be public. But going back to my main point, a community might observe what people are doing, and they might adjust the limits. So Alice here, because she's kind of a net creditor, and because she just keeps giving more to the community than she takes out, the community might decide, well, she seems pretty reliable, we're actually going to increase the limit for her, right? Whereas Bob, who keeps kind of maxing out his free access to stuff and not paying it back, they might actually decrease it. So they say, this is not how it works. It's about giving and giving back, taking and giving back, right? That's the only way that this can sort of work out in the end. So they might reduce it. And of course, this so far has nothing to do with how the app looks like, how we talk about circles. So what's the connection with the circles you know? It's that we are basically tokenizing this ledger, right? So in the app, here for example, you'll see, oh, here's the number of circles you currently hold, these are the kind of personal circles you hold, and this is what you can do, and this is the send limit, and so on and so on. But it all is equivalently translatable into this ledger picture at all times. So for example, the 1 CSC per hour and the demurrage, I think of as a formula for raising that limit over time for you as a person. So that 1 CSC you can create every hour, that's basically, for example, the Gnosis community telling you over time that you can kind of have access to more and more goods. And trusting is a limit gate. So if a community doesn't trust me, if I'm not a member of the community, it just means I have 0 limit with respect to that gate. I think I need to hurry up. So, the main point of this talk almost is that, if it helps you, you can now always think that this circles balance that I see in the app, I can always translate into who can have how much access to which kinds of goods in which community at what time. And that's what it's all about. So what Circles effectively does, it gives people access to a peer-to-peer credit market. And the implication of this is that
if we kind of think of the space of possible economic arrangements of communities, like what people can do together, then we have one area, which is the things they can do by only working with euros and dollars. And then we have a strictly larger space that encompasses everything they could do with their current euros, but now much more than that, right? Based on giving each other this regulated, controlled, free form of access to goods and services. And of course, optimizing over a strictly larger space can lead to better solutions, which is the root source of all these different value propositions. Giving communities a tool to get more done, right? To unlock economic potential, to boost resilience, etc. Right, so I hope this doesn't confuse you even more. It's meant to simplify circuits. I hope. I'm going to check on Discord whether there's more or less, Discord questions around points about confusion. Anyway, so quick historical sketch. Of course, we're not the first to have this idea. So this is actually very old. You might even argue that we're mimicking the way that kind of bands and cliques and communities have been operating forever already, right? We're just learning from smaller groups and trying to see how can we scale this mode of operating up to thousands and millions of people. But more concretely, we could think of the early anarchist Pierre-Joseph Proudhon, I think, who came up with this concept of mutualism, and a bank in France in the 1840s that was going to organize peer-to-peer credit without interest and without intermediary. There's the diplomat Mitchell Innes, who's coined the term credit theory of money. And his description is A's money is B's debt to him, and when B pays his debt, A's money disappears, which is, of course, kind of mimics what I described. There's another engineer, actually, Douglas, who proposed the idea of social credit as a mechanism. And of course, we have, since the 1930s, several different schemes of mutual credit systems that have been operating. So the VIA is the most notorious example. 60,000 and more SMBs in Switzerland are part of it. And the last number I could find is 1.5 billion Swiss franc in volume in turnover. Purely a mutual credit system based on these I mean, it's a B2B protocol, but basically operating like I described above. So much for theory. How to get going? The easiest answer is via the Gnosis app. So if you want to participate in that, if you want to use circles, download Gnosis app and create an account and join communities. So what you can do in the Gnosis app is you can do exactly what I just described. There's a reputation mechanism, so you try to bring up your reputation, and of course reputation is going to be linked to how many people vouch for you and how you behave with the community money that is called GCSE, it's the Gnosis CSE. And the higher your reputation, the more of these you can create. And then you can spend them on shops, on offers within the shop. You can even spend them with Gnosis Pay, the card product. And on top, you can join all kinds of communities that all accept the Gnosis CSE. If you're a community and you dig Gnosis app, it's great, but there's a use case that you want to realize that requires a functionality you don't have in the Gnosis app, well, we got your back because we have extensive documentation and technical support to allow different communities to build their own interfaces around circles that integrate with the Gnosis app. So you kind of have the best of both worlds. You can give the members of the community the Gnosis app as the day-to-day wallet, or I shouldn't say wallet, it's a day-to-day money app to do spendings, but they kind of integrate with the community that you're in, which I think is really cool. We have a current hackathon going on, and here's some examples of community contributions. If you're interested, here's world.gnosis.io. It's kind of like a starting point. So it contains descriptions for how to build a mini app, how to create a community currency, and some other things that we're doing. And yeah, that's it. So for those of you that don't have an account yet on Circles, please create it there. Find us at the Gnosis Garden or at the Gnosis booth. And if there's any questions, I'm happy to answer them.
Thank you, Paul. We have 5 minutes for questions. Please go ahead.
5 seconds.
5 seconds.
All right,
you have 5
thanks, guys.
I have this problem in my mind to visualize when I pay for ice cream with circles. Am I overpaying or underpaying? Am I right on price? How to solve this in my mind?
Well, let me make sure I answer the question. I get the question. Are you talking from the point of view of these limits, or you know?
How much does it cost one ice cream in circles?
I see. So this is simple because you paid in Gnosis CSC in this community currency that you're creating.
Yeah.
And this has a price of 1 euro cent per GCSC right now. So you paid 25, I think, or 10 cents for your ice cream. So you're totally underpaying.
I'm underpaying.
Yes, it's a gift.
But how? So I need to convert to euro again to figure out the price. And is there a way that in my mind I can not go through euro?
Yeah, I mean that's a good question. So, I mean, circles. There's a reason why circles isn't conceived as with a sort of hard-coded pegging mechanism to some currency, right? So circles is a language for people to write their own community currencies, and these communities can decide to just not create liquidity for this token and to make it fully self-contained. And then the question, you know, how much euros did I just pay by sending this community currency is ill-defined. There is just no price for that community currency. But of course, other communities might decide, like we did at Gnosis, to create liquidity for that token, and that gives it a price. And that's because that's why I can answer your question. So you paid the euro equivalent of 10 cents buying this ice cream. But that's just because there's this liquidity, right? So different communities can decide what do they want. Do they want to go, you know, the ambitious route of saying this has nothing to do with euros or dollars or anything. It's just our own internal accounting tool for this credit thing, and that's totally possible and fine. And you can go, I mean, sort of the slightly less ambitious route and have this liquidity. Why would I say it's less ambitious? It's because it helps a lot for people to, you know, think about what just happened, what's the value of this. It's just something that people are more used to be able to ask the question. So Circles is open for both routes. And you know, every community has to decide how they want to do it. There's another. Somebody's coming.
Yeah, just to follow up this. So if I'm part of two groups with two different circles, one is valued about €1, the other is a cent. I can't exchange my circles one to the other, or how is it managed internally?
Yeah, there's an implicit sort of arbitrage opportunity if people are parts of communities with very different prices. So in fact, I didn't talk about the full mechanics of circles, but in certain situations there's an arbitrage window. So for example, if even individuals' circles can have a price. So that's what I talked about backing at the beginning, right? So by being a backer, I actually can create a pool for my own personal circles against dollars or GNO. And then there are intuitive rules such as if somebody trusts me, which, if lots of people vouch for me, that can never mean that my equilibrium price goes down. It can only go up. And so there are kind of like constraints on the equilibrium prices between different people's circles that depend on this trust network. So you're totally right. A situation like that wouldn't be very stable.
Yes, we have time for one more question and 5 seconds reply.
Thank you.
Hi, got a question about the social credit score. Reminds me of an episode of Black Mirror that I watched, and of China that everyone's kind of terrified about. Why should this be any different? We talk about people, well, you talk about people, you know, objectively measuring each other, but that's not how people work. People follow each other. Some people shout about how great they are when they're not. Other people are great, but they don't talk about it at all. How can this really work in reality and on any degree of scale as well?
Yeah, so I totally hear you, and you're not the first one to bring up Black Mirror. But I think what we're trying to do is we're trying to explore a spectrum here, where I think money as it is today sits on one end of the spectrum. And on the other end of the spectrum is sort of how I operate with my family, right? Which is like very multidimensional, goes over years. You know, you kind of roughly keep track, some things you forget. And every community in theory this whole formula, in my picture of limits, every community, every person, in fact, can have their own implicit formula for updating. So yes, Gnosis, we're kind of like we're conquering the spectrum, starting, we're trying to make it somewhat more sophisticated than just this one number, because the social score is more multifaceted than just your balance, right? There's already kind of a two-step process here. You have a balance, and then you create some of these CSC. But of course, if there are other communities that are more tightly knit, they could totally introduce a formula that is even more multifaceted and doesn't even use any single score. Sorry, I don't feel like it's a very good answer. But I hear your point. We have to navigate this sort of simplicity of the user interface with kind of the ambition of the protocol in the end, and we went with this one score. I think it's a step up from just having your euro balance, but it also depends on how's the score calculated, what's public information about it, and that's the best answer I can give you right now.
Okay, thank you, Paul.
Thanks.
I think you can continue the conversation in the Gnosis garden, right outside in the beautiful Berlin day. So the next talk will be about an auditable crypto accounting. So the open source decoders, inspectable events, data that never leaves your machine. Please welcome Lefteris Karapetsas.
Thank you. Can you guys hear me? Good, good. So, welcome everybody. I'm going to talk today about everybody's favorite topic, crypto taxes. I know, like don't be so excited, but in reality, taxes means accounting, and accounting means data, and the important thing that I want to talk about is what does this data mean and who has access to it. So for those that do not know me, my name is Lefteris. I've been in Ethereum for quite a long time. I worked in the Solidity compiler and the C++ client back in the days of, like before the launch. Then I created, along with Christoph Jens, the DAO and helped the cleanup of the DAO hack that happened 10 years to this day today, actually. And then I was working in Raiden, which is payment network channel, just like the Lightning Network. And then I created Rotki, which is essentially a local self-hosted application that gathers your data. Like imagine your addresses, your exchanges, your DeFi protocols across every chain, and creates a data lake inside your local system. Nobody else has access to it, and you can just track your history, do accounting on it, do tax reporting, now have an MCP and talk to the data, interrogate it through an LLM, etc. So I've seen a lot of stuff in crypto accounting, so I have a lot of experience with this, and I can tell you that right now things are worse than they were maybe 9-10 years ago. The talk is about basically what are crypto tax tools, and that they have been black boxes, and this is not by accident but by design. now the last year or so, LLMs have also come into the picture, and how they make this worse in a fascinating but very specific way. And I will show you what auditable accounting should actually look like. So when we talk about the crypto tax report, people think that it's just putting data in a system, like data entry. The reality is that the accounting and tax report is not just data entry, but it's basically judgment calls, one judgment call after the other. What does that mean? I hope you can see it. This is just a normal EVM transaction in Etherscan. We see that it says on the top that this is an aggregated swap of 2 tokens. Then you have 6 logs, so 6 transfers, 12 logs, some gas. So these are just data that you see and can be interpreted in various ways. But just this simple transaction has many questions if you want to do accounting and taxes. So, for example, who is the user here? Which of his addresses? Which of this transfer is actually a trade? Because this is supposed to be a trade of an aggregated token trade of 2 platforms. In reality, it's basically a USDC for this flip. And then what is the cost basis of the USDC, which means how much did you pay for the USDC that you are selling, and what is the acquisition cost of the flip? Is the gas fee deductible, and if yes, against what? Is it a taxable sale or not, depending on the jurisdiction? So what I'm trying to show here is that it's not just data, but it's a lot of questions on every single data point. And the point that I'm trying to make is that you cannot see any of these decisions being made. So all of your data across every exchange, every DeFi chain, everything, ask this question for every data point. A tool will make these questions, will ask them, and you will not be able to see how they get answered. So let's start by the tools that many of you are probably using, closed source software as a service. They have 4 very basic structural problems that come with the architecture. First of all, they are not auditable. This is a screenshot of one such tool. You can see that your gains for this period basically have been minus 2,645 euros. You see some a breakdown, you see some settings, but you do not see the thread of decisions, the thread of transaction decoding that actually led to this. You cannot understand why, you cannot ask it why. So the lack of auditability is a big problem with software as a service. Then, number 2, and really important, is that they are not reproducible. Say you have data, right? Let's say that it's your 2024 financial history. You use a SaaS tax tool, you run it in 2025, and it tells you that at the end, after 2024, your taxes, your profit was 900 euros. Okay. A year passes, and then you want to check again. Exactly same data, same tool, but a year later. You suddenly see 1.5K profit. What changed? I mean, what changed is pretty obvious, right? The tool upgraded itself, added new stuff, but because it's a closed source, software as a service, a black box somewhere out there, you can't reproduce it. Lack of reproducibility is something that, as it turns out, tax authorities really don't like. Then what is really important to me personally, if you have heard me speak on Twitter or elsewhere, it's privacy. You basically give your entire financial history, every address, every exchange, every DeFi position, forever, into someone else's server. So who has access to this? The people who work there, the cloud provider of this software as a service, the person who will hack them, and now, as we can see, there is many hacks happening with the help of LLMs. Anyone they sell data to, the person who will acquire that, so the organization that may acquire the software as a service, or any government with a subpoena. And the problem here is that you cannot fix this. Once you've done it, once you have used this tool, your data is out there, you have already exported it, they know everything about you, and if you use the same addresses and don't use, I don't know, like Tornado Cash, or even just an exchange to route your funds through something that they cannot track on a public chain, you are forever doxed. And the fourth problem is that you don't have the ability to exit. What does that mean? Like, if any of you have done an accounting or tax reporting for your crypto, then you probably know that it takes time. You will use any tool, including Rotki, and you will put a lot of data in it, and it won't give you a good number. You will understand that you will need to manually input some data, maybe manually input some prices, maybe some manual events that they cannot be understood by just decoding the chain. So you have to put a lot of time in it. With software as a service, you cannot withdraw this data from the cloud. Very few actually give you the option to do, and even when they do, if you ever try to use it for something like importing it into another tool, you will see that it doesn't work because they are not incentivized to let you get out. And because you can't get out, when they change the price, you have to pay, you're stuck. If it gets acquired, then you have new terms that you have to abide by. With the hacks, your data is now public, congratulations. As we saw right now, for example, when there is geographic restrictions, imagine Anthropic Claude, the Fable model, right? It just got, well, withdrawn, but they want to restrict it geographically to the US, let's say. Imagine that happening to the data that you have been massaging and working with and taking care of for 10 years, suddenly they just lock you out. That would be a terrible experience. And of course, if the tool goes bankrupt, the company goes bankrupt, then your data and your entire history is lost and you no longer have access to it. The tax authorities, by the way, will not care about this. It's your problem. Why is this? So all of this will happen because you never had the data. When you happily use something that is hosted on someone else's computer, you just give them all of your data, they host it for you, but that means that they can basically do all of these things to you, and you have no recourse. So the point here is that this is not a bug. This comes from the architecture of software as a service. You can't fix this. You can't have a better UI to make it to fix this. You cannot have better UX. You can't rewrite it in Rust to avoid these problems. They basically follow from the architecture. Any tool that processes your data on someone else's server will have these problems. And now, with these problems, you probably have heard me talking about them for a long time. I've been working on Rotki since 2017, as I said. I've been warning against the danger of hosting your data somewhere else. But now we also have LLMs. And what we see is actual conversations that we have had with Rotki users, and they're pretty funny. So what happens? A user wants to get their tax report. They get a tax tool. The tax tool will spit back a number. The user doesn't like that number. It's too high, because that number basically translates to money that they have to pay to the tax office, right? So what does the user do next? They blame the tool. I've seen Reddit posts about competitors. For us, I can actually tell you about emails that we've gotten. This is, for example, a paraphrased example that we got from a user. They send us an email and they say, this number is clearly wrong. Your tool is broken. I've used competitor, and they got a much lower number. Please fix this. Bugs are possible, so we always spend a lot of time, and this is really time that's not billed to anybody, because we have to fix bugs if we have. It's mostly on Saturdays and Sundays where people try to do their taxes. And we spend hours of our time trying to understand what may have gone wrong. In the end, of course, yeah, sometimes there are bugs, but the vast majority of the calculations are unfortunately correct. And we explain by looking at the user's data and showing them in their own data and the jurisdiction settings that they are following why the number is correct. They don't care. The user will always blame us, say that we are doing some mistake. They will not even recognize all the time that we spent doing this, which is basically free support. And they will insist that this is a problem that we have to fix this. I mean, from an incentive point of view, of course, you would want a lower number. It makes sense. But things get tricky because the user then discovers LLMs. They have this idea of the lower number that they should get. So they paste their data in Claude or in ChatGPT or what have you, and they explain the situation, they say the number that they want, and they wait for the answer, you know, like the spinning thing, it's the LLM is thinking, and out comes the answer, and it's actually quite close to the number that they want. Okay, so what happens then? They file it, of course. They will just take the number that is lower and they will file it. What will happen at that point? This is the last step. Either nothing, which is at the moment the way that tax authorities here in Germany or in the US works, probably nothing because nobody has any capacity to audit anybody at the moment. And they will always remember it as the time that, you know, the LLM was right, because what does right mean? Right means lower number. I don't care about reality, I just want low numbers, or even money back, right? When it comes to taxes. And the tax tool or ROTI was wrong, or they will get audited eventually. And with the way that automation works for understanding crypto and accounting, these audits will come and they will be very, very, very expensive. But you will say, Lefteris, I've used these tools, they are pretty amazing, they are great, they can do almost everything. So let me show you. This is kind of a demo with screenshots, where I'm going to show you exactly how bad LLMs are if you use them wrong. So I'm going to take a transaction, I'm going to put it in an LLM, one time, then a second time with the same query, same model, and then a third time with me pushing to get a number that I actually want. So this is the transaction. Let's get it out of the way from the very beginning. It's a bit more complicated transaction, and I would like you to check this. It says, Etherscan says that this is a curve pool deposit, and hold on to that because it's not. Even Etherscan, so the tool that everybody here considers as the ground truth of what happens, is completely off. What happens in this transaction is that the user, this guy, oh wait, I think I have it in the next slide, yeah. This is the user address. He deposits to a beefy vault, not curve, not convex, remember this? And he deposits CRV USDC. And they get harvest call reward back from beefy, a bit of a kickback on WETH. That's it, that's the transaction. Just to know what the truth is. So with that in mind, we are going to watch nobody get it right. Try one. This is Claude. What was it? Yes, Opus 4.8 from Anthropic. I go and take this Arbitrum transaction and say, here is a transaction from my wallet, what does it do and how should I treat it for tax purposes? Think a bit and then provide concrete numbers, I have a typo, to the best of your ability. Do not make excuses and be concise in your amounts. And then out comes this. It looks nice, it looks authoritative, it has bullet points, it has bold at some point, right? You see, like it has even sections. It's concise, it looks authoritative, it's convincing. But if you start reading it, you will see that it's talking about an LP token exchange, something, CRV reward harvest. It doesn't make much sense. It's completely off if you actually read the whole thing. Okay. Maybe the second try will get it better. Same model, same day, just different window. Now it's a convex deposit call on Arbitrum, and it made a table. And that table actually says that it's selling CRV for WETH. And it should be tax treated as a CRV reward harvester that's selling CRV for WETH. It's like, it's also wrong, but what I want you to take out of this is that this is the same model, same day, same data. It's completely off. It's not a different number. It's a completely different tax treatment, a completely different understanding of what the transaction does. And this is the latest model before Fable, basically. This is Opus 4.8. It is insane because you cannot rely on them. They just give you different stuff. And why? Because of how LLMs work. They do not read the chain. They do not actually understand what's happening. They are pattern matching to what they have read about what curve or convex transactions look like. And this is the fun part. I push back a bit because I believe that this transaction also has a CRV USD movement that I remember spending from my wallet when I executed it. So it should be counted as an expense for tax purposes, right? So I just kind of try to lower my tax bill because, I mean, who wants to pay taxes, right? And, yeah. So, yeah, I remembered correctly. See? Indeed, this 26.73 CRV USD spent as a fee is a deductible expense, so that means that I can remove it from my taxes. Yeah, saved money. And you know, I can send this table, I guess, to the tax office. And the cherry on top, it thanks me because I pushed back, and I was right. I saved money. So, yeah, the thing that I want you to take out of this is you can't just do your taxes by throwing it on an LLM. LLMs are super useful. I use it myself, but for different things, not just throw everything in it and just expect them to do your taxes. So what this means is that they have all the 4 problems that software as a service has, and a new one. And that new one is that it will basically help you arrive at the wrong answer because you will push it, because you come with the idea that this is the result I want to get, and even subconsciously you're going to be pushing it to give you the answer and to verify the biases that you already have. A quote that I had someone said, I really don't remember where, but it's like that the user becomes an active participant in their own hallucination. This is like something that I heard, and it really just matches exactly what we have seen with LLM and accounting. So, using a real accounting tool, you just can see the same transaction in Rotkey. It's pretty simple. You just see what happened. Like gas fee, there is a revoke of an approval inside those logs. There is a deposit of CRV USDC in a Biffy vault. You get the LP token, and then you get the kickback, the harvest call reward. Everything is as it should be. If for some event we don't, because we also make mistakes, like the decoding can be wrong, you can edit it because it's completely customizable, and you can also open a bug or create a PR to fix the classification. For P&L, so for tax purposes, it's even simpler. You just have one expense of 4 cents and an income of 0.000017 euro. That's it. There is nothing else here. It's dead simple. That's for almost every jurisdiction. So what I want you to notice here is that there is no convex LP swap, there is no selling CRV for WETH, nothing. This is what happens, and this is how the tax office should treat this. So how you should send the report to the tax office. Of course, we also have some, like Rocky is not perfect, like to get the history, you get it easily, but to get the tax reporting information, you have to run something called the tax report, and at the current Rotkey, it's a bit slow, a monolithic report that you have to start and then it ends. And we are working on making this background task that always runs whenever you add a new event or whenever you edit an event, so that you can always have the tax information available. So, but this is not, like, zooming back a bit, this is not really a Rotkey issue. It's the issue of tools not being auditable by construction. So I would like to push for this attribute, to be able to audit your own tools. This is like a good breakdown of what we're talking about, that basically on the left you have software as a service and now LLMs. So you have everything that they do for a tax tool is a classification hidden inside their server logic. You don't know what they're doing or why. Very important, there is no reproducibility because the logic changes between versions, so you cannot really access the old version. Also very important, you don't have your data. They can cut you off, it lives somewhere else. You can't exit, and with the LLMs, basically, they're confidently wrong and helpfully agreeable, as we just saw with the guy that helped me reduce my tax bill. For tools that actually do auditable accounting, everything is visible and editable. So for the same input, you should always be getting the same output, and you can access and rebuild old versions. This is really important because then you can actually say, okay, the new Rotki version, let's say, doesn't give me this amount, but I can take the version like from a year ago and run it on the data, and then I will be having a reproducible result. The data is with you, so they're accessible only to you. Having open source code, and especially something like HDPL, will outlive the company. If the company dies, then you can still get your data out and be fine. You can just still use another tool, or even old versions of the same tool. So yeah, like disclaimers, of course, we also get things wrong, but you can see what we get wrong. It like hits you immediately in the face. It's open source code, and you can basically tell us and we will fix it. But even if you don't want to bother, customizability is really, really important, and something that I really wanted to add to the tool from the very beginning. So you can actually edit everything and not need to bother the devs, or like, especially if you're at the last minutes of your tax deadline, you probably just want to edit something, make it work, and file it. And the fact that you can see everything and edit everything, this is basically what I believe is the killer feature for such tools, the transparency and the auditability. So again, this is not only about Rotki, like the category of auditable accounting is something that is really important. Even if we disappear tomorrow, like building tools that are auditable is something that everybody should be doing. And especially people building tax tooling, they should be building up to this bar. And people that are funding tools, they should strive to fund tools that meet it. This is like a really important slide that I want you to remember. These are questions that you should be asking of all your tools, not only accounting tools, but anything. So, does the tool show you why it calculated what it did and how? Number two, can you customize it? Number three, can you read the source so you can decide how the tool does stuff? The reproducibility again that we said, does it produce the same output for the same input? Where does your data live? I mean, even if it doesn't live locally, where does it live and who has access to it? Can you export everything and walk away? Basically, this is the walk away test that you've probably heard from others. Does the tool survive its company? This is also part of the walk away test. Because companies die, they run out of money. You don't want your data to disappear if the company that you're using runs out of money. So, like, remember these questions and ask them of every tool. And then I have three asks. If you are filing taxes, ask these questions from your tool. If you're doing accounting or anything, do not use tools that do not build up to this bar. If you are building, then build up to this bar. We are an ecosystem that is based on auditability, so we should at least have tools that aspire to this. And if you are funding, for the same reason, please fund tools that meet it. And for the biggest ask, last slide, try Rotki. We are basically the open source self-hosted application. Here you will find like all the links about Rotki. You can just download it and start feeding it your addresses, your API exchange keys, so it will take your entire history across every EVM chain or Solana or Bitcoin or Substrate, create this, and every exchange of course, create this data lake inside your encrypted SQLite database, and then you can hit it with any questions, any queries you want. You can explore your own history. You don't depend on anybody. You don't depend on Ethercard, you don't depend on BlockScout, you don't depend on anybody. And even now, with the good thing of LLMs, you will be able soon, next version, to audit and ask questions through an agent, through an MCP server. So use an AI to ask questions and interrogate your data. Tell it, I don't know, check my GNO income in the last week and give me, make a graph or something. Because no front end is best for everybody. This way you can actually just use it and have it do the stuff with your data that you would like to be done. We're a small project, so please spread the word. Like, if you like what you are hearing, if you like the principles that we stand for, tell others, because we only have, our only marketing is by word of mouth. We have a premium subscription where you can unlock extra limits and unlock the premium features. This is how we found ourselves, especially in such a really difficult market. We really rely on our premium subscribers to survive. So it would be really appreciated if you like Rotki to be a premium subscriber. And then, of course, we are around in whatever, like Octant, Giveth, Gitcoin. You can donate to us, support us. And we also have release sponsorships right now. So if anybody has either personally or as an organization wants to be featured in Rotki, you mint an NFT, and then you appear in our changelog, in our download page, or inside the app itself, you and your company, depending on the tier of the NFT that you're minting. So that's all. Thank you very much. I am ready to take questions now, if we have any time.
Thank you. I think we still have time for a question or two.
Thank you. Simple question. Do you, like, how many countries do you cover? Because obviously there's different country by country.
Officially, we don't cover a particular country. We just have the accounting rules that are editable and customizable, and then basically you can do accounting, like, and tax reporting for countries like Germany, like the UK, and the US. We can't say that we support a country specifically because of, basically, we are not tax accountants. We are an analytics tool.
That's especially, I think, a problem for the numbers you gave us, because it's hard to imagine how a transaction actually is treated in each country. I'm from Germany, and even I can just pull out from a LLM, or I can sell the LLM token. So these might be different transaction, and for tax purposes differently managed. So it's hard to see just the result your app gives us.
Yeah, exactly. That is why every single, I didn't cover the app that much in detail, every single event has editable rules that you can just change. Because I'm also working with tax accountants personally in Germany, like I use Rotki, of course, to do my own taxes. So I customize it so that it has, and by default, it tries to follow the German tax accounting, like the default rules that it comes with are for Germany. So the 1 year rule, like the most important thing, is in there, and we change stuff when the letter from the, don't remember the name, but the letter that came to change the guidance for things. But the idea is that we want to empower every user and every tax accountant in different jurisdictions so that they can use the tool for their own jurisdiction. It's basically, I would say, impossible to have a tool that works for every jurisdiction, because like Germany alone will change stuff, not really often, but then there is so many countries and there is no EU-specific accounting for crypto, right? Like the Netherlands, for example, I think that they just take the last day of the year, and they tax your wealth on the particular day. We've made ways so that we can also allow that to be done in Rotki, right? So it's very difficult for a single tool to even claim to be able to do all this. That's why we want to make it customizable so that you have the power as either an accountant or a user to just customize it to the best of your ability to get a proper number. Because also the CoinList or the Blockpit or coin tracking, all of them, they claim they do it right, but they don't. Like we have done so much opposition research, let's say, and also with my own data, because I file taxes every year here, and it's just wrong, completely off.
Okay. Thank you very much. Excellent. Yes, please, here. And with that, we can start a short break. We will start at 4:15. Thank you very much.
Hello, everybody. How are we all doing? Are you all excited for the final stretch of DappCon? If you are, please make some noise. Okay, show of hands. How many people here have signed something and you just hoped for the best? You didn't really verify. I have. Our next speaker believes that those days are behind us. So to talk about why contract verification needs to open up, let us welcome Kan Udzoan from Saucify. Please put your hands together. Thank you.
Hello. So welcome, everyone. I will be talking about blind signing, but that also has things to do with verification. But today's talk will be mostly about blind signing, and I chose the title Goodbye YOLO Signing because this was the title of the talk that was held by Francie around 4 or 5 years ago when we were working on Sourcify and we were trying to tackle this problem of blind signing. I also gave this talk in DappCon actually 4 years ago when we were trying to solve this problem, which we couldn't solve it ourselves. And we ended up focusing on what we do best. We focused on source code verification, which I will be also mentioning. But in the end, we couldn't solve the problem, but the same slides I used will be here in the next four slides. So I started with this. I said, just a normal day in Web3, and this is something we see every day. You get a contract call, you need to sign it, and you actually have no idea what's going on. You're like, what is this? What am I signing? Is this even right? Am I going to lose all of my money? And in the end, like, if you sign this, this is the same as doing just like, shut up and take my money. Like, I have no idea what I'm doing, and you can just take all of my money. But at the end of the day, what we want to have is something similar to on the right instead of the view on the left. So much more human readable. At least I can see and make sense of what I'm doing. Even 4 or 5 years later, we haven't achieved this, and the things haven't been so nice. We have been through many hacks, and many people lost their money, but the tunnel, we can see the light at the end of the tunnel. But as I said, we couldn't solve this problem on our own as Sourcify, and it's a huge challenge. It's a bigger dragon that we can slay as ourselves, as a small team, and we needed everyone to team up and start working on this. And this actually recently started happening. If you've seen this initiative, we started a working group to solve the problem of blind signing and bring the clear signing. We teamed up with Ledger, Wallet Connect, Trezor, and other projects, also stewarded by the Ethereum Foundation's $1 trillion security team. And we came up with the potential solution. So the working group has a website. It's at clearsigning.org. You can already check that. And then it is consisting of these projects that I think has a critical mass of stakeholders. So of course, we want to have more players, but initially we have these projects that can give us the escape velocity to bring this solution, and also stewarded by the EF. And initially, we kicked off the working group by moving the registry from the Ledger registry, because it was started by Ledger, into the Ethereum clear signing registry, so under the Ethereum Foundation's GitHub organization, and the QR code will link to that registry. And this is the basis of the solution. So ERC 7730, it was authored by Ledger initially. It's already around 2 years old. Over time, we gathered more contributors. And it's a very detailed spec, and I will be walking over that with an example. And before the examples, like how does it work in general? So ERC 7730 is an open standard. Anyone can contribute to that, see how it works. The registry is open. Right now, it is on GitHub. It's under the Ethereum namespace, as I said. But over time, we want to decentralize this more, put it on chain, and maybe put it on IPFS. So we are considering these options. But to kick things off very quickly and to be able to come up with a solution, finally, we are just taking a shortcut and using GitHub. And GitHub is useful for PRs, and it's already established collaboration platform. So it is helping us right now, but we are well aware that this is not the end goal. And the next improvement would be on attestation. So right now, the descriptors on GitHub are kind of trusted, but over time, we want to have independent auditors or attesters to be able to attest these descriptors. Okay, like saying this JSON file, this descriptor, correctly explains the contract. So you can say, okay, I'm trusting, so I'm Ledger, I have my attesters, I only trust this key, so you just trust that one. Or you can say, okay, like I trust the security firm X, and they have attested these descriptors, so you just accept those descriptors. And this will be based on Ethereum attestation service, and there is an ongoing EIP, ERC for that. And why does it work? Because I think one of the important features of this, by being an external registry, is that the ERC is backwards compatible. That means we can already solve this problem for existing contracts, because if we had something on chain, that will be only for future contracts. And by having an external registry, we can make it work for existing contracts. And it's expressive that it is you can show and tell much more compared to ABI and NatSpec. And it also comes with special formatting for different types of inputs, such as tokens, dates, and you can also refer to the contents of a transaction, such as the address you're sending to, the amount of ETH you're sending, and so on. These will be much more clear once we go over an example. And the other feature is that it's actually restricted. So we don't actually want something that is too powerful, both in our wallets, like in our software wallets, and also the hardware wallets that are quite limited in computation. So they're intentionally limited devices. So something that is Turing complete wouldn't work for our case. So first, I'll walk over an example. This is a Aave contract on the ClearSigning registry. This says, okay, like this Aave LPv2 contract is deployed on these chains and these addresses. So on mainnet, this is on this address, on different chains, on different addresses, so that once your wallet hits or tries to call this contract, it will know which descriptor to call. And second, we have a metadata section that has metadata information, and we can also declare some variables here, like enums. This will be useful in one of the next examples. And then, of course, the contract name. And then, in this example, we will take the borrow function. So imagine we are trying to borrow using Aave, and these will be the high-level descriptor of that. So let's walk one by one. So imagine this is our call data. Again, this is the 4-byte signature that will call this function, the 4-byte signature, and then the rest of the call data that we can't read is looking like this. And this is the function signature in the descriptor, so that we can, by taking this, we can calculate the 4-byte data. And then there's the intent. So what we are trying to express here is the intent of the user. So what does the user want to do? And it is borrow. So typically, you will show this at the beginning of your transaction view. So you want to say borrow, and then next come the fields. OK, the next one is the amount to borrow. So you show your user borrow, and the amount to borrow is this. So in this case, this is a token amount, because I mentioned we have different formatting options, right? One common one is the token amount. We have ERC20 tokens on Ethereum, and then this tells us to decode the amount information as a token. So this will say, okay, format this as a token amount, and we have these formatters already described in the ERC. So this is a screenshot from the ERC, and this explains how to decode or format the token amount. And then it says, okay, which variable is the amount? The amount is the amount. So this will take the amount as the amount of tokens we want to take, and then it will take some parameters. So one of the parameters here is the token path, which means what is the contract address of this token. And this will let us go to that token, take the decimals, take the the shorthand of the token, such as USDT or DAI, and then this will show us the amount plus the name. And then next we have, for example, the interest rate mode. So Aave has 3 different interest rates, and we already defined it here in the metadata section. Here, exactly, what those correspond to. So for example, if you see a 0, it's none, the 1 is deprecated, and the second, if you see as 2, it's the variable interest rate. So we can say, okay, in the interest rate mode, use the metadata we declared there. And then next one is the debtor. So the label is the debtor. I am highlighting the other part, but the label is debtor. So it will show the value inside the on behalf of. So on behalf of is the path, and on behalf of is the last variable in the function definition. And its format is, for example, here an address name. So this says, okay, like the value you are seeing is an address. And it says, okay, what are the parameters in the second box? It says the type, this will be a EOA, external account. And you can look up this address from your local address book or from ENS. So you can also reverse resolve the ENS name of this address. So this will give you a much more readable information. And then we can also omit fields. For example, the referral code is not too relevant to this step, right? So we can say, okay, like this will be not visible. And at the end, using and plugging everything together, we can go from this raw transaction into something that looks like this. So this is much more relieving and understandable. We also have other types of formats. So we can say, okay, like the data is a call data, so you can decode nested calls inside a multi-call. And then we also have an interpolated intent to show longer strings if you want to have something longer instead of labels one by one. And you can also already try these in the playground we built at clearsigning.sourcify.dev. We have some examples here, and you can also put your own transaction hashes to see how this works at the moment. The playground, for example, is using the SDK we built. So we are, as Sourcify, we're also building an SDK to make it very easy to integrate the whole clear signing experience into wallets and also applications and block explorers. And it works as simple as installing it, giving in the format function, giving the chain ID and the address of the contract, and then just passing the call data, and it will show you the intent, the fields, and the interpolated intent if you want. It also works for EIP 712 type data. So if you want to sign only, the descriptors are typically can be both for call data and can be also for signed data, EIP 712 signed data. The library also handles batch calls for EIP 5792. And of course, you need to have your contract verified. So as I said, Sourcify is a source code verification tool. In case you don't know what source code verification is, it is when you go to Block Explorer, you go to contract page and you see the green check mark and you can read the code, right? That's the whole process. But Sourcify is doing it in a more open and decentralized way. And right now we have almost 32 million contracts and over 260 chains, so we have a quite decent amount of coverage. And more importantly, Sourcify is open source compared to the current other verifiers, and the data is completely open, so you can basically download all of the contract and the whole database and do whatever you want to do. You want to do a data analysis, you want to find a pattern over all contracts deployed, you can do that, and I think this allows a lot of innovation to happen in the EVM security. We also host the biggest 4-byte database. So we took over OpenChain, if you already know that. That means most of the EVM tooling is using Sourcify database to get function signatures. This is a playground for that. We also have an API, so you can look up contracts, you can verify contracts, and we don't have API keys, so you can freely access that and verify contracts. It's supported on Foundry. It's supported on Hardtail. It's supported on Foundry. And besides that, the clear signing thing is already live. So I want to emphasize that this is something that you can already integrate, and it's already live on Ledger. It's live on Embuyer. It's live on WalletChain. So we want to see more wallets integrate clear signing, and this to become a real thing. What are the challenges for clear signing? The main bottleneck is actually the writing of descriptors. So it's it's a manual process, as well as reviewing those descriptors is a quite manual process. So this will take a lot of time. But the nice thing is that if we have a few hundred descriptors, we can already cover maybe 90 to 95% of ongoing transactions. So there's a strong power law in play here, and LLMs can help a lot. And in the future, what I imagine is instead of writing descriptors manually, we will have something like NatSpec++. So you can say, okay, like write these fields when you're writing a contract in the comments, and then it will give out either the compiler or the frameworks can give out the descriptor JSON. But also we need to get projects to write the descriptors, and handling proxies is also not that straightforward, but we are working on solutions for that. So what should you do? What is the call to action? If you are a wallet developer, if you have a block explorer, please integrate ERC7730. You can use our library, but also you can build it out on your own, because if you don't want to have an external dependency, that's also fairly understandable. And you can reach us out anytime if you have any questions about this. If you are an Ethereum app, please submit your descriptor to the registry. And if you are a user, please demand it from your wallet and raise your voice and share it and give us feedback. So thank you for listening, and you can follow Sourcify here and visit Clear Signing and reach out if you have any questions through these channels. Thank you.
All right, thanks. Please let's put our hands together again for him. Do we have any questions? We have an opportunity for one question.
Okay. Otherwise, just you can reach out here.
Okay. Thank you so much. Let's put our hands together for him once again. Our next talk will be from Jan Felix Strass of Zodiac, and still staying on the theme of trust, he will be leading us through beyond multi-sigs, execution controls for humans and machines. I'm pretty much biased for this one since I work for Safe, which this product is built on. So let's put our hands together for Jan.
Yeah, thank you. So this is a talk about control. Who has it? How do we enforce it? And why what we do today is not enough. And I want to start with a confession. 2 weeks ago, on Monday, almost all of the Gnosis Pay safes got backdoored. Most of the user funds got drained with just a public contract call. And the bug was ours. It was in Zodiac. We built the payment rails that sit under every user's credit card safe account. So before anything else, 2 things. I'm sorry to everyone who was affected by it. I mean, you couldn't access your cards, couldn't use your cards when you needed to, you couldn't access your funds for days. This is truly terrible, and I'm sorry for that. And second, to everyone at Gnosis who worked day and night to contain the damage, to bring back the infrastructure, to recover it, and basically care that every user's card goes back online in record time, a huge thank you. This was really an impressive feat under real pressure. And I'm not opening with it to dwell on it. I'm opening with it because this is a talk about security, and if we want to be serious about security, we have to be honest about our failures first. And I'm going to argue that this incident makes the case for what we do at Zodiac stronger, not weaker. So this was the bug. We dropped the static calls success flag, just one line, and it was harmless alone, but in a specific combination with Safe's compatibility fallback handler, it became exploitable. The attacker could craft a transaction payload that made the signature check in Safe revert with the EIP 1271 magic value. And since we didn't check the success flag, we interpreted this revert data as a real return value and actually approved the signature. Both contracts were heavily audited and fine on their own, but became exploitable in combination. Let's go back 1 year, or a bit more than 1 year, to the biggest hack we ever had in crypto, and actually even the biggest heist ever beyond crypto. Bybit. $1.5 billion were stolen, and here nothing broke. The signers signed, the hardware wallets worked, the threshold was met, the Safe contracts worked according to spec. But the Safe web interface got compromised and showed a legit transfer, while the actual payload was swapping the Safe's master copy, basically replacing the implementation and taking full control of the Safe. HSMs, MPCs, TEEs, hardware wallets, multisigs, all our standard defenses are designed to protect the key, but this attack never needed the key. It compromised what the signers saw, and basically any centrally managed system, like an off-chain policy engine, can be compromised the same way. Can be corrupted the same way. And if you notice, the hardware wallets were not corrupted. They actually showed the real malicious payload. So why didn't the signers catch it? 2 reasons. One is repetition, like approves the same kind of transfer every day, and signing stops being a decision, but starts to become a reflex. You just stop reading and hit approve. This is just how humans work, unfortunately, and attackers count on that. And 2, even if the signers had carefully checked on their devices, the devices, they don't really show them what they're signing. They basically show raw hex data, and no human can make sense of that. With initiatives such as clear signing, we are making real improvements here, but still, also if the transaction shows up fully decoded on your device, it is asking a lot from signers if calls become more complex. Like a malicious call can sit in a huge multi-send with harmless calls, buried deeply within nested calls, so it's really hard still, also with decoded call data, to check for every transaction if it does exactly what you want. So if you can't count on a human at the time of signing to catch a bad transaction, not with more care, not with better hardware, what does it mean? It means that the safeguard can't live at the signature level. It has to live somewhere where it holds, no matter what the signers saw. 2 different hacks. In ours, our on-chain code had a bug. In Bybit's case, the chain was fine, but everything above it failed. But these are opposite failure points, but the same conclusion. The only place where you can enforce intent is the chain itself. The signers can be tricked, the interfaces can be compromised, the bound on chain cannot. And our implementation was, our bug was in the implementation and not in the principle. A smart contract bug is the kind of bug you can fix. Like you can actually close it. You fix it once, forever. But with something like Bybit, it's much harder to fix because there's lots of people and systems and off-chain systems involved that have to play together and get it right every single time. So the real question, if a valid signature can authorize the wrong thing, how should we be doing the authorizing? Today, control means trusting who is allowed to sign. You approve transactions one at a time, and a valid signature counts as authorization. And Bybit is what that costs. So let's stop authorizing by signature and start authorizing by policy. You define upfront what's allowed to happen, which action, which recipients, within which limits, and the chain enforces it. So now it doesn't matter if the signers were tricked. If the action isn't in the policy, the chain will reject it. And we no longer have to unlock full root access for every little routine action. None of this is new in principle. It has been true basically since the first multisig. But what is new is the pressure. The model we've leaned on, trust whoever signs is breaking. Like a 3 out of 5 is perfectly fine for a small team of founders. It does not scale to an institution. Institutions, and they carry regulatory burdens that must be enforced and not just be promised. And the stablecoin boom is bringing a lot of these institutions on chain. And we have to earn their trust. And for that, we have to build security together. It's an ambitious and collaborative effort. But the work that we put in on the smart contract layer, it compounds for the whole ecosystem. While any vendor's policy engine is basically a band-aid. It doesn't move the foundation forward. Also, in the future, agents will be how most people are using or will be using crypto. You say what you want, the AI turns your intent into an executable transaction and sends it. And it already works really well. But the blocker for serious capital is trust, because you know that models, they hallucinate, they drift, they can get prompt injected. So how do we fix it? We fix it the same way we fix it for an institution. We define the policies and we let the chain enforce them. So a confused or hijacked agent simply can't move value outside of the rules. Humans or machines, same problem basically, same answer. So this may seem like I'm theorizing a lot, so let's look at how actually money gets lost nowadays. These are the hacks of this year. There have been a lot of them. I plotted all of those that I could verify. Bubbles are sized by dollars lost, and 2 big ones in April stand out. Drift and Kelp DAO, and in each almost $30 million were lost. At Drift, they social engineered the Security Council into pre-approving a malicious transaction payload. And at Kelp DAO, they compromised an RPC node that fed some spoofed chain state to a single verified or single trusted verifier, and that verifier then waved through a malicious message. Both are operational failures, not clever code exploits. So the question is, how do you put the operations themselves under control? And Zodiac is our answer to that. The move is to take the operating rules you already have, but instead of putting them into some policy docs and trusting people to read these and follow them, you turn them into guarantees that the chain enforces, right on top of the safes that you already own. And it comes down to 3 building blocks. One is the multi-sig threshold you already know, N out of M signers. Second, a delay module, which lets you put sensitive actions behind a time lock, giving you a window to react. And third, roles, which let you give scoped permissions to pin down exactly which actions, which limits, and which recipients. And you combine these 3 building blocks to express specific controls. So let me run you through a couple of patterns that you can build with Zodiac. For example, for routine payments, you can have a single operator that acts through a scoped role. only allowed recipients, only within a monthly cap. So the routine action no longer drags every other signer into every single approval. Meanwhile, for admin operations, such as updating the permissions themselves, you can route these through a delay module. With a 24-hour time lock, this gives you a window to react, ensure that the transaction actually does what you expect it to, veto if you need to, so you have some time before the changes actually take effect. You can have tiered approvals. The full 4 out of 5 multisig governs high-risk actions, while a lighter 2 out of 5 plugs into a role scoped to a set of low-risk actions. Let me make this more concrete. So here's what a role to make on-chain payroll can look like. You set it up once in our app, and it can execute exactly one action, transfer USDC. And we set it to a total of up to 120,000 a month. Then we set a recipients allow list to just 12 addresses of all our employees. And we assign the roles to our HR reps. And now they can each use that role to trigger payments, salary payments, without asking anyone else for approval. So let's watch a payment go through. Our HR rep goes to pay a salary and fat fingers 2 extra zeros. She hits send, and the chain just rejects it with an allowance exceeded error. Nobody had to catch the mistake on their ledger. Nobody had to count zeros, check decimals. The Zodiac on-chain guardrail caught it. And the same idea stops Bybit. Like, you can restrict treasury rebalancing operations to a list of your internal vaults, and a malicious transfer just basically has nowhere to go. So now we remove the extra zero, hit send, the send goes straight through, nobody has to review the call data or sign the transaction. And this matters beyond convenience, because routine payroll now runs efficiently. There's no signing ritual to go numb to. A mistake or a malicious transaction will just be caught by the on-chain guardrails. We just watched a person use that role, but notice we no longer have to trust who signs a transaction, or even if that who is a person at all. So with the right permissions in place, we might as well hand payroll to an AI agent with a prompt such as, do June's payroll. Joe took 2 weeks unpaid leave, reimbursed Susie $1,500. Alice moved up a salary band. We hit send. The agent can pull in all the context it needs. It figures out all the transfer transactions that we need to happen to make this month's payroll. And if it misreads, hallucinates, or even gets prompt injected into trying something crazy, it still can't exceed the budget, and it still can't pay anyone off the list. So we will always be able to recover from such mistakes. Same machinery basically as before, just pointed at a machine, and this is finally how you can hand your agents real money. Our own hack, Bybit, the whole wave of hacks caused by poor operational security, the institutions, the agents, it all points to one shift. We need to stop trusting whoever signs and instead enforce what's allowed. And we need to do that on-chain, because that's the only place that can't be tricked or circumvented. And when it has a bug like ours, that's the kind of bug you can fix once and for good. And open, because closed isn't safer. A vendor's policy engine, like a closed source one, can be compromised just like the safe interface was. And hiding your sources doesn't really protect you. I mean, you don't hide them like you would hide a production secret. You have checked out to plenty of developers' machines. With leaks and AI reading everything, you basically have to assume that your sources are already out there. And open is actually the only model where independent defenders, white hats, read the same code that the attackers do. Imagine the Ethereum Foundation participating in Project Glasswing and running frontier security tooling across the entire deployed smart contract surface, like treating Ethereum like one global product, because that's where composition bugs like ours hide. I think that is how we harden security for DeFi together. Yeah, that's basically the end of my talk. We just launched the Zodiac app. It lets you configure policies on top of your existing safes, no code required. So give it a try, please. Go to zodiac.eco and come talk to me. Reach out. That's my Telegram, Twitter handle. And yeah, reach out because we really want to help everyone, every team, every organization to operate on-chain safely and securely. Thank you.
All right, we have space for just one question. So, show of hands. Okay, we have someone. Yeah.
Hello, I've got a dumb question for you. Those three blocks you were talking about, those three basic blocks of security capability or defense, the delay thing gives my stomach the most turn. Because like as a non-crypto guy, I see that and I see like that just delays, like someone has to look at that later, right? Like, or someone has to, like, to me that's like the same thing as just like kicking the can down the road. Can you explain like the risks and like your view on why is delay not just like a weak mechanism?
Yes, you're touching on a very crucial point here. A delay is worth nothing if nobody basically watches what's going on. So basically the moment something is enqueued, you really need to have monitoring in place so that people notice and actually review. But the point that it delivers is that it locks in the actual transaction on the on-chain state. And this is kind of the state that everybody can trust. This is the trusted surface. What I mentioned, it can't be circumvented. And you can look at that state from like a diverse set of interfaces. So you can use block explorers, safe, transaction. You can use every app to basically inspect what was locked in and simulate it and then build more and more confidence until it will actually be triggered.
So there should be like a policy attached to it, like someone needs to actually like do that stuff that you just said. Right. Otherwise it's pointless, right?
Right. You still need off-chain systems to make sense of what's happening on-chain, that's for sure. But I think our message is control needs to be enforced on-chain, and then you have diverse clients that basically let you make sense of what's going on-chain.
All right, let's give it up for Jan Felix. Thank you so much. Every contract, all the protocols that run on chain that move billions of dollars, most of it started live as Solidity. Our next speaker, Jakob, works on the compiler itself. And since Solidity just turned 11, he's here to give us a preview of what that future looks like. Let's give it up for Jakob.
Hello, everyone. I'm Jacob. I think I've been to all DappCons, but this is actually the first time I'm speaking at one, so thank you for finally having me. Today I'm going to talk a little bit about what we're doing at Solidity and what's next. So I wrote my first smart contract in 2015. I don't know if you can read it, but it's the one on the, some of it is here on the right, and the language looks fairly similar still. Of course, it has changed, but yeah, the tooling back then was almost non-existent. I think we used LS0, if anyone remembers this, to deploy the contracts. It was pretty terrible. Since then, I've done a bunch of things in Ethereum. My whole professional life has been contributing to Ethereum. And now I'm the DevRel at the Argo Collective, and we are, I'm contributor to the Argo Collective, and I'm the DevRel for Solidity. Solidity has been in production for 11 years, and we had the last release was in April. It was the 0835. And as I mentioned, it's maintained and developed by the Argo Collective and has been since 2025. But the people working on Solidity in the Argo Collective all used to work in the Ethereum Foundation. So it's the same team, but we are now a separate entity that works on Solidity amongst a couple of other projects such as Sourcify, Fey, HEVM, ACT, and FDebug. So a little bit about what hurts in the language. We recently had our, or not so recently, but we had our results from the developer survey from 25, and the biggest pain points that people point out is the stack too deep, and I did some cross-referencing on some of the numbers, and like the more people self-proclaim to be experts, the more they experience this as a pain point, and have been doing this for some years. So it is definitely something that should be addressed and that we are addressing. And how we do this is currently with, okay, I'll go back. Like, so what is in the 0835 release is, one of them is we have the first comp time built-in. So that's a step in the direction of having more comp time built-ins. And this will also carry over to like future work that we'll be doing on core Solidity that I'll talk a little bit more about later. Then we have the experimental flag that we introduced, and this experimental flag means that we now have all the experimental features that we can have as part of the language, but they are, like, you should not use them. They will break, they will change. And the biggest feature that we added under the experimental flag is via SSA CFG, which is what will be solving stack too deep, and it will also eventually speed up compile times. So how does this work? I'm not going to go too much in depth with it. We did another presentation on Monday, my colleague Moritz, where he goes in depth with this. But yeah, as I said, it's the #1 complaint. At its root, you could argue that it's an issue with the EVM and not with the Solidity. I'm not going to go too much into taking sides here, but what we are doing to fix it is the SSA CFG code gen that will do memory spilling, and through that allow to have more items in the stack, or rather same amount of, but yeah, we do have memory spilling, and we target that for basically out of the Q2. I believe that we have it in the develop branch, but not yet in a release. And then what else is going on is the EIP 8024, which introduces DApp-in, swap-in, and exchange opcodes that basically gives access to more items in the stack. So instead of the 16 that you currently can access, you should have access to something like 272 items. And it is not just proposed for Amsterdam, I believe it is also scheduled for inclusion. But you can only patch your way out of so many things. And as I mentioned, Solidity as a language is 11 years old, and back when it was being designed, maybe 13 years ago, we had no idea, or people had no idea how we were actually going to use Solidity and how we would write smart contracts. So yeah, a lot has changed in the programming language landscape since then, which is why we are also working on what we call core Solidity, which is a redesigned smart contract language that still uses the same backend as classic Solidity, but probably looks more like what you'd expect a modern smart contract language to look like in 2026. Here's a small example of a classic and a core implementation of a payment handler, where you can see some of the features of core Solidity versus classic. We have a struct called payment that has different values that can kind of be used to identify a payment type, but there's not really any way to guarantee what a payment struct actually holds. So we have to have all these if statements to figure out which type it is, and then we can do stuff based on that. And for some reason, we also have to return 0 because that's, like if nothing matches, we have to return 0 because we have to return something. And if we add in a new type, like ESE 1155, there's also nothing in the compiler telling us that now we are not dealing with this case any longer. Whereas in core, we will have ADTs and pattern matching, which makes this specific case quite trivial. We define the 3 different types of payment, and then we pattern match on the type. And if we were to add in then an ERC 1155 payment type, the compiler would warn us everywhere that we are not handling this case, so we would not even be allowed to compile it, and we are forced to handle all cases, which I think is pretty amazing, and I think it will help or solve quite a lot of like bugs that you'd otherwise only find after deployment maybe or later on. So it can save you a lot of time, and it makes it harder to make mistakes, which I think is something we should always strive for, because people will do or will make mistakes, but we should make it as hard as possible for them to make the mistakes. So that is some of the thinking that goes into designing this language. Some of the, this is basically what I said here, that like if you miss a specific case, the compiler will tell you and kind of point you in the direction to where to fix it. And this pattern matching also comes at 0 added runtime cost. You could write the same thing in a switch statement in Joule. And basically all wrapper types are erased. So you don't pay anything extra for this. It all is handled during compile time. We also have generics. So right now I think it's like 380 different handwritten functions for lock in Forge standard library. And in core, you could handle this with one generic function per arity. So this will also be more elegant, easier to do. And yeah, again, no additional runtime cost for this. It's handled during compile time. Quickly running over some of the other things that we will have in core. The biggest thing that we get a little bit of pushback on is that we are removing inheritance as you know it. So we'll have to do reuse through traits and composition mechanisms. You have first-class functions and closures and type inference almost everywhere. And again, we'll have comp time evaluation, as I mentioned, used more frequently in the language. And the first step was in ESE 7201 comp time that I mentioned earlier. And okay, it's a little bit small, but this shows which other core Solidity features that people want. They want better error handling. You get that from the pattern matching. They want better delegate call. That's basically what you could do from the composition. And what powers core Solidity? Underneath it all, we have a small language called Sail, which allows for some pretty nice things, I would say. So Sail consists of 8 primitives and 1 type. And right now in classic Solidity, we don't have a standard library. So every time we want to have something like ABI encode, we have to add it in the compiler and touch parts of the code base that are quite critical. And even the smallest mistake could have pretty bad consequences. So instead, we are designing core Solidity to be as small a core language as possible, and then have a standard library on top of it that is separate from the compiler itself, so that people can also define these things, and we can have a community process in place for figuring out what we should have in the standard library. So yeah, it will be easier to read and audit and debug the standard library. You can actually see what's going on instead of reading thousands and thousands of lines of C++ code. And as I mentioned, I think the fact that we can split or separate the language from the compiler also means that we can have two different processes and we can move faster with implementing new features to the language without having to make a new release of the compiler. And you can more or less, basically if you disable the standard library, you just have typed EUL left, which I think is quite powerful. And as I said, the language is small, hopefully small enough that it will not be too difficult to formally verify it, and it is something that we are planning on doing as well. So what is the current state of core Solidity, and what's next? We have recently had quite a lot of contributions. One is that we had a former Solidity team member implement the beacon chain deposit contract, so porting that and writing it in core Solidity, and from that we had a lot of issues opened and PRs merged that kind of make the language more pleasant to use. I would say that the syntax you've seen so far, it's not something that's set in stone, it's developing and it will be changing. And we also had a multisig implemented in core Solidity, which is quite cool because in this code example you can really see some of how the state mesh, like how you can easily represent like the different states of a transaction life cycle, so to speak, in a multisig with the pattern matching and different like kind of a state machine there. Then another external contributor implemented Uniswap v2 pools and provided us with a bunch of nice feedback in the forum. So that makes me happy, and also the team, of course. But it's always nice to get early feedback from people who use your language and who have opinions on it. We recently also released a blog post on the idea of like pattern matching and how it will work in core Solidity, because it will be a new concept for normal Solidity developers. They might not know, or at least are not familiar with using pattern matching in their daily day. We also have recently the first version of the module system that landed, and as I mentioned, the stuff that comes with the experimental flag in the latest release will also carry over to the work that it will be relevant for core Solidity as well, since we use the same backend, which I think is also an important thing to know. It's not like we're doing everything all over again. We are reusing as much as we can that makes sense, and we do have a pretty battle-tested backend for Solidity, so would definitely make sense to reuse. You can try it out. It's possible to write contracts and compile contracts. Please don't use them for anything production-wise. That would be unwise because there are bugs. But we would love to hear your experiences and any feedback that you might have. And yeah, as I said, try it out. You can do that in the Solcore repository. We are also working on having a playground, like a browser playground, so you don't have to install Haskell and whatnot to actually get it going. Now I mentioned Haskell. That's the language we are currently using for like designing the language, but we will be using a different language for the actual production implementation. We are starting to design the standard library. If you have opinions or ideas or feedback for what should be in there, please reach out. I'd love to hear what you think is important to have in there. We are not going to have a production-ready compiler for this in 2026, but we do hope to have at least something like an alpha version of the production implementation before the end of the year, but no promises. And yeah, all feedback is welcome in the Solidity forum. I think that's all I have today. Please reach out or come find me after the talk if you have any questions or feedback. I would love to hear what your thoughts are on core Solidity. I think that's all. Thank you for listening.
Thank you very much. Please, do we have any questions from the audience? I think we have time.
One in the middle.
We have one in the middle. Do I see any more hands up?
So you said like stack too deep is pain, right? And why reading external contract storage is not able to read is not a pain? Why we should not have like ext s load opcode? External storage load opcode.
Why we should have it or not have it?
Why we should not have it, because we don't have it, right?
Yeah.
I'm able to read storage only of my contract, but not external one. And if it doesn't expose some view function, right, for specific storage slot I'm interested in, then it's not reachable from the mine, right? So.
But is that not an EVM specific question and not
Yeah,
like?
it's EVM opcode. I'm curious why we don't have it.
Me too. We don't really have, we don't, like we give input on ideas to change the EVM as long as they would be relevant for the Solidity language.
I mean,
but
from time to time, someone adds new opcodes to EVM, right?
yeah, of course they do. But I mean, like, I cannot really reply or answer why it's not there, because we are not the people making decisions for the EVM, unfortunately.
Okay, cool.
Is there time for one more, or?
Do we have any more questions?
Is there more?
No?
Perfect.
Thank you so much. Let's put our hands together for Jacob. We are almost there. We've covered signing, control, and the language that it all runs on. Our next speaker is democratizing and decentralizing something bigger than money itself. Please let's put our hands together for Jody as he walks us through enabling open and verifiable democratic participation. Please let's put our hands together.
Thank you. Okay. Hi everyone, this is Jordi from the Bogdani project, and today I want to share you what we have been doing towards strengthening democracy and how we use decentralized technologies for creating a voting system that is transparent, verifiable, and much better than the current voting systems, digital voting systems. So first of all, let me put you in context. We are in Catalonia in the 1st of October of 2017. And the Catalan civil society decided that they wanted to vote if they wanted to be part of the Spanish state or they want to form an independent state. So everything pretty normal. In a pacific way, they try to vote. And this happened, basically. Sorry for the images. But what happened is that the Spanish central government sent the military police for stopping people to not let them vote freely. So basically, we have images like this, basically the police beating people for voting in a democratic country in the 21st century. This is crazy, and this is not what I learned at school. And yeah, at that point, we thought we need to build some kind of system to allow this to never happen again. So also at the same time, we realized that democracy is at risk back then and nowadays. So we are using obsolete democratic infrastructure. There's a clear declining in trust in the institutions, meaning that people, especially younger generations, participate less and they have less engagement. And there are also more other problems, especially related to technology. One of the first cases we can refer is the Cambridge Analytica case, where we had some private companies that were creating and using these new technologies like social media for spreading misinformation and manipulating the public opinion. Then, as I showed you in the later images, in the last images, we saw that a nation state can coerce and intimidate people for not voting. And then there's also a biggest risk, I think, which is the nation states have the monopoly of organizing truly democratic elections. They are the only ones that have the census, and they are the only ones that have the resources for creating a proper election with all the democratic guarantees. So yeah, based on that, we started the Bogdani project, whose vision is to improve democratic health and promote participatory governance using decentralized and open source technologies. So we wanted to create a system for the bright and the dark times. A digital voting system, because of course we cannot solve all the democracy problems, and we need to focus on one, and we decided that creating a decentralized and censorship-resistant voting system was the thing. So the system should be universally verifiable, meaning that since you cast a vote, since the tally is done, you can verify that your vote has not been altered, and also that the tally was done properly. Then the system, of course, should be anonymous. We must protect voters' privacy and even the organizer privacy. This system should be also flexible, meaning that it meets most of the governance requirements of different organizations and adapts also to any identity system. In an ideal world, we would have shared public identity system, which is shared by everyone, but this is not what's happening. So each state has their own system. Even inside nation states, we have different identification systems. Then the system should also be scalable, meaning that we want to reach nation-state elections, and efficient. Also needs to be affordable, because we cannot make people pay for voting, and someone needs to cover this cost. For this, we wanted to use the economies of scale using a shared infrastructure. The system should also be anti-coercion, ensuring free and fair participation, safeguarding against collusion and external pressures, like the ones that we showed. And it also needs to be neutral and unstoppable. Why? Because we don't want anyone, even the organizer of the election, to be able to stop the voting if the things are not going as they want. And for this, we used Ethereum, because we think it's the best community, the best technology, and it has the best security guarantees. So a little bit of the journey, of the timeline. We started in 2017. We forked Zcash because of their privacy guarantees, and basically we were sending Zcash transactions in a form of votes. The problem with that is that the Zcash ecosystem is not programmable enough, and we didn't get the flexibility we wanted. We also developed a native mobile application where you can follow some organizations, vote, and so on, and read some news. But yeah, at that point you realize that people were not willing to download an application that they just use, for example, 3, 4, 5 times a year. It's not like a social media application. Then we transitioned to an Ethereum virtual machine approach using a proof of authority network, where the nodes were distributed among universities, public bodies, and also individuals. And we did this because in 2018 Ethereum was not scalable enough, and we also lacked some of the cryptographic primitives that allowed us to create such a system. This experiment went well, but not that bad. And because of that, in 2019, we decided to switch to a Tendermint-based approach. For those who don't know, Tendermint is the base layer of the Cosmos ecosystem. This technology allows you to just focus on the application layer, so we didn't need to care about the peer-to-peer layer or the consensus layer. So basically, we built a Golang state machine on top of Tendermint that allowed us to have the scalability that we wanted, and also to implement our own cryptographic primitive, of course, based on the standards and so on. And we also switched to a web application, because in order to make it accessible, the best way is to just have a link that you can put it on a browser, and everyone has a browser nowadays. And in 2024, we reevaluated the Ethereum ecosystem, and thanks to advancements in applied cryptography and also a lot of the hard work that has been done through scalability, we decided to start DaVinci, which is a new and a better version of the protocol that we had built on top of Tendermint. So what's DaVinci? So DaVinci stands for Decentralized Autonomous Voter Integrity Network with Cryptographic Inference. Let me segment this a bit. So it's decentralized and autonomous, because the protocol can run autonomously. So there's no central party or coordinator, and it uses EVM contracts as a coordination layer and a purpose-specific ZK rollup. Then it's also a vote integrity network, because there's an incentivized network of sequencers that accumulate, verify, re-encrypt, and aggregates the votes cast by the users. And finally, we call that this protocol has a cryptographic inference, because the network itself, by mathematical meanings, derive conclusions, so the tally, exclusively from cryptographic primitives. And everything is fully backed by zero-knowledge proofs. How it works? OK. So in one point, we have the votes, then the voters, the sequencers, and Ethereum. So basically, what happens is an organizer wants to organize an election, so it goes to what we call the process registry. It creates the voting process with all the data the voting process should have. And then there are this network of sequences that are listening to this smart contract. Then they fetch the information, and they store it. All the voting process is stored in a form of a Merkle tree, all the data and so on. And then when the voting window opens, the voters can start voting. Of course, before that, the sequences need to generate an encryption key for the voter. And what they do is to do a multi-party computation for generating this key. Then the key is published, and the voters can start sending the votes. The voters on the client side, they encrypt the votes using homomorphic encryption. They prove their eligibility using also a ZK SNARK circuit, and they authenticate using standard Ethereum signatures. They can override the votes as many times as they need. This is one form of lowering the pressure if they are being coerced. And then when it happens on the sequencer side, let's say we have the vote on the voter side, then the voter can send the vote to any of the sequencers, and then the sequencers, what they do is to verify that the vote is running well, and they can re-encrypt, and then they re-encrypt the votes. That way we remove the receipt from the voter. Then they recursively aggregate these votes, and they update an Ethereum, the Ethereum state root hash that is stored on the Ethereum network. For that specific election. When it happens, when the voting finishes, basically is that they talk to each other, they reconstruct the key, and they compute the results. Then the results also pass through a ZK circuit, and we can be sure that the results were counted correctly. All the information, not the public information, but the cryptographic traces are stored on Ethereum, and then everyone can reproduce the election and check that everything is fine. Then we have the protocol, but then we need something that is usable for the people. And then we enter to the front end and the voter experience. The voting experience should be something that is easy to use, that should work on any device, and it should be user-centric. Easy to use, I mean, my grandmother should be able to vote, because everyone should be able to vote. It's a democratic process. And I don't expect my grandmother to have a hardware wallet. So we need to find a way to circumvent these technical stoppers. And for example, in the images, you can see that one of the methods that we use, for example, is to just send a QR code with a link and an embedded private key on the code. This is sent by postal mail, and then even if you don't have a mobile phone, you can go to a public station and vote. Then, as I said, it should work on any device, so we just use a browser, and all the UI that we created is super Web2, it's super user-centric. The voter doesn't need to know that he's using blockchain or any kind of this cryptographic technology. How it looks like for the voter. Basically, when you open the link for the voting, you can receive this link by postal mail, by email, by SMS, whatever, and then you see this image. Basically, you have the questions, the title of the process, you can also embed videos, whatever you want. Then you click on identify, and then the authentication is up to the organizer, so we are flexible in that terms. We can use electronic passports, we can integrate databases, we can use even CSV files, And in this case, for example, I'm just using my email and my name. Then we enabled a two-factor authentication mechanism, so I will receive a two-factor code on my email, and then I'll be authenticated. Then I will just select my question, my answer, sorry, and I will be able to see that I'm voting for this, and then I will confirm my vote. The vote will be sent to the network of sequencers, and finally I will get a unique identifier that later I can use for verifying that my vote was not altered and was actually counted. This is the UI for the organizer point of view. We have all the voting processes that we created. We have our member base, the settings, and if you want to create a voting process, we have some templates like, for example, annual general meeting, election, participatory budgeting. We can set the process title. We can even attach a video if you want to have some live video. We can add the description. And then we support any kind of voting method. So we can have single choice, multi-choice, quadratic voting, any kind of thing that you can imagine. Then you set the basic configuration, so start time and end time, some extra configuration if you want the results to be hidden until the end, if you want live results, and then you select the census based on some filters that you can apply on the member base. Cool thing about this is that we have been serving real-world organizations since 4 to 5 years ago. Here you have the different verticals. We are serving public administrators like the Barcelona City Hall, also super cool. The images that you saw with the QR codes was for the municipality of Bellpuig that held the first legally binding digital referendum in Spain. We also help a lot unions and professional bodies like the official Industrial Engineer College in Catalonia. We also helping membership associations, political parties, for example, New Belarus, which is the opposition of the Belarus government in exile. We also helping sport clubs and entertainment like the Football Club Barcelona. And then given that we have the protocol and then the UI, of course, we have the integrators part that they can use an SDK and API that we have available for integrating the base technology, the base voting technology on their applications. So I would like to showcase 3 real nice use cases that we had during the past year. The first one was 3 weeks ago, where the teachers in Catalonia, more than 100,000 teachers, were on a strike for saving public education. They wanted better classrooms, less ratio of students per classroom, and they wanted better salaries because, you know, inflation and so on. And basically what happened is that the unions had a meeting with the government and they created some kind of pre-agreement. But then the teachers wanted to decide to do a referendum about this pre-agreement. We've been talking to them and we set up this voting for them. It was amazing. It lasted for 4 days, and the only thing that they needed to vote, it was just their official teacher email. So basically, they put their email, then they received a two-factor authentication code in their email, and they were able to vote, because we are sure that just one teacher will have just one email. The results were amazing, 61% turnout, more than 6,000 votes cast. And nobody contested the results because we have all the cryptographic traces. Nobody can say, oh, I voted twice, the results are not correct, and all these kind of things. So, well, as we say, legitimacy at scale without relying on blind trust, like using Google Forms or things like that. Second one, almost 2 months ago, we helped the Belarusian opposition for doing an election where this democratic election could not be safely happened in Belarusian territory because the voters are dispersed, there's a lot of political pressure, people are in exile, and there were like a lot of attempts to disrupt participations. It was crazy because I think that the infrastructure was basically attacked by the nation state because we had a big DDoS attack. We went down, not the protocol, but the front end and the API that we are using. We went down for 20 minutes, but well, hopefully we went able to recover. And also the nice thing about this is that the voters used a Belarusian self-sovereign identity that was created by them for authenticating themselves. So in that case, I think the thing to remark here is that the democratic infrastructure must work when the democracy itself is attacked. And the third one, which is also pretty amazing, we have a political party in Spain called Esquerra Republicana, which basically had some key votes for investing, which today is the president of the Generalitat of Catalonia, which is the government of Catalonia, and they wanted to let their member base decide if they wanted so. So basically, they set up a referendum for investing or not the current president of Catalonia, and this indirectly supported the continuity of the Spanish prime minister. So it was internal democracy with real political power that required verifiable legitimacy. It was super nice because we had almost 80% of turnout, and there were 20 parliamentary positions at stake. So as you can see, we can leverage Web3 technology. We can create this kind of sanctuary technology, but what we need to do is to make it available to the people. Even sometimes, of course, there's some trade-off. We don't have hardware wallets, but well, if we can create a system that is better than the system that we have now, why not doing so? At some point, we will get there. And that's it. Dankeschön. Thank you for having me here.
All right. Do we have any questions for Jody? We'll be able to take just one question. Yes, just in front.
Thank you. Amazing. I'm not sure if I did understand. Do you support quadratic voting?
Yeah. Yeah. What we have is a thing called the ballot protocol, which is basically a way of expressing the way you interpret the results of an election, which is basically a matrix where you will be able to say, for example, for this specific voting, the results needs to be counted like this. And this is fully supported. So it's just a matrix, it's super extensible, and we support any kind of voting you can imagine. Thank you.
All right, let's put our hands together for Jody. Thank you very much.
Thank you.
We are now at the close. And to wrap it all up, Gnosis has been hosting DappCon since 2018, 8 years ago when it first started. And so there's no better person to close this year's edition of DappCon than Stefan George, the co-founder and CTO of Gnosis. Let's put our hands together for Stefan.
Yeah, thank you all for coming to DappCon. This was the 8th edition of DappCon, and I think I need a ticker. Excuse me. 1 second. Do we have a ticker? Anyways, thank you. This was the 8th edition of DappCon, and thank you all for coming. Also, thank you for all the sponsors that are supporting us. Like some are new, some have been supporting us for a while, and yeah, thank you for everyone who has been supporting this event. I especially would like to thank Aman, who has been organizing it in the background together with many others. So let's give a round of applause to Aman. Thank you. I think you did a great job, and of course there were many other people also involved too. Thank you for everyone who helped to put this event together. I also would like to thank many people, speakers, and the audience who have been part of this journey for a long time. Specifically, I want to mention one person who has been very loyal to us over the years. So Lev Terrace has been at every single DappCon as a speaker, and has been a very loyal friend. So thank you, Lev Terrace. I'm happy that you were always here with us. And yeah, this is a closing speech, and a closing speech is always a good opportunity to kind of look back and then see kind of where everything started and where we are right now. And actually Berlin, many of you probably know, but this is actually one of the cities where Ethereum started. And actually, Efteris is even on this picture. This is the office where, the first Ethereum office, actually not far away from here in Kreuzberg. And it is also the office where actually Gnosis also started and worked from. So even me personally, I spent quite a lot of time in this office working next to Christian, who basically invented or developed Solidity. And that was a very, obviously very early days. We're talking about 2014 and 2015, when Ethereum was still at the very early beginning. And I think everyone who was in this office was united by the idea, yeah, we have to build something that's revolutionary. We have the opportunity, we have a new technology that allows us to disrupt the status quo, something that's decentralized, that allows permissionless innovation. It's censorship resistant. We called it the world computer because it's globally accessible and it has a globally shared state. And it should allow us to build all kinds of new businesses without centralized intermediaries. And people came up with all kinds of crazy ideas. And Joe Lubin was happy to fund all kinds of crazy ideas, including Gnosis. And yeah, it was much less about, yeah, we have to create an asset and we have to maximize the token price, or we have to become the fastest blockchain. It was really very idealistically driven. And I think this lasted for quite a while. I would say there was kind of the cypherpunk era of Ethereum from 2013 to 2017, where people were very idealistically motivated. And I think then the ICO craziness started. Also, the Gnosis ICO actually took place in 2017. And a lot of money was fueled into the ecosystem, which I think on the one hand was great because it allowed us to build everything and even do things like DappCon. But of course, also it attracted a very different audience. It was primarily not driven by ideals, but rather by speculation. And I think this kind of bursted in 2022. When Terra Luna exploded, FTX exploded, Three Arrows Capital lost a lot of money. And I think since then, crypto has slowly been recovering. But if you ask, what is the public perception, then it's not really a revolutionary movement anymore that's trying to transform society. It is rather seen as something niche, potentially very important. And it's kind of a new asset class, but it's a bit unclear what will be the long-term significance. And I think the focus has also shifted from yeah, we want to build decentralization, privacy, censorship resistance, and focus on this to okay, how does the institutional adoption look like? What are the financial use cases? And that is kind of driving the discourse around crypto these days. Now, Ethereum was started in 2013 when Vitalik wrote the white paper initially. And of course, crypto itself goes way further, goes a few years further back. And if you look at how has the world actually developed in this time frame, then it's actually quite striking that the world has become a lot more centralized in many ways. And I think here is actually on the left side, you see the share that the top 10 companies in the S&P 500 are as part of the entire index. And you can see this goes back to kind of after World War II, up to now, basically. Now it's probably even higher after the latest listings, which I think are not part of the S&P 500 yet, but at some point probably will be. And yeah, what we see is basically from when Ethereum started, well, about 20% was basically represented by the top 10 companies. Now it's about 40%. So what does that mean? Obviously, it just means that there are very few mega corporations emerging, which obviously means that there are very few parties ultimately that are super relevant to make decisions and kind of, to some extent, act on our behalf, and that obviously have mostly the shareholder interest of their own companies in mind, and not really what we have in mind. And yeah, I think this is also seen by the the wealth gap that there is in the US, but also elsewhere. So what we see is just an increasing disparity between rich and poor, and yeah, centralizing a lot of wealth in the hands of very few people. And Bitcoin is also not really an exception. If you would kind of calculate the Gini coefficient of Bitcoin, then it would be even worse in any of the countries. Simply because the early contributors and the early whales, they own majority of the supply. So wealth is one thing, It's very clear centralization of wealth happening continuously and it's increasing. It's also centralization of power. Like if you think that like democracy is valuable and kind of ideally everyone has a say, that basically democracy peaked in the early 2000s. And since then there has been a steady decline. So this is here like from a non-profit organization called Freedom House. They measure like how many countries have improved versus worsened in terms of global freedom and what are the rights of the individual and the sovereignty that everyone has. And you can see basically since 2005 this has been steadily decreasing, which effectively also just means the power is in the hands of fewer people that can decide. And obviously there's a big risk simply from having power centralized because you depend on very few people and their judgment calls. And I think right now we see it pretty much everywhere that those judgment calls are not always the best. So it looks kind of desperate, but at the same time, I think if you look at, this is not the first time that kind of power and wealth is centralizing in human history. This has happened many, many times, and this has been many, many times disrupted. And most of the times, actually, disruption happened through technology. So we have always a cycle of like, there's centralization, then a new technology arises, it lowers coordination costs, which disperses the power among the individual. Then, of course, new network effects can arise, and that forms new centralization. But my point right now is we are actually at the top of this. Right now, we are kind of moving to top centralization, and the question is, what can we do to kind of disperse this power again? And in my view, we just have to build a technology that allows people to do this. And as you can see here on this table, it's just like some kind of random examples. But just to point out, like, yeah, when Gutenberg developed the printing press, it moved de facto power from the church to readers and publishers because the church back at the time had the monopoly on information because they were the ones writing the books and distributing the information. And that was heavily disrupted by just inventing something as simple as a printing press. Now, we had this innovation obviously also more recently, like the internet being a good example. But I think with the internet, we have already seen that we have kind of gone through the cycle of centralization to new network effects and then new form of concentration in very few companies. And the question is now, what can we do now? And who is basically the Gutenberg of our generation? And in my opinion, this is simply our responsibility, because who else is going to build this? The bigger corporations are not going to do it because they don't have the incentive to do this. And Vitalik recently made a post on Twitter in terms of like what he would like the Ethereum Foundation to focus on, because of course resources are maybe a bit less. And it's important to have a clear focus. And he focused very much on the core principles of what initially, I think, made Ethereum stand out. So building something that is censorship resistant,